designed for scientific Earth imaging, right? So it's not like you said it's like a phone camera, Matthew. It's not like a phone camera.
In the sense that it's a digital sensor, they combine the red, green, blue electronically, and then they send the images through radio waves instead of Wi-Fi.
Yeah,
but his
cool.
speech was
So it's
August
one of those
20.
things where we just kind of have to, it's like a trust me bro type situation where it's like, yeah, we're sending this data and then they'll, like NASA, like Robert Simon or someone like that will get the data and then they'll like transfer this alleged data into an image.
Yeah, my point is
What
that
kind of resolution
Obama wasn't being
capabilities?
inconsistent.
What kind of resolution capabilities and lens size would you even need to capture such things in detail from such distances as claimed?
Depends on the lens and distance. And I don't know.
Yeah, that's what I'm asking.
Super high. I don't know. I think they're like 1,000 by 1,000 pixels, something like that.
Anyway, is there anyone new here? Because we've exhausted the conversations with Matthew over and over. Is there anyone new here that would like to ask a question or speak with us about the topic?
I did watch the optics video that Jen sent me.
Mm-hmm.
Still doesn't make a whole lot of sense.
What doesn't make sense about the optics video?
So it says it cites a bunch of optical science and what have you, and the 0.2 degrees that we can resolve in terms of being able to calculate something at like a various height or distance away from you. So if we apply that to
go ahead, Sam.
if we apply that to the horizon and ships, the maths just doesn't add up.
Okay, so once something moves away from you and the object that you're looking at, say a boat, reduces in angular size, once it gets below 0.019 degrees or something like that, let's call it 0.02 degrees, the human eye can't resolve it anymore. And that's the angular resolution limitation of the human eye. Now, when we're talking about the horizon, right, now the definition of horizon is the apparent location where the sky and the ground meet. Okay, you think the horizon is the leading edge of the sphere, right? Essentially, anything that goes over it is going over the curvature of the Earth, and as it goes beyond that distance limitation, due to the size of the Earth, it would start to become obstructed behind the curvature of the Earth. That would happen at a particular distance out into the ocean. Now, we've got so much evidence that just completely disproves that. But when it comes to, I think you were asking about boats over the horizon or something when you were talking to the other guys. It was in the politics server, wasn't it?
No, it was in here.
It was in here? Yeah, okay.
A little bit ago.
Yeah, I was listening. Okay, cool. Yeah, so, I mean, a ship should start to disappear over the horizon at a certain rate. But, ships will disappear due to angular size most often. I mean, I know that firsthand. Growing up on the east coast of Australia, where we have a lot of cruise ships, growing up like fishing and surfing a lot, we'd sit there and watch like the fishing boats going out, watching the cruise ships go out. And what happens most of the time is they, if you don't have big waves on that day, right, if it's pretty flat swells, then, they'll just kind of get smaller and smaller and smaller. And depending on the visibility, they'll either fade off into the opacity of the atmosphere, or they will just get so small that you just can't see them anymore. Now, if there's ocean swells, obviously they're going to appear like they're disappearing bottom up. As the ship moves away, it gets smaller and smaller, so it's going to slowly disappear behind the ocean swells. But yeah, other than that, I mean, there's very rare situations where you can have certain types of miraging effects that can make something look like it's sinking behind the horizon. But yeah, like there's tons of footage of ships, and then you can just, like, it looks like they disappear. You can still see the horizon, but the ship's gone. And then you zoom back in and you can see the entire ship again. So it's something that we can recreate it on a small scale consistently and make it so on a flat surface, the same thing happens. So it's not exclusive to a globe or anything like that.
Yeah, atmospheric refraction is a thing, obviously. But for ships to disappear off the edge of the horizon at 3 miles away.
It doesn't happen.
Well, yeah, I mean,
It's actually not atmospheric refraction. You'd be referring to terrestrial refraction, and there is a clear difference. So atmospheric refraction is dealing with the apparent displacement of objects outside of the Earth's atmosphere. That's light entering into the atmosphere. Well, versus terrestrial refraction, which would deal with the apparent displacement of objects within the Earth's atmosphere.
Yeah.
And light reflecting off it.
Yeah, fair enough. I've just used the wrong phrase.
Yeah. Regardless, like when we go out and actually test for the geometric horizon, right? It's not at 3 miles we can consistently see magnitudes further. You know, I can show you observations where we're looking over like 21 mile lake, and there's no horizon present over the entire 21 miles, just from 5-foot observation height, where there would have to be a horizon if the Earth was a globe at just 2.7 miles. So, I mean, I bet you can't show me a single observation where a boat starts to go over the horizon at 3 miles and that you can confirm that it's anywhere close to 3 miles.
Well, I did post a picture in the chat of 3 boats at different distances.
Right, but you can see that there's waves, like there's quite big waves there.
Yeah. So,
and we don't know the distance to the boats either.
Well, that's what it says there, nautical miles. It's labelled each boat with a distance.
Okay, so what's the observation height?
About 35 feet, I think.
Okay, how did we? Well, where's the confirmation of the observer height? Like, is this from something?
It is. Let me find it. But yeah, if you plug.
But can you see the big waves? Like.
Yeah. But that.
Okay, and we can see that. Well, just let me say this one thing quickly. Okay, so we can see.
Mean?
Okay, they mean that. Okay, so something. Okay, so if you hold your hand in front of your eyes, right, you can block a giant mountain just with your tiny little hand. Now, that's the same kind of principle that I'm talking about. Because of the way that linear perspective works, we have the, say it's like 1 meter waves, even if it's small waves. Okay, so as the ship moves further away, it reduces in angular size, but the waves are still close to you, right? So something small in the foreground can easily block something big in the background, because the thing that's moving away is constantly reducing in angular size due to perspective. But those ocean swells aren't, right? They're still close to you. And because of the way, as you can see, the water looks like it's ramping upward, right? And that's the way that perspective convergence works, right? The ground ramps up, the sky ramps down, and it meets at a point of convergence due to perspective. So it's going to block anything that goes beyond that convergence point very easily if you have 1 meter waves.
And you would expect to see such big variance between small distances, like shown there.
Small distances, miles difference.
Yeah.
You would expect to see the same thing that you're seeing here, right? So as it moves further away, it's going to reduce in angular size, and it's going to be more and more obstructed.
So
right?
the
Because
thing stopping you from seeing the vast majority of the furthest ship is the fact that the bit that you can't see has reduced to 0.2 angular size.
No, this has nothing to do with the angular resolution limitation right here. Let me give you an example of the angular resolution limitation. 1 second, I got an example here, right? So this one, so you want to try to find one that doesn't have waves to begin with, right? Because whenever I see these from the globe side, there's either massive waves or there's obvious miraging effects every single time. Okay, so I'm going to show you one that doesn't have any obvious miraging effects or any waves, right? And this is a giant boat as well. So it's just uploading now. Right, so this is an example of the angular resolution limitation, right? So you'll see that when he's zoomed out, right, this guy's just standing at the shoreline, so you can see he's, maybe like, let's just say 5 foot, 6 foot, whatever. When he's zoomed out, you can't see the boat anymore, right? Because it's...
Well, the camera.
The viewer can't.
Well, how do you know? All you can see is the camera. Eyes work.
So you think that... Not much differently than the camera, no. Right, so the human eye is like...
If you zoom in all the way out...
It's like a 28, like 30 millimeter lens or something, is kind of how the human eye sees.
What I'm saying is you can't compare the two. All that shows is a camera zooming in and out. If you were stood there and you could say, this is what I see.
Yeah, so what's your point?
You can compare them.
Okay, so we're looking through the optic. Do you realize that eyes are just a different lens, right? So we're just looking through another lens here. So it's the same principle. Okay, so what's the reason you think that we can't see the ship through the camera lens?
Because it's too far away. That doesn't mean that an eye would see the same thing. Okay,
it doesn't matter whether the eye would see it or not. Okay, because we can't see it through the camera lens. Because it's not that it's too far away, it's too small to resolve. Right? Why can't you see a fly when it flies away from you? It's the same thing, right? It's breached that angular resolution limitation and you just can't see it because it's too small. Same with the boat. Right? This isn't like some flat earth argument.
No, yeah, you can't see it, but you also can't see like the bottom of it disappearing off.
Yeah, there's no like this is what happens most often, right? So just if the person's standing there watching the boat go out, right? I was talking to a physicist, bit of a dickhead actually, Professor Phil Bell. I don't know if you know who that is, but an Australian physicist, right? He says that you'd never ever see a ship disappearing bottom up with the naked eye over the curvature of the Earth. You would have to zoom in with some high-end optics to be able to see that. I can probably pull up the screenshot of him saying that to me in my DMs. But we have countless examples of this, right? So like most of these zoom cameras, I forget what the lens is, probably like 20 to 1200 millimeter lens or something like that. Because it's like a fixed lens with like a super zoom.
Do we know how far away that ship was?
Yeah, so all I was trying to show with this one, because we don't have distance markers with this one, so it's a bit hard. We don't have the tracking radar, but I can show you somewhere we do know the distances. Okay, so we don't necessarily need a ship, right? Right, so just a second. Right, so this one we have some oil platforms that we can use as distance markers this time. So yeah, these could, just be considered similar to a ship. All right, so here we have Santa Barbara, California, and we have 2 oil platforms. Platform C is the closer one, 6 miles away, and then Platform Habitat is 10.1 miles away. It's the further one, obviously. So it's a little bit shorter of a platform, and it's like 4 miles further away, so that's why it looks a bit shorter there. So we can see the horizon beyond the oil platforms. Okay, so now we can just do the basic math and work out how far away the horizon should be. Now, the cameraman is 8 foot above the surface of the water. So that means that the horizon should be at 3.46 miles. right? And then luckily we have the distances to the oil platforms, and we can confirm that the horizon is beyond the oil platforms. So here's a great example of the horizon being like many, many, many times further away than where it should be if the Earth's a globe. So that's just a clip from a full high definition video where he shows the entire process of the observation.
Is that no? That's just the GIF, isn't it? Have you got like the?
Yeah, I got the full video. Yep. Sorry, 1 second.
That's right.
Yeah, there's the full video if you want to check that out sometime.
Got it.
So I don't know if you want to watch that now, or if you want, I can show you just another one really quickly.
Yeah, if you want.
Yeah. Right, so this is a lake in Canada. And what the guy's going to do is he just holds the camera as close to the water as possible. He says it's like 3 inches or something like that. Okay, so what we can see in the zoom, right? So he's just holding it with his hand, so it's a little bit shaky, but the actual zoom section is clear enough to see what we're looking at. So what we can see when he zooms in on the right is we can see 2 like rocky peninsulas that are coming out into the water. Now that second peninsula in the distance that you can see in the still shots that are above the GIF, the second one's 13.8 miles away. Okay, so from approximately 3 inches observer height, the horizon should be just over half a mile away. Now, once again, like there's no horizon present at the distance. And then we can see the 13.8 mile peninsula, right? And that should be hidden behind the horizon by about 120 feet. So yeah, there's another example.
How high are those rocks?
Oh, they're very low. It's just like you can actually go there. Like if you have a look at the video, he shows you like exactly where it is, what the name of the lake is. You can go there on Google Earth. You know, I went there on Google Earth, and you can cruise over to that little spot in the lake, and it's just like, you know, it's kind of like a rocky peninsula, so it just goes down and meets with the water. It's not high. You know, maybe like, you know, because it's varying in height, so it's hard to give you a height. You know what I mean? It probably ranges from
Lakes aren't the same as the ocean, though, are they?
Well, according to the globe claims, right, all bodies of water will curve, but you would just have to take the altitude into consideration, and it will make like a tiny, tiny little difference, to the point where they don't even really take it into consideration. So I think this one, I've already looked into this, right? So because someone else said the same thing. So if you have like a body of water at altitude, it just changes the radius value a little bit. So I think this is 500 feet above sea level or something like that. And it changes the radius from like 3959 to like 3959.8 or something like that. So it doesn't really change the overall mathematics to the point where you would need to even worry about it, because like we can see like magnitudes further than you would be able to see. It would just change the horizon distance from like 0.6 miles to like 0.61 miles or something like that.
So yeah, I wasn't thinking of the altitude. I was more thinking of the gravity, which obviously is a problem for you guys anyway, isn't it? But like the ocean is magnitudes heavier than the water in the lake by volume. That's what shapes it.
Yeah, but they don't say that. They say that any body of water will conform to the curvature of the Earth. They don't say that just because it's a lake, then therefore it's not curving along with the curvature rate.
Well, no, they say that water conforms to the gravitational pull towards the center of the Earth, and that's what forms the curvature of the water on the Earth. So it therefore follows that oceans would be totally different to lakes.
I've never heard anyone say that before. Never, like, we've debated, like, physicists, all kinds of people with these observations. No one's ever said that's the case. I don't think you'd be able to. You can. No, it actually isn't, because we have giant lakes as well. It's not like you're going to have a different rate of curvature due to the size of the lake. It's such a huge amount of water. I mean, if you can find me some kind of site, it's interesting because I've never heard anyone say that. So if you can find some kind of something to back up that claim, then definitely happy to have a look at it. But everything that
I haven't heard that either. We Globers typically say that the surface of water conforms to a sphere no matter how big, if it's a swimming pool or a lake or a big lake or the ocean.
Yeah, Matthew's pretty honest with stuff like this. I mean, he's a globe earther and he's a college professor or whatever. So, I mean, yeah, I've never heard anyone say it. When I've been looking up this kind of things, I've never heard that suggested. But it's an interesting suggestion. I get your reasoning.
But I mean, it surely can't. I mean, it's interesting that you say that, Matthew. But how observable is it going to be at a certain point? Obviously, stupid example, glass of water, very, very small gravitational effect on a glass of water compared to an entire ocean.
Yeah, I don't know about a glass of water, but an Olympic swimming pool, 100 meters. I think I figured this out once. The curvature would account for less than the thickness of a piece of paper, so it's not going to be measurable.
On an Olympic swimming pool?
Either Olympic swimming, 100 meters or 100 feet. I can't remember now which number I used.
Yeah. No, I was just checking I heard you correctly. So the largest lake in the world is 78,000 cubic kilometers. Compared to the Pacific Ocean of 714 million cubic kilometers.
Think about this. You could have
magnitude there.
Yeah, but if you drop a bowling ball and a feather in a vacuum, they still fall at the same rate. So I mean, would it really make a difference if you have a swimming pool or a medium-sized lake or a...
Yeah, absolutely. That's how gravity works. It acts based on the weight of the objects interacting with each other. And in a vacuum, there's nothing to interact.
I know that, right? But I think honestly, I don't think any globe earther would agree with you on that point that you made about the curvature being different for a lake or the ocean.
Well, it's just always the way I've understood it. The reason why water curves on the Earth is because of gravity. Therefore, a large body of water would curve more than a small body of water because of the difference in gravitational force. And the only reason a feather drops the same rate as a bowling ball in a vacuum is nothing to do with gravity. It's to do with air resistance. If you drop a large mass and a small mass that have the same air resistance properties on Earth, they will also both drop and hit the ground at the same time. So
it's not biased towards larger or smaller objects. Everything falls at the same rate, whether it be in a vacuum or but you would just calculate the air resistance. It's still falling at the same rate. Right, it's like the
we're not.
Yeah, it's not something heavier. Something. No, we're not. Right, you're talking about the same thing though. It's the same effect. It's being pulled down to the earth, right? The water, and that's what's making it conform. If maybe you can try looking something up about that. I don't think any like respectfully, I don't think any globe earthers would agree with you on that.
But yeah, back to the whole ship horizon maths thing. The bit about that optics video that I started to have a problem with was the angular resolution at 0.02 degrees. When you start to figure that or start to calculate that out with the actual equations, you don't see the same results as you're claiming for the flat Earth model. It's only really possible with curvature.
What do you mean? No, what we claim is what do you think isn't adding up? Right, what we're saying is that a horizon is just an apparent location where the sky and the ground meet, right? Just like the definition says. Okay,
But
so
that
it's
happens at, like, all things being equal. If you say, like completely calm sea, no visibility issues, no atmospheric phenomena, that horizon should happen at that.
Yeah, but there's no evidence.
Right?
I've never seen. Look. I've been looking into this debate, right, for the last 8 years, and I've spoken with thousands of globe earthers, like many thousands. Not one of them has ever been able to show me a single observation where the horizon is at the distance that it should be, right? And especially being able to account for the atmospheric conditions as well, right? Because we always have, some kind of refractive effects taking place. But no one's ever been able to validate the geometric horizon. Like at any time that we go out and try to check for it, we can see way further than what we should be able to. But the horizon moves around, right, as the weather conditions change. Like if you take a time lapse, you'll see the horizon changes distance depending on all sorts of different factors. So you could go one day and the horizon will be at like 15 miles away, and then the next day it'll be at like 6 miles, but you're not going to see it at the closer distance where it should be. I've never seen that before.
That's kind of what I'm saying. If we're saying that the limitations of the human eye are what determine the horizon.
No, I don't think it's that, right? It's not just that. Like, okay, so in architecture or art or whatever, right, they'll say that the horizon is the straight line between vanishing points. Okay, so when you're looking out, right, you have unlimited vanishing points. It's like the point of convergence due to perspective. Okay, so the sky ramps down, the ground ramps up, and then they'll meet at a point, right? And that's the point of convergence, the limitation that you can see. Now that changes, right, when you're looking out over water or something like that, because there's always atmospheric conditions that you have to take into consideration. That's why the horizon specifically says it's the apparent location where the sky and the ground meet, because it's very much apparent.
Yeah. So what is it specifically that determines that distance on a flat Earth and prevents us from being able to see the entire length or width or whatever?
Perspective convergence and weather conditions, and obstruction like ocean swells and things like that. And then miraging effects are super, like quite often when we're looking out at the horizon, it's a false horizon because you'll have a mirroring effect that takes place just where the horizon line is. So sometimes it looks like you're zooming out and you can see the horizon. And I mean, you're just looking out with your eyes and you can see the horizon, and then you'll take out a zoom camera and you'll zoom in and you can see like dolphins, like, and they look like they're jumping in the air. Like behind that, it looks like they're super common.
And different differentials in air density can make it bend downwards. So
Fazem cobre.
What's that, bro?
Is that someone speaking?
Yeah, chuck yourself on mute, Spirit Bird.
I'm so sorry. Okay, I'll just use this moment to say that, wow, what a respectful group you guys are. It's that so many people here, but everyone is just so quiet. Sorry, guys, it was my bad.
Oh, that's okay, bro. Look, we were just having a conversation. Like, not everyone can talk at the same time. It would just be chaos.
Yeah, what was I saying? What were we saying?
Yeah, just talking about mirages. Yeah, so like we have like a list of mirages that we can agree upon that happen.
So,
but yeah, look,
sorry.
like well, I can show tons of observations where we can see magnitudes further than you should be able to see. I don't think that you would be able to provide any that match up with the globe Earth math, right? You know, and if there is something, right, it's not going to be consistent. It's not going to be something that's been repeated or something like that. Or there'll be like obvious miraging effects or obvious like ocean swells. And, you know, quite often when you look out into the ocean, it looks like it's pretty flat. And I used to like live next to the ocean. I had a boat and it was just a little boat, right? And I would take it out like one of those blow up boats. And I would take it out into the ocean and I would look from a distance from the peninsula and I would be like, oh, it's nice and smooth out there. It looks flat. And then I would get out there and there's like massive ocean swells, right? You're going up and down over these big spread out ocean swells. So if you've got a boat and you're watching a boat go out over that, it kind of looks, you know, somewhat flat, the actual ocean, because it all kind of blends in together because the ocean swells are just everywhere, laid out kind of evenly. And then as the boat goes out, you know, it can disappear behind them. And then because what happens when those ocean swells go through the ocean, they make it towards the shore. And as the depth of the water starts to get shallower, we have an effect called shoaling. And then those ocean swells that were, say, 1 meter high out in the ocean, now all of a sudden they go up, you know, quite high in height because just because the depth of the water gets shallower and you have that shoaling effect, you know, and that's when they actually turn from swells into waves. So we have shoaling. Yeah. So if you're standing at the beach and you're looking out, right, it can look like a ship is disappearing bottom up, but it could just be the shoaling effect, the ocean swells, or you could have like a miraging effect, like an inferior mirage, or a less extreme version of an inferior mirage, which is sinking. And now if you look at the definition of sinking, it says an object that is normally visible on the geographical horizon apparently sinks beneath it. So that can happen sometimes. And I've got like some good observations where they went out, right? And there's a ship like 13 miles out, big giant ship, and it's anchored. Checked on the distance on the tracking radar. It says anchored. It says 12.9 nautical miles or whatever, right? And in the morning, it looks like it's hidden behind the horizon drastically. You can only see like the top part of the ship. The whole hull of the ship's all completely sunk. Looks like it's gone beyond the horizon. Now, he stays there for the next 4 hours and he keeps like occasionally like zooming in on the ship. And you'll see over the next 4 hours, as the weather conditions change, the ship becomes more and more visible, even though the ship didn't move. And then 4 hours later, you can see the entire ship again. Right? It wasn't actually hidden behind the horizon. It was just a sinking effect.
Can I give a hypothetical explanation for that on a globe Earth?
Well, this is the explanation even on a globe Earth. But yeah, go ahead.
Sorry, what do you mean? This is the explanation.
Oh, well, this is an explanation. Okay, maybe I misspoke then. No, I'm saying that this effect isn't something that's, it's not like something flat earthers came up with. That's all I mean, right? This sinking effect.
No, I mean, like, so you're not saying that is evidence of a flat earth or debunk.
No, I'm not using any of these observations as flat earth proofs, right? This is just us testing the globe metrics.
Yeah, so it's more of a debunk to the globe.
Yeah.
In your opinion.
Yep.
So
let me actually show you the observation I'm talking about, and then you can tell me what you think, and you can give me like a potential rebuttal. because I got it right here, ready to go. Okay, so this is the ship. So I just found this image on Google because the radar said the name of the ship. Okay, so that's the ship we're talking about. Okay, so in the morning when sinking is more likely to occur, this is what we could see, 9:30 a.m. And you can just see the top part of that ship popping out over the top of the horizon there. Here's another view, slightly more zoomed out. And then what you'll see is 3 hours later, right? Because what happens is in the morning and during the night, that's when sinking's likely to occur, because you can have the air temperature gets cool overnight, but the water temperature stays pretty similar throughout the day, throughout the night. Now, if you have like the water temperature a little bit warmer than the air temperature above it, it creates like a slight gradient where you have a layer of warmer air above the surface of the water, and then it cools down as you go up vertically. So it creates like that sinking effect, and that sinking's like a mild version of an inferior mirage. So it makes the object look like it's bending downwards. So anyway, look, as the air temperature heats up, as the day goes on, the air temperature gets hotter than the water temperature. So now you've got, like an inverted refractive index due to the inverted temperature gradient. And then look, all of a sudden, that's the exact same boat. And now we can see the entire boat. And we also have a bit of an effect called stooping, which makes it like kind of look a bit compressed, and a little bit of looming. It looks like it's a bit higher, but it's a little bit hazy as well. But it just goes to show that everything's not always like as it seems when it comes to the boats over the horizon argument.
No, I mean that's kind of what I'm getting at. The lensing of it is what creates the effect that allows you to see over the horizon, so beyond that 3 mile rough 3 mile limit. And that as exactly as you've just explained, with the difference in temperatures and the bands of air pressure above the ocean is what makes that change. But that would be evidence for curvature. Because if it was flat, it would just disappear altogether. Like
not necessarily. This is the thing, right? We can replicate this same thing on a flat surface over a small distance.
But that doesn't translate. Like, scale isn't the same.
I think things can disappear. Things can disappear bottom up on a flat surface.
Well, that was another point actually. At the end of the video, the optics video, with the whole moving the coin around and then the book and stuff.
I don't like the coin example. I don't stand by the coin example.
Below the table, which is a really...
Well, it's not even that it's below the table, right? What I would say is that, like, you know how you have an aperture inside the camera lens?
Yeah.
And when it's zoomed out, that aperture closes and it's very small, and then you can't see the boat, and then, or the coin or whatever, right? And then when you zoom in, it just opens up that aperture. It opens up like 4 or 5 times the size, and then all of a sudden it, the hole that the camera's looking through, or the light's coming in to the sensor in the camera, it's high enough now to see the coin again. I think that could be an explanation for it, but yeah, so I wouldn't use that as like a perspective evidence myself, but I could be wrong. I'm not saying other people are wrong about it. That's just my opinion. Makes sense. But look, what I'm saying is that we can replicate exactly what we see with boats on the ocean on a small scale. So it's not something that's exclusive to the Earth being a globe. Now, if you're talking about lensing, I think lensing's the wrong word to use, right? Lensing's not going to... You're talking about like terrestrial refraction or atmospheric refraction, whatever we want to call it, right?
Yeah. Terrestrial refraction, I think, is
well,
what
it's
you define
actually
it.
what that is essentially a series of miraging effects. Now, yeah, I was listening to a debate the other day, and it was like, it's like Doctor, I forget his name. Let me just check what his name is.
So just to clarify, miraging, as far as I understand it, is the opposite, where it bends light in a convex manner. And
not quite. No, it can do either. Okay, so there's different types of mirages. Okay, so what happens is when you have vertical temperature gradients, right? So say you're looking down a road and the sun is heating up the road, it creates like a warmer layer of air above the surface of the road.
Yeah.
And then when you look down if you get down low and you look across the road, what will happen is it will, like the warm air makes the gas particles spread apart further, and it lowers the refractive index, and that will gradually get cooler as you go up vertically. And then the cooler air, obviously, it's more condensed, right? So that will create a higher refractive index. So you have like a density gradient that's caused by the temperature, and it's just like a gradual gradient. So when you have that effect, it makes like the light bend upward. Right, I'm just parroting the mainstream right now, by the way. So it makes the light rays bend upward, which displaces the object in the distance downward. Okay, so when you see inferior mirage, there could be something like a person walking down the road or something like that, and it'll look like the whole bottom half of the person is like sinking into the road or something like that. Now that's the inferior mirage. Now we can have the opposite of the inferior mirage, which is the superior mirage. And you've probably seen those images where you can see like floating ships and things like that. Now, that's when you have like the opposite. You have an inverted refractive index gradient or an inverted temperature gradient. Okay, so you have cool air down lower and then warmer air above it. And instead of the light rays bending upward, right, they'll bend downward, and it'll displace the object in the distance upward. So that's when you'll see like floating ships. It's just like the opposite of an inferior mirage.
Yeah, so when the typical kind of shimmering effect of, the whole I've found water in a desert, but it's just a mirage.
Yeah.
What are you seeing there? What is that reflection made up of?
Well, that reflection is called total internal reflection. And it
what is that? What is that? The total reflection? What is that?
Total internal reflection is present during certain types of miraging effects, right? So mostly, it's mostly present. It's like, okay, yeah, I'll put an example in the side chat.
Sorry, I don't understand all, but okay.
No, that's okay, bro. That's okay. I'm just gonna put an example in the side chat.
I ask. Okay. Yeah, let's go. Okay.
Right, just a second. This is a good example anyway, so I'll just find it quickly. Sorry, my files are kind of unorganized.
No problem.
Yeah, so when you see that mirroring effect during these mirages, that's like called total internal reflection. And it's just due to the angle that the light is hitting that part of the ground, and it's kind of like makes it bend up, and the light actually goes over your head, so you can't see that section of the ground. Instead, what you can see is a reflection of whatever's in the background. It gets super technical. There's people that can probably explain it. I'm probably butchering it a little bit, but this is the basic explanation of it. Now, have a look in the side chat. Does that make sense?
Bro, what the heck?
Yeah.
It's it's basically the sky that you're seeing, because it's refracting the light.
That's so interesting.
Upwards.
Yeah, I'm learning.
That's exactly what I was saying. Yeah. In that scenario, the light's refracting upwards, and in the boat scenario, the light's refracting down over the curve.
Which books? Now I can ask.
Yeah. So, well, this is an image I just posted.
Hmm?
And you can see like a guy walking down the road, and it looks like he's like sinking into the road, right? And that's an inferior mirage.
Yeah, because
so-
he's further away than the mirage that's in front of him, and that's caused by the difference in air density.
Yeah. Well, what's happening
in
is
layers. But the reflective mirage that's as he's walking, you can see his shirt or his shorts. There's a dark patch where you can see him, and then you can see the sky around him. So
Yeah, you get-
initially there's at the angle we're looking at it from, or the observer's looking at it from, the shininess, if we want to make a distinction simply, is the sky, and that's hugging right to the surface of the tarmac because that's where it's hottest. And then as it get, like you described just before.
So sorry that I interrupt. Sorry that I interrupt. I go to the next channel. I come back and okay, this is very interesting. I come back and sorry, this I think this is not my
All right.
channel, but I okay. Sorry about that.
That's okay. Catch you later.
Okay, yeah, I got you.
All right, bye.
Bye-bye.
Yeah. So look.
Yeah, so as I'm saying,
so when you when you have that
pointing up
Yeah.
further away, it's different pockets, different bands of air, and that bends downwards. So you've got an inferior and a superior going on there at the same time.
Well, kind
That's
of.
what's
Yeah.
causing that effect.
What you get, like sometimes you can get like a soup most often of different miraging effects. So that's why if you look up a specific type of mirage and then you go to Google and hit images, you'll see like very like they're not uniform. Like sometimes if you're looking over a long distance, you'll have a different refractive index gradient at say 2 miles, and then you'll have a completely inverted refractive index at say 5 miles. So what you'll get in the distance will be like a soup of different mixtures of different miraging effects, or sometimes you'll have a particular miraging effect close to the surface, so the bottom half of like the oil rig or something will look like it's like squished, and then the top half will have the opposite type of miraging effect, and it'll look like it's stretched. And that's like
kind of exactly what we're seeing here.
Well, what we're seeing here is this is textbook definition. This is textbook definition inferior mirage. Same with the one up above, right? Because you can't have the superior mirage in this situation because this is over a hot ground. So it's always when you have the warmer air down lower and then the cooler air above it, right? That's when you'll have the inferior and things will sink. And then when you have the cooler air down lower and the hotter air above it, that's when you'll have the opposite. That's when you'll have the looming or the superior mirage. But look, have a look at this one, right? This one's with a little toy boat over just a couple of meters distance.
Can I just clarify? The shiny road is the sky.
Mm-hmm. Yes.
So that's a superior mirage then, because the light's bending upwards.
No. That's total internal reflection from the inferior mirage. I got all the definitions and things here saved, so we can 1 second. Inferior is, you could have that mirroring effect. It'll look like it's happening kind of in the sky a little bit. It's and then an extreme version of that's the Fata Morgana. Right, so there's the like the definition of the inferior mirage, and if you have a read over it, it's like kind of technical, but you'll be able to understand it. So when I read over it, like there was some stuff that kind of confused me, and then I would just look up the terminology that they were using, so it would all make sense. But yeah, basically, if you have like a hot surface, right, you can't have a superior mirage in that situation. You would have to have the opposite temperature gradient. But have a look at the one I posted at 22 minutes after the hour.
terminology skill
this
issue
is-
on my part.
It's all good. It's all good. But yeah, look, just have a look, like back to the boats thing again, right? Have a look at this little toy boat. Now, just picture that the pavement that the boat's sitting on was blue water, and then the background was blue sky. Right? It kind of all blends in together when you're looking over a vast distance, and it will look like the bottom of the boat is, disappeared over the horizon. But in reality, it's just a false horizon because of that total internal reflection, and then you've got the displacement due to the bending of the light, making it look like the boat is lower than what it really is. So that's a way of explaining some of these effects, right? And what you'll see quite often when you see these effects is you'll see, if you zoom right in, you'll see that total internal reflection, and you'll see like little see-through bits of the boat, like part of the bottom of the boat will look like it's like completely missing, right? Like you'll be able to kind of see like the sky. It's that mirroring effect, the total internal reflection. So look, all I'm saying is that I've never seen an observation that takes into account these things, right? These are factors that have to be taken into consideration. That sometimes when you see a boat and it looks like it's over the horizon, it could easily be an inferior mirage or sinking, right? Or it can be ocean swells. So I'd love to see an observation where those things have been negated, right? No ocean swells. And then someone's been able to validate the refractive index gradient so they can confirm that there's not this sinking effect taking place. But I've never seen that. And when it comes to like what I showed you earlier, the oil platforms, we see the horizon behind the oil platforms. We don't see any miraging effects, right? It's completely clear. It looks normal. There's no like total internal reflection or anything like that. It's just flat, right? And then we see the horizon line clearly behind the oil platforms, 10 times further away than what they should be. Like the horizon 10 times further away than what it should be. So
where should the horizon be in your on a flat Earth model?
On a flat Earth, it will be apparent, like it'll appear in a different place depending on the weather conditions. So depending on that refractive index gradient, depending on the height of the observer, all of those factors come into consideration. But it's, some days you'll go there and the horizon will be like 20 miles away from just standing at the beach, right? 6 foot height. Other days it'll look like it's like 5 miles away, 6 miles away. But on a globe it should be 3 miles away. But it's very, like, I've never seen anyone confirm that it exists. The geometric horizon. It's like the elusive geometric horizon that nobody can find, but it has to be there. So this is kind of what the globe side's claiming in these observations. Really, there is a horizon there at 3.5 miles, right? So I'll just pop this back to square one with this original oil rigs one that we looked at. Right, so I'll just pop that back in the chat. Right, so this is what they'll say. Really, there is a horizon halfway between the observer and that first oil platform. And everything beyond that horizon is starting to sink behind the horizon, but somehow everything's perfectly like refracting up and making it just all flatten out and look like it's completely flat all the way out to the horizon, right? And really that second oil platform's like hidden behind the horizon. Like half the oil platform's hidden behind the horizon, but it's just all perfectly refracting up and making it look flat. And that doesn't match any of these miraging effects, right? It doesn't match what should be observed with terrestrial refraction. Hey, someone's hot micing. Leonardo. Can you mute up? Yeah, so it's not a realistic claim, right? Because we go to like different locations, different weather conditions, and we have the same thing happen. We see the horizon like 10, 20 times further away than what it should be. And there's no miraging effects. It's just not there. Like,
that's not consistency though, is it? That's just variability and proving that.
Well, there's no type of miraging effect that will change the distance of the horizon like that. Now, here's a debate. I did bring this up earlier, but I think we got sidetracked. Now, here's a debate. This guy's a doctor. He's a high-level engineer. He's got a bunch of qualifications anyway. He was debating some flat earthers I was watching the other day. The flat earthers did a pretty terrible job, to be honest. And they were kind of butchering these observations and butchering refraction and stuff. But this guy, that says that he's a physicist here. I don't know exactly what his qualifications are, but he's definitely an engineer, and like Dr. Matthew Jelovic. You can look him up anyway. But super nice guy, very, very smart guy. And he was talking about refraction with the flat earthers. So I took 2 little clips, and these are just like 15 to 30 second clips. And this is what he had to say about how much of a difference refraction would make in these types of observations. Okay, so I'll just post that in the side chat. So if you want to just check out like those 2 little clips really quickly, they're like super short.
Just on the oil platforms, it seems to me that the legs particularly on the one further away, ought to be much taller. And
like
the
they're
whole
not
image, like various different parts of it are squashed and distorted. So I like.
Well, it's actually not. It's actually not, because what we have, right? We can look up close up. Like these are super like popular oil platforms, and there's so much information about them online. So we can look up pictures of what they look like close up, and I do have the pictures here somewhere. But if you compare what we see in this observation to what the oil platform actually looks like close up, you'll see that it's like not all distorted or anything like that. It's got very short legs. It's a small platform, and it's only 77 feet above the surface of the water. So if you compare the the close-up picture to what we see in this observation, you'll see it's very accurate. But I see the point you're making. But you've got to remember, it is 4 miles further away, right? That's what's that, 7 kilometers or something like that. It's a long distance further than that first platform.
The bit that sort of still comes back round and is that optical angular resolution thing from right at the start, 4 hours ago or whenever it was we were chatting last. If that. So that clearly doesn't determine where the horizon is, because we're seeing loads further than that.
Yeah, I didn't use that argument myself, and I'm sure some other people, if you talk to Jedi about it, he might be able to explain that in more technical detail. But I just stick to what I researched about these things, right? With the angular resolution, I'll just say that my claim with that is that it just applies to things that are moving away from you, and once they get below a certain size, you can't resolve them anymore. Like a fly or a boat or anything, a plane, right? That's why when a giant jumbo jet is just 6 miles away up in the air, you can barely see it. It's like a tiny dot. If it was 12 miles away, you wouldn't be able to see it at all, just because of the angular resolution limitation. And then you could zoom in and bring it back to view again. But
yeah, so that was my confusion, because that was sort of being posited as the reason for things disappearing bomb first, because we can't, the angle becomes such that we can't resolve that, and therefore it appears to shrink below or sink.
Yeah.
Below.
Well, look, that confuses me as well, to be honest. I don't know. I don't use that argument myself, but maybe other people can explain it better than I know how it works, but you know, I don't use that. I think it only applies to like if you have you're supposed to have a horizon at 3 miles on the globe, right? So this is the argument, the best I know it. So you're supposed to have a horizon at 3 miles if you're 6 foot tall, making the observation. And then if you have a 6 foot boat, right? Just say a boat's like 6 foot high, 6 foot wide. Technically, it would breach that 0.02 degrees exactly at that 3 mile mark. But if you had like a 10 foot boat, it wouldn't work anymore. It would only work with the 6 foot boat. So yeah, I don't fully understand that argument. Doesn't make a lot of sense to me, to be honest.
Yeah.
Maybe someone could educate me on that. But you know, what we know when we do these observations is we see no horizon over like 20, 30 miles, right? Sometimes it'll be at 5 miles in the exact same location. So it's very much an apparent horizon.
Yeah, for sure, because of all the refraction
Atmospheric refraction's like the globe earther's worst nightmare, in my opinion. It makes it super hard for you guys to be able to prove that geometric horizon exists. But that's what brings me back to this guy, right? So let's say the horizon in the oil platforms video that I showed you, it should be at 3.46 miles, right? It has to be at that distance. So hypothetically, if we were able to remove all the atmosphere, just for a thought experiment, right? So we're in a vacuum chamber, and then, okay, so that would mean that the horizon line has to be at exactly 3.46 miles if the Earth's a globe. Has to be there, can't not be there. Anything that goes beyond that, right, has to start going behind the horizon, right? So technically, that oil platform is behind the horizon.
Yeah.
But so now we add in the atmosphere back again. Now we have to take into consideration the atmospheric refraction or terrestrial refraction, whatever one you want to go with. I think technically it is actually called. Oh, anyway, that doesn't matter. So yeah, now we've got the refraction to deal with. Okay, so here, please have a look if you can. It's literally just like 20-second videos, right? Both of those. So here's a professional that's not biased against flat Earth, right? He's a globe earther, he's a scientist, and he's a super honest, nice guy. Just someone that's actually researched about this type of thing, and he tells you how much of a percentage that refraction can actually make. Right, so just check those videos out if you could, if you don't mind.
Yeah, I'll look.
Awesome. Cheers.
Yeah, so he's just saying exactly what you said, that it doesn't account for very much.
Yeah, so the horizon, right? Like if
I'd
the
love to
horizon
see
should
some actual calculations on it, though.
Yeah, I can show you the actual calculations. Oh, calculations on what specifically?
Like what we would expect to see based on the refraction and the conditions based, like all these photographs and videos and stuff proving one thing or another. And like we just discussed, it doesn't actually prove anything because there's all sorts of other stuff going on.
Well, it does.
Like, it'd be interesting if we could actually measure.
Well, this is the thing, right? He just said that it would only allow you to see about like 8 to 10% beyond the curvature of the Earth. So it would move that. All that means is it would move the horizon from 3.46 miles to about 3.6 miles or something like that. Right? It's not gonna. Right? That's you just add 10% on to how far that horizon distance should be. We're seeing the horizon 1,000, 2,000% further. Right? Not 10%. It far exceeds the small consideration you have to take into account for atmospheric refraction.
Yeah, but that's
So-
what I'm saying. I'd love to see it actually calculated with angles of incidence and all the rest of it, and refractive indexes calculated to actually prove that. Because I mean, that obviously, I know I don't mean to be a dick, but that is just one guy's opinion, and he might be very well qualified for all the rest of it. But
Yeah.
I'm just saying we need empirical.
No, I get you. Well, we got subject matter experts that write books on refraction. You know, they all say the same thing. And then we've got surveyors and, you know, navigators, and they all use the standard atmospheric refraction calculation, which is, I think, 7% or 8%. So, you know, there's tons of sources. It's definitely not just that one guy's opinion. It's the mainstream opinion. So
Where in refraction it says that it causes balls to look flat, or they said that in the refraction stuff?
no, he said it wouldn't do that. He said if you could show me an observation that exceeds that 8 to 12% or whatever, he said that would be shocking to him. He said if you can show me something that exceeds that, then I'll be like shocked and mind blown.
So where do globers get the idea that refraction is like a globe argument of some sort?
It's the worst nightmare for the globers, for the globe earthers. Yeah, worst nightmare. But yeah, that's the thing, bro. Like,
See, I don't,
we're trying
I
to
don't think it is. I think the curvature increases these types of angles because you're it's like a fiber optic cable. If you bend it too much, the light comes out of it. You know, so curvature increases these types of effects, not diminishes them. And that's why I'm saying on a flat Earth, I feel like that exact thing wouldn't happen.
No, it does happen on a smaller scale. Like we can reproduce all of these known miraging effects on a small scale flat surface. I've got demonstrations of all of them.
I know what you mean. I'm not explaining myself very well. It's far too late.
It is.
I mean, I'll figure it out.
Maybe we can continue this conversation another time because it's like 4:40. Yeah, it's the same time. I'm in Poland, so it's an hour later for me.
It's pretty late.
Yeah.
Yeah. I should probably go to bed. It's a fucking stupid.
Anyway, man, it's actually a pretty fun conversation, but I appreciate the cordial conversation.
No, not at all. That's the whole point of these rooms. I can't stand it when people just want to shout over each other and like it becomes about winning the argument rather than trading points.
Yep, cool.
Nice one. Right, I'm gonna go.
All right, catch you next time, bro. Catch you.
See ya.
What's up, guys?
What's up, man? Who's that? Gemsy?
No, I'm the elegant.
Oh, the elegant. Hey, how's it going?
I am also elegant, but that wasn't me.
What's up, man? So,
Not much.
you're talking about any topic right now or something?
Oh, yeah, we just had a long conversation about boats going over the horizon.
Okay. So you're taking a break right now. Am I right?
I'm just about to go to bed because it's like nearly 5 a.m. for me. But there's tons of other people here that can chat with you and answer your questions, like
Okay,
Jamesy,
thank you,
for
mate.
example.
Thank you, mate. Thank you.
Yeah, no problem, man.
See you.
Gotcha.
Yeah, I like that, DJ. It's the globe killer. Refraction.
What is?
It is, bro.
I don't think any of us Globers see it that way.
Of course not.
Well, quite often
Wait,
they do. Like,
Matthew, you speak for all Globers? Is that what you're saying? None of you Globers?
Is that what I said? None of us Globers?
What did you say? None of us Globers see it that way?
No, I said I don't think us Globers see it that way.
yeah, same thing. But yeah, dude, I explained the same thing to Eggshells, and after he said that he agrees and that any globe earther that uses boats over the horizon as a globe proof is retarded. That's what Eggshells said. He's one of your
Yeah,
top
none
guys.
of us use it as a proof either. Anyway.
Yeah, they do all day long. That's like nearly like every person that comes
Yeah,
through
maybe
here.
you're right, maybe.
Maybe not you though, but all the other ones. They definitely do that. Eclipses, boats over the horizon.
Sunsets.
Sunsets, as Matthew's go to. All of these things. Yeah, like the elusive geometric horizon.
They just decide when it's on and when it's off, when to take it into account and when not to.
Yeah, like if we show a long distance observation from like a mountain and we can see hundreds of miles, they'll be like, it's refraction. And then like the next week they'll come in and present the same thing. And they'll be like, we'll be like, did you take refraction into account? They'll be like, no, it's on top of a mountain. It's too high for that to like matter. Yeah, it happens.
And you're like, what about this infrared footage?
Yeah, that's why we've always got the infrared footage. I never see them use the infrared footage. Not once. It's always some like consistently. The globe Earth's long distance observations are like like just filled with like blurry shite and obvious miraging effects, like that Rainy Lake experiment. That's one of the dumbest ones I've ever seen. It's like crazy miraging effects taking place in the background. And they're like, well, that's happening in the background. You know, do you see it happening in the foreground? No. It's like, dude, come on, imagine if we presented something like that. And then we'll present these, like, you know, super clear ones, and they'll be like, refraction is making the completely flatten out throughout the entire field of view of the whole lake. It's all perfectly bending up and somehow making it completely flat and hiding the horizon that's really there. Really, there is the horizon there, but you just can't see it. It's not 2,000% further that you can see. It's 0.0004 degrees.
Now go to the top of the Burj Khalifa.
Oh, bro, dude, I noticed they love that argument in this server. I guess because there's more like Arabs and stuff in the server. So
Oh, of course.
yeah, we hear that one quite often.
Would make a great YouTube video. Be like, look, it happens regardless because we're increasing our field of view.
Yep. That's Brian Mullen explains it well in that perspective balls out physics episode that I just posted in the side chat. He shows some examples of it as well.
Nice.
Yeah, that guy is like ahead of his time with his level of arguments against the globe. Yeah, a lot of those videos are from like 6, 7, 8 years ago, but they're like spot on in most cases.
Yeah, it's a shame what the Globies did to him.
Yep. Hey Flat Lloyd, did you see this? I think he's a Chinese kid who got arrested.
I did.
Yeah.
He was detained, arrested.
He got detained, yeah. Where's the guns?
What do you mean? They didn't let him just land over there?
Who got detained?
This 19-year-old pilot was trying to raise $1 million for cancer research. I think he was Chinese, and his goal was to fly to all 7 continents or something like that. And he left Chile and he took a detour and went to Antarctica and landed there, and he got arrested, and then he got put in. Yeah, he got detained by the Chilean.
But my final experiment.
That's interesting. Too bad that he got detained for traveling. I mean, if men made it to the moon, what's the issue about one guy going across continents? What's the big deal?
No.
Yeah, he was just trying to pop out the other side of the ball.
Well, he's probably lucky he didn't get like shot out of the sky or something like that.
Anyways, we do know that aircraft don't work on a globe because you need a pressurized system for that. Just like water. There's no water on a globe. Right, Matthew?
I have a question. Can I ask?
Yeah. Yeah.
So,
Oh, go
do you
ahead.
guys
I would-
believe gravity? Do you guys believe gravity?
Specific gravity? Sure.
No, like gravity. I mean, like a scientific gravity. What Newton's find. Like gravity means like space curvature. I mean, like
Maybe
the
if it was
fact that
1913, sure.
yeah, like
But it's been
Einstein's
superseded by
gravity,
Einstein.
Einstein's space and time gravity, kind of that way.
It's like a mathematical concept, isn't it?
No, guys.
Yeah,
listen,
it's like
listen.
you don't believe gravity?
No. Wait.
Okay. That was I was
Listen
asking.
to me. No, you have to listen to me.
No.
Okay.
No. I have something to say.
No, but you're interrupting though. So don't interrupt.
Yeah, we don't do that around
If
here.
you have something to say, don't wait for someone to be saying something for you to say, no, I have something to say. Just wait for someone to finish, and then you say what you gotta say after. Or
There's gonna
give
be
it
some
permission.
insult anyway. I've heard trolls
You
before.
guys open is mute. I don't care. I was just asking you guys believe gravity. I think you guys don't believe gravity, so I just mute myself. Thank you.
When you say gravity, what do you mean? You say
Like gravity
Newtonian and then
means-
Einsteinian?
Like, Einstein made like a space-time gravity way, like Newton, like, gravity, what I mean, it's like,
Those are
gravity, right?
concepts on a piece of paper, like people writing the word gravity and an explanation on paper. Something that you
Like,
cannot demonstrate.
gravity is like the force that pulls objects towards each other. Like, it's one of the fundamental forces of nature. Like, like objects fall off the ground when you drop them. Like planets orbit the
Helium
sun and the moon
balloons.
orbits the earth. You stay on the ground instead of floating into the sky. Like these kind of things. Like, do you guys believe that? Like gravity?
Well, what happens if we let go of a helium balloon?
What?
What happens if you let go of a helium balloon? Does gravity pull it down to the earth?
Helium balloon because it's helium.
Yeah,
Because
so it's less dense than the air, right?
sorry?
Helium is less dense than the air, so it goes upward if you let go of a helium balloon.
Sorry?
A helium balloon, if you let go of it, it goes upward, not downward, but upward.
Okay, if something, I think when I break it down for you, it's something has a lot of mass packed into a small place. It is dense. It's example a rock like a denser than a sponge. So,
Yep.
like
Wait.
Oh, hold on. How the hell did this guy get unmuted? Look, that's what we're saying. That's not gravity, that's specific gravity. So if something's more dense than the air around it, it's going to sink, right? It's going to go down, like an apple or a brick, or a pencil or anything like that.
I think.
Hold on, let me finish.
Okay, I'm sorry.
Yeah, I'm almost done, right? So if something's less dense than the air, it's going to go up. If it's more dense than the air, it's going to go down. And then things will behave differently in different mediums, right? Like water. you can get a tennis ball and it's going to sink in air, right? So if I lift up a tennis ball, I drop it, it's going to sink. But if I do the same thing in a different medium, like water, which is more dense than air, the tennis ball is going to go up. It's going to go up, right? So it's just based on the density, just the density of the object in relationship to the density of the surrounding medium. Like you said.
So I was saying that helium doesn't escape gravity. It's still affected by it. But it still flows because but it floats in air because it is lighter and less dense than air. But helium doesn't escape from gravity. Like the
They're
real
anti-gravity.
reason is helium floats because of the force called I don't know why it's that. So it is oil floats in the water, boats float on the ocean. That's why helium is floating in the sky. I think that was a stupid example. Why you said helium. Because it is the same thing because boats floating in the ocean.
Yeah, same thing. The density. So nothing to do with gravity, just to do with the density
So
relationship.
when you jump,
Well, let me explain it to you
why
really
you're not
quickly.
floating? Why you're not
Because
floating?
because I'm more dense than the air, and I don't live on a globe. Okay, so look, let me explain it to you quickly, right? So you have to have.
Oh my god! Oh my god!
You have to have.
I don't want to talk. I don't want to talk. I don't
All
want to talk
right.
to flat
Bye
earthers
bye.
because
Bye bye.
Did it just hit
Bye
you?
bye. Bye bye. Okay. Well, that was a good talk.
Nice little spiral out.
Yeah. Well, welcome to the chat, Soul, Axion, Curator. Welcome.
What's up? What's up, man?
Not much.
Hello.
Not much.
So, have you guys got into any topics?
Yeah, a whole bunch.
Could I ask you guys a few questions?
Of course.
So I just wanted to ask, what's your opinion of the International Space Station? People recording themselves having a ball of water floating in the air. Why do you think that happens? Is it CGI or something?
Well, you can do the same thing in parabolic flights, right? Which are zero G flights. So you can do that same thing in those, right? But you can also use special effects like augmented reality and CGI to easily do that. So if you watch the episodes of The Big Bang Theory or anything like that, right? They're doing the same thing on TV shows, right? Where it looks like they're floating around in the ISS and they're manipulating things that are floating. But, obviously they never went to space or anything, but they're very easily able to produce something like that. Now, NASA gets $70 million a day in funding. So they're easily able to use the top of the line methods to be able to produce these kind of things. But,
also, that's a contained environment. That's a contained environment. The globe is not. But you need a contained environment for that water to be liquid in the liquid state, pressurized system.
Well, of course. I mean, I agree with that, and it's pressurized, but it's still in a world without gravity. That's what I'm trying to say. It's there's a situation where gravity doesn't exist in a place, and
that's correct. No, that's not an argument for the globe. A world without gravity is not. That's not helping the globe start.
Well, it shows the fact that if we have an environment without gravity, then that must mean that the environment we're experiencing right now must be an environment with gravity. That's what I would logically conclude from that.
Yeah.
So you would agree there's gravity?
You're saying that if something is happening differently with water, gravity, it's happening or not happening, depending on what's happening with water?
Well, there's no force we see that is giving the object the propensity to move downward. But in our environment, we see objects that give that force the propensity to move downward. And so, what I would say to that is that since we can observe a place that doesn't have it, in the place that we do have it, it must mean that there is a force that is actually real in doing that and applying it to those objects. And that would mean therefore
there might be something else happening, but you're going to the conclusion that it is gravity as a force when gravity is not a force. So it's got to be something else that is happening, not gravity.
Well, what else is there?
Not the non-force of gravity.
What else is there?
What else is there? Is gas pressure, a pressurized environment, water in the liquid state?
Well, okay, if I have like a vacuum chamber and I suck all the air out, I do agree that a colleague of yours mentioned it once. But if I have a cup of water and I suck all the air out, and then all the water evaporates, the cup still remains downward. What is applying the force to keep the cup downward? Because there is no air pressure in that environment anymore.
The force is the gases are applying the force, right?
No, but there's no gases in the vacuum chamber.
So then what was the argument for the globe there? You got a container.
No. There's gravity.
Pressure.
The gravity's keeping the cup down. That's what I'm trying to claim.
Okay, what was the gravity? Can you pick the gravity and manipulate it somehow and say this is the gravity and I have it here?
Well, no. We see the effects of gravity. We don't see like this force of being applied to it, but we know it exists because we see the effects of it.
So what is this? When you say you see the effects of this thing, what is the thing? What is that thing?
Well, I don't know exactly how it is, but I know it's there. I can't describe all of it. I know it exists. Kind of like laws of logic in a different way. I'm not equating gravity to the laws of logic, but I know the laws of logic exist. I don't know what it's made of. I don't know exactly.
Let's say there's a thing. There is this thing that we don't know what it is, but that has nothing to do with proving a globe.
Okay, what I'm trying to tell you is that if gravity exists, then it perfectly explains that there is no container in an environment anymore. And therefore, we can dispense with the container because we don't see a container up in the air.
But
we don't
all the examples that you're giving, that this thing that you don't know what it is and you're labeling it gravity, it always happens within a container. So how can you just remove the container when the examples include a container?
Because when I prove an example with the container and I take the air out, I still have the force applied to the cup. That was the example I was giving.
You have what force applying to the cup? Go ahead.
Well, the force that is maintaining that is maintaining the cup attached to the bottom of the object. Okay, for a lack of better verbiage. There is a force being applied to the cup, okay, that is keeping it glued to the surface. Because again, there is no air pressure in the container.
Isn't the cup denser than the medium that is in?
There is no air pressure applied to it. So what is being applied to the cup?
Why? So the gravity that force didn't affect the gases. The gases left the vacuum, the chamber, but you're saying that force that wasn't affecting anything. Now that you remove the pressure in the medium, now this force is affecting the cup.
No. I'm saying the force was always there. You were saying that the differentiation of air pressures and mediums is what makes what we appear to call gravity. But I've removed.
No, I didn't make any claims about gravity. You're the one making assertions about gravity.
I know I'm making the claims of gravity, but
what's that? Do you know what that is?
the force that is giving objects the propensity to move downward. That is what I'm claiming. There is a force that is giving objects the propensity to move downward to the
But they
Earth.
don't just go downward; they go upward too. So, are you talking about
Like
the
what?
phenomena of things going up and down due to relative density?
Like what? Yeah. There is relative density, and things are going to sort themselves out. But
Because I would say Newtonian gravity in itself was really more invented, not discovered.
No,
Right?
no,
They
not
tell you a story that the apple fell on Newton's
No.
head.
No.
However, if it were to fall into a puddle of water, he would have realized, oh yeah, Archimedes' principle and relative density already explains that the apple fell through the air because it was denser than the air that surrounds it and floated on the water or
What
the
is
puddle.
keeping all the air down? You're going to say a container.
Pressure.
But yeah, pressure created by a container. But what I'm going to tell you is that
Well,
if
that's what
I
air
create
pressure
my-
needs.
Yes, but if
Movement,
I
volume.
create again, going back to what I was
PV
saying,
equals nRT.
yes, an ideal gas law. That's not real gas law. But the thing is this, is that when I have like a container and I suck all the air out, there is no air pressure anymore. Okay? Air pressure is zero. There is no, it's a
No,
vacuum.
there is no such a thing as
Good luck
zero air
finding that
pressure.
in
Stop,
nature.
stop making
There,
stuff up. There
it's
is no such a
vacuum.
thing.
It is a
No,
vacuum.
listen, bro.
It
You
is a
have to.
vacuum.
You just said that there is zero gas pressure in there. Is there? Can you
What do
demonstrate?
you want me to
Zero
say?
gas
Almost zero? Almost zero? I can say almost zero. I can use
Is
correct
it zero
scientific
or is it
interpretation.
non-zero? Zero and non-zero are different things.
It doesn't matter. The
Oh,
air
it doesn't
pressure
matter.
is low enough. The air pressure is low enough where there is almost no air inside the container. So what is pushing the cup down? What appears to keep the cup down into the container at the bottom of the container?
Wait. Can I say something? So, let's say you have a container with no air because you remove the air with an engine, with a pump. You remove the air until there is no air.
Yes.
And then you close it. But inside this container, there is an object. So there is no air. But inside this container, there is other objects, and there is no air around it. How come this object goes down? That's the question. There is no
because
pressure.
it was lifted up. Because it was lifted up, it never would have moved off the bottom of the vacuum chamber unless someone exchanged some energy to displace it. Now, all you did by changing it from regular air to a vacuum chamber is manipulate the medium and make the medium even less dense than what it already was. So
How
there's
less?
no
How
well,
less?
as much air as you could possibly get out, right? So depending on what torr rating you could get that vacuum chamber down to, all you're doing is making it the least dense medium possible that you know. So those objects are not going to just fall. Nothing just falls by itself, right?
Yes,
And
it does. If you
No,
have
it doesn't.
gravity, it falls.
No, nothing. Hold on. Let me finish, and then you can reply. Right. So nothing just falls by itself. It has to be displaced. So something needs to force it out of its state of rest at the bottom of the vacuum chamber, right, where it's in equilibrium in relationship to the density of itself and the density of the medium. It will never move, right? So if you come along and you exchange some of your energy to force it out of equilibrium, it's just going to sink back to equilibrium, right? And also, gas particles debunk your gravity as well. But it's very easy
How?
to explain.
How does it debunk my claim of gravity?
How does what? I mentioned two things. Just
How does gas particles debunk my claim of gravity?
Oh, yeah. Gas particles don't have a downward bias. Gas particles move at random in all directions.
Yes, they
just
do.
like
They
yeah,
have a
so
downward bias.
Right, they have so they have a weight, right? Like different gas particles have different molar weights, right?
Okay. Yeah, they have
so
different.
are they getting pulled down to the earth by gravity?
Yes, I would agree.
No.
Well, you just said that they're going in all directions, but the actual definition of gas. Hold on, let me finish. Last thing, I'll let you reply. Hold on. The definition of gas particle movement says that gas particles move at random in all directions, and they travel in straight lines between collisions right? And they move because of kinetic energy, and they're not affected by gravity. They don't have a downward bias.
No. That's an added point. Okay, they are affected by gravity. It is why they stay in the Earth, because gravity is keeping them down. It is also why
The air that is not curving. The air that is not curving.
The air that is
There's
not
science
curving.
in there now.
The Earth, you said they're sticking to the Earth, right? But that thing is not curving. So whatever you add into whatever phenomena we observing within the gas chamber, gas behavior, the cup staying down on the table or on at the bottom of the vacuum, it has nothing to do with whatever additions you add into this word gravity in relation to the globe claim. Nothing to do with
Yes,
that.
it does. Okay, because like I can disprove with the theory of gravity that there is no idea of this container. Number one, you haven't demonstrated where is this container at. Okay, what is the container made of? What is supporting the container? Why has no one ever called?
You yourself said that you don't even know what this gravity is, but you're gonna give all of these attributes. But remember, you gotta give it all of these
That is a
attributes.
fallacy.
You're gonna make claims on top of claims without any. You're gonna be making baseless assertions about what this
That's
thing
a fallacy. It's not a
If-
baseless assertion. I've proven several points of the existence and demonstrated the existence of gravity. And you've
never shown gas pressure without a container, brother.
And not
You
only
thought
that,
you thought you had a good point when you came in here, but it's not a good point. Dude, we've had
Yes,
this
it is a good
conversation
point.
thousands of times. You're not going
And
to
you
come
keep
in here with a
denying
weak
it
point like
1,000
that.
times.
No, there's
Yankee.
not. You're not. Go ahead.
DJ, may I? So I just wanted to ask, because Yankee, you did say that gas has a downward bias. Where did you get that from?
Okay, number one, because the gravity exists. Number two, there's the same reason of why we climb mountains and there's less air up there. Okay, if it was going in all directions, we should see like even air pressure in all places, and yet we don't. The higher we go, the less air there is.
This is called claim stacking.
Exactly. Yeah. So I want
claim stacking.
I'd like to pick it apart.
I'm not building upon the claim.
Yankee,
These claims are supporting each other.
Bro, check this out. Right?
I could use one or the other.
Yankee, hang on. So check this out. You're trying to assert that gravity exists by then saying or stating that gravity has a downward bias, and then because gravity exists. So you have a little bit of circular reasoning in that. Okay, number one. Number two, okay, with regards to the gradation of the air pressure, do you have another example whereby all the variables at play creating the pressure are static?
Say again?
And it does this? Do you have another example of this whereby all the variables at play are static, i.e. temperature, humidity, etc., etc.? Those are static, they're not fixed. And with that, you can still show a gradation?
So you're saying there are areas on the planet where you're able to go higher and you would have more air? Is that one?
Another claim stacked on top of the other claims. It's a planet, another claim, another basis assertion on top of the other one.
Yeah, so the reason why I'm asking that, Yankee, is because we know that temperature, for example, has a role to play in creating pressure, right? So if you have an environment and you're strictly measuring the altitude of something, but discounting the temperature throughout that altitude, and then state that the sole reason why it's gradiating is because of the altitude, without actually factoring in the temperature, you're making an error in calculation.
Well, no. That's not what I'm saying. I'm saying there's less overall air particles within the environment that you are in, not the fact that there's less air pressure.
No, that's fine, right? But first of all, unless you go ahead and count all the air molecules, I mean, you can't really state that. But by definition, sure, temperature, it can be pressure. It can be influenced by the actual number of particles, for sure. You pull out the gas from thing, you have less pressure. I get that. But in an environment where that's not fully quantified, Okay, we just have air, right? We know we're surrounded by air, and then you can measure different degrees, different temperatures at different altitudes, and then you have a gradation, right? You can show. We know that you influence the temperature, you can influence the pressure. So in this claim about the altitudes, right? And unless you can quantify that, strictly saying it's because of the altitude, it's not. It doesn't hold water.
There are some things I would say that like don't really need any type of demonstration of like exact calculations. If you want me to find like exact like parts per million of calculations, I can bring that up.
I'm not asking for that, dude. The reason why I'm bringing this up is because clearly you don't actually have this material on hand to show. Okay, you're trying to skate past the notion that you did not consider this.
I could claim the same thing you are
before you blurt it out of your ass. Okay, so I would suggest that just on your first two statements that you retract.
No, it's not. You still look. If I have a plane, okay, and this has happened several times in several places where people have tried to like climb into the wheels of planes. And they go up, and what happens? They get hypoxic, they pass out, and they fall out of the plane when the wheel opens back up. Why does that occur?
Dude, check this out, dude. It's not the point. Is not the point that there is a gradation. That's not in contention, dude. But the reason why
then what's keeping the air downwards, closer to the earth?
Dude,
what is keeping the air closer to the earth?
Relax. Listen, just to restate it, right? The point that the higher you go, the less pressure there is not in contention. You're asserting
not pressure. It's air molecules parts per million.
I get that, but listen to me. Calm the fuck down, bro. Okay? You asserting that the reason why that happens is because gravity is pulling all the gas molecules closer to the surface is what's in contention. You follow?
I follow.
Okay.
Yeah,
so if you can
ask a question?
If you can demonstrate that, then that's different. Go ahead.
No. The answer to the guy that asked a question, you cannot ask a question at the moment because the guy was in the middle of his sentence.
No. I'll concede. I mean, like we can continue. It's just just a discussion. I'll let him speak now.
So when I jumped in, you were iterating through some stuff, right? If there was more in that list, because number one, I showed you there was a bit of circularness to it, so you may want to retract that. The second one, there's a bit of iffiness to your premises. Is there a third one or a fourth?
I'll continue on. Like, dude, I'm not going to forget what I say. Again, we can continue it on. I'd rather have like Axion like say what he wants to say and then let him go.
Yeah,
actually, you can ask a question now. Go ahead.
Yeah, go ahead. And I
so
think DJ wanted
the question is, what keeps? So if you have if the atmosphere is maintained by pressure, is it this pressure? Because if you want to have pressure, must be somewhere, right? What is it? What is containing the pressure? Because if you as you can make experiments everywhere, you put pressure in anything, and then if you remove like this container for the pressure, it's going to depressurize. So are you living in an environment with pressure? So
I'll tell you.
In that case, what is containing the pressure?
I'll tell you. Listen. So the pressure of gas is the force that the gas exert on the walls of its container, right? So
we live in a container.
One second, I'm not done. So since you asked, I'm gonna tell you. Pressure is caused. You hear that word? Caused by gas molecules hitting the walls of the container. You see?
What container?
So another one. The rapid motion and collision of molecules with the walls of the container causes pressure. It's pretty simple.
Yeah, okay, but can you explain what is the container that you're talking about? Because I don't get it.
And then the antecedent for the pressure of the gases is an antecedent. It has to be in place for the gases to press against, causing the pressure.
So the Earth, it's inside the container.
Well, you have gas pressure, and gas pressure is the force that the gases exert
I'm
on
just
the walls
asking.
of this
I'm
container.
just. Is it yes or no?
You have gas pressure, yes. You do have gas pressure, yes. So there must be.
No.
It
I'm
has
asking
to be
if the
contained.
Earth, if the Earth
Yes,
is in a container.
it's contained. You were contained, yeah. The Earth is contained.
So-
I mean, the air is contained. The Earth being part of that
By what?
container.
By what? There is a container. How can I see the container?
How can you see? Okay. So this is an antecedent relationship, right? You're asking about what is the color? You have a steak on your table. You have a steak. You have a
No, I'm
ribeye.
vegan, sorry.
So you have a corn. You have corn seeds, right? You have a corn salad, and then you're asking what was the size of the corn plant or whatever. You know, there's as an antecedent to have the corn, a plant, soil, all of those things were in place to be able to have the corn, right? So as an antecedent cause and effect relationship, the pressure of gas is the force that the gases exert on the walls of
Yeah, I
this
understand.
container.
I understand. That's, you don't have to explain me that because it's obvious. So I'm just asking about
that will be an unknown. That will be the size, the color, the make, the smell of it. That will be an unknown. If you want to go explore the edges of the world or the ends of the world, maybe find that. That's a good question. How big? How high? The total volume, all of the numbers. That will be a good question. That's a blank.
Yes, but
to be answered.
Okay, but you don't have. Do you have any evidence to support that there is this container?
Yeah, you have gas pressure. Yeah, the evidence is that you have gas
doesn't-
pressure.
Yes, it's an
Gas
antecedent.
pressure
dude.
only
So there
occurs
is- there is
if
no-
you
there
have
is
a
no
force being
evidence,
applied
just-
to it. That
just
force can be
pressure.
explained through gravity. My
Dude,
guy.
if you have a person, right? If you have the steak, hold on a second, right? If you have a person, they had to have had a mother and a father, right? To create that person, it's the antecedent, right? So,
Okay.
no, you keep saying you understand, but then you go back to the same argument again. So we have to give you different analogies to try to get you to actually
sure.
understand it, right? Because
Sure,
we
I'm
can't.
gonna
We
give
can
you-
only, just let me finish explaining really quickly. Okay, we can only get so high off the surface of the Earth to check things in the sky. Obviously, if there's some kind of container, right, we would have to get up really high, much higher than what we can actually get to actually validate the specifics of the cow or the parents, right? Or whatever you want to call it, right?
You don't know any layers that are before you reach the container. But listen, let me give him the antecedent so you get it. Antecedent, one that precedes another. A preceding occurrence, cause, or event. Synonym, cause. You see?
Okay,
the cause of the gas pressure. So you need the cause for it to happen.
I understand
You
what
have the
you're saying, but
phenomena. You have the phenomena. You have the
Can I
gas
talk
pressure.
now?
You need a cause. And the cause that can only be demonstrated is containment. And you're denying.
No, the
No, I'm not
antecedent.
denying nothing. I'm just asking.
The other guy saying the other guy is gonna say gravity, but he cannot demonstrate that. The only way you can demonstrate it is with it and
I'm
container.
just asking. Can I
Nor
ask?
can you
No,
demonstrate a
the
container.
other guy.
You
Yeah, can I
cannot
ask?
demonstrate, my guy.
Can I ask something? So, if you have pressure in a container, usually the pressure is it's equalized. If you can make this experiment anywhere.
You're talking about an
Pressure in a
isolated
container. Wait,
system.
I didn't finish. Don't interrupt.
Whatever,
You
dude.
didn't
An
interrupt.
isolated system. We live in a dynamic system. There is heat introduced. There is
When you are
different
interrupting, I
temperature.
didn't finish my
There's
reasoning.
depth.
So,
You're saying you just said something that the pressure will equalize. You said that the pressure will equalize
yes,
in this
but I didn't
container
finish.
that you
So
float
let
in.
me just finish. So if you
In
have
the
a
place that you're
container,
in is a dynamic system.
Wait,
There's
look.
different temperatures. Are you listening?
No,
So the pressure will not be
can I
equal.
finish
Well, you're
my can I
saying
finish my reasoning, please? Do you mind? Okay, so I was saying there is if you have a container and then you put a gas, it doesn't matter what it is, and you put and there is a lot of you put pressure. You can do this with a machine, and then you put pressure. What's going to happen in this container? Any gas is going to be any gas is going to be everything is going to be at the same pressure in all points, right?
you're talking about an isolated. You're talking about an isolated container, like a propane gas tank. You don't have that in nature. You don't have that in nature. What you have is a dynamic system where energy can go in and out of the system. You have the introduction of you have temperature changing within different areas of the system. You have changes of temperature. The molecules are being excited at one point, being heated at one point, cool down at the other side. So you have this exchange that is happening. So you're gonna have different pressures happening all across the system. So it's not gonna be equal. He's saying no.
If you pressure,
you also have something that is demonstrated that can be demonstrated, that you have depth within a container. You have depth, and also you're gonna have different pressure within the depth of the container. If you have a very long tube and you have water or gas, you're gonna have a different pressure at the bottom and a different pressure at the top with depth. So there's a lot of variables in place to have the dynamic system that you're in. So it's not analogous to you saying, no, I'm going to have a propane and all the pressure in all of the volume of the gas of the container is going to be equal. It's not the same.
What is the concept of entropy?
What is it? Tell us.
So entropy is the tendency that anything has to be chaotic, in everywhere. So as you say that the Earth is a system, etc.
When you look at a terrarium, is that chaotic everywhere?
I'm not interrupting you.
We're talking about gases. We're talking about gases, and the entropy of gases dictate that they will increase, right? They will expand, right? So if there wasn't a container, in place, the gases will be leaving your lungs. And when you expand your lungs, listen, when you expand your lungs to open the volume, so the gas pressure around you rushes toward your lungs. If the entropy of gases was increasing, you wouldn't be able to breathe air. If the gases weren't contained, because they will be leaving your area.
Wait. When you go up a mountain and you are on top of the mountain, and when you are on top of the Everest, it's very difficult to breathe. Why? Because there is almost
that is pressure.
There is no more. So are you saying the pressure is going down so much?
You have depth.
You don't have. So to a point, there is. Do you guys believe on satellites? Yeah, I don't know.
Well, you're jumping from gas pressure to satellites. Yeah, there's a technology that we can send very high up. Yeah, what's wrong with that?
So I'm just saying that up there, the atmosphere is almost nothing.
There's no such thing as an atmosphere. You have the atmos, the air. There's no sphere of it.
What shall I call it?
Air, atmos. But you attributing a sphere. You're attributing a shape to it.
Okay. But there is almost no air. How can you explain this inside the container pressurized?
There is almost no air. What do you say? There is a lot of air.
Yes. What there is, but it's not. There is not. There is a lot of evidence that you don't have breathable air, and the air is almost. And if you go really high, there is layers that the atmosphere is almost nothing. And then you go to a point that is the atmosphere is really nothing almost.
So what? That's a pressure gradient. In this sense, this is not an argument for this. This is a pressure gradient. To have the pressure gradient, which is pressure, you have the container, you have pressure and pressure gradients.
Okay,
you see, this is not an argument against the container.
If you have pressure, okay,
to have a pressure gradient, you just acknowledge, bro. You just acknowledge that there is a pressure gradient, right? And to have that, a container is required.
Explain to me. This pressure is a force, right? Because the pressure needs because the pressure doesn't come from nothing.
The force, what causes
what is the
pressure
force that generates the pressure? What is the force?
The entropy of gases. The gases are expanding and pushing against the walls of the container and against other gas molecules. That's what's causing the pressure.
Causing the pressure. Because to have pressure, you need a force to push the gas.
That's gas behavior. The behavior, the gases are. You mentioned entropy, the entropy of gases, right?
But the entropy is a tendency to all systems in the universe. I cannot say universe. To all particles.
Gases move because of kinetic energy. So as soon as they get heated up, they move because of.
Even
no, bro, it's not a vacuum if you've got the gas in there.
So if you remove the air from a container, other container, if you remove the air, and there is something that is fields, but quantum fields, but there is no air because you can remove the air from a container, and inside this container, you still have something, which is quantum fields, and you can measure them. You know this. So explain. So if when there is pressure, the pressure is maintained by a force that is generating this pressure. Let's say you have a machine to, let's say you remove the air. You need to put the air back in. You just open the container, and the air is going back by pressure. What is generating the pressure?
That is amazing phenomena. That's great. Real quick though, Exion, that is amazing that you are telling us that, and I would like to see that demonstration. But it has nothing to do with.
I just want to say, if you want to turbocharge an engine, you have to have a device that is increasing the pressure, right?
Yeah. You gotta remember that all of these phenomena.
What is the force
to do with demonstrating the globe.
The pressure in this container that Earth is inside?
What is the force that's generating? That's a very good
pressure.
That's a very good question. What is causing the pressure?
Okay.
The gas is pushing against the walls of the container. That is causing the pressure.
Yes. Yes, but
what is causing the gases to behave the way they behave?
Is pushing the gas are pushing what? The walls?
The gases are pushing against the walls, right? Causing the pressure.
So, but what? So if they are pushing, there is something forcing the gas to push. What is it?
The wall, okay, the wall is there holding the gases. The force of the gases are pushing against the wall.
But why the gas has
energy?
About that.
Because of heat.
Because of the heat of what?
Yeah, temperature, heat, the heat.
Yeah, what does the heat comes from? There is no planet. It's just flat. Where does the heat comes from?
Wait, there's no heat on flat stuff? Oh goodness, I didn't know that.
I don't know. Tell me. I'm not. You are the one saying that there is some heat, not me.
The sun.
Remember the sun?
So all these forces must be generated by something. What is it?
Do you deny heat now?
No, I don't deny heat. I deny. We have sun. We deny sun.
Yeah. So when gas particles are heated, right, they move at like 500 meters per second due to the kinetic energy, and they move in straight lines indefinitely to fill any available space, right? And they only change directions from that straight line path when they have elastic collisions, right? So if the gas particles bounce off of each other or off the walls of their container. Now, to have gas pressure in the first I can give you citations for all of this, right? Okay, this is the mainstream explanation for how gas particles move. Now, the definition of gas pressure is the
Can you
force
give me
that
the
the gas...
formula, please?
PV equals nRT.
Pressure is equal to what?
Yeah, let me give you the... Well, hold on a second. I'm playing a game of chess with Vivek at the moment.
Oh, wait, I
Sorry,
want to be
Vivek.
part of the game.
I have to concentrate because he's like a master. So, just 1 second. I'll just pull up the definition of gas pressure.
What
He's
is
a
his rate?
master in chess.com.
What is Vivek's rate?
It's Lee Chess. Vivek's like a freaking 2200 or something like that.
Oh my lord. Well, never mind.
But yeah, so you can look it up right now. Just look up the pressure for formula for gas pressure. It'll come up with what I said.
But okay, wait, I'm gonna look it up. Yeah, but what about the heat?
What about the heat? The heat is what makes
What
the
about the
gas
heat?
particles move. Just heat in general. It comes from the sun or whatever.
Oh, comes from the sun.
Yeah,
so there is a sun. Because I don't know.
Yeah,
I had the
I
idea
mean,
that
I don't think anyone's denying the sun, my friend.
Okay.
Why are you acting like this, Axion? Do you think people don't look outside and see the observable phenomena? People label the sun, call the
Yeah,
sun El Sol.
I don't know.
Helion,
I don't
Helio.
know. I'm just.
You don't know?
Yeah, but
You don't
maybe
know.
you. But
You don't know?
maybe you
You
guys.
really don't know.
Wait, maybe you guys. I don't know because maybe you guys could say that the sun is something else.
The sun is what it is. You are the one that claiming that you know what it is. Remember?
No,
You're the one.
I didn't. Well,
Or the
it's
globus.
already
No.
already explained. It's already
The
explained.
sun
Don't
is explained.
don't
What is that
overreact.
explanation? What is the sun? Since you
You
know,
said there is a sun. There is
the
fusion.
sun is the sun. Yeah, is the sun.
There is fusion occurring in the sun, and you want me to
Fusion.
explain how the sun works?
You know the mechanisms of the sun. You know that stuff.
Yes, but I don't want to go into that because we are in a container.
Do you really know, or do you believe you do? Is there a difference? Can you go to court and can you go to court and testify that you know the mechanisms of the sun?
Well, it was reproduced. It was reproduced in a. It was reproduced
container?
in a machine called.
Without a container.
You have many machines of fusion. A machine. So you know this fusion
Was
reactor.
that a container? Did they have a container?
No, it's not. It's a container. You can call it container, but in my point of view, like when you say container, I see like
it's not a container, but it is. Which one is it?
I see like a square with something inside. It's not a square. It's a reactor. Could be in the shape
sounds
of
like a container.
Tomahawk. They call it tomahawk. And they call it, wait, there is one they call tomahawk, the other one they call a stellator, and the normal one, it's just a coil, because the plasma is maintained with magnetic fields.
So not gas, plasma, different phase.
Yes, I said plasma.
Yeah, we know. You are claiming in order to have gas pressure within a container, you need gas. Plasma, not gas. Plasma is plasma. Gas is gas.
Yeah.
Liquids
Yeah,
are
it's not
liquids. Solids
analogous.
are solids.
I'm just asking. Don't be offensive. Talk normal.
I'm
I'm
not.
just asking you.
He's
Where does
talking
the
normal.
where,
You're the one claiming. You're the one we're
what's
saying
the
that you
question?
believe that people here claim the sun to be something else than what you believe
No, I
it to
said
be.
maybe. I said maybe. I said maybe. You know, that's possibility. Maybe it's possibility.
Action,
It's
is it a
possible.
possibility that you have a misconception of what the sun actually is, and you probably don't actually know what it
No,
is?
no,
Is that a
no,
possibility,
no.
or do you 100% know what it is and how it works?
No, I don't know 100% because I was never there. You know,
There you go.
experimenting the
That's a
sun.
good one. So if we just observe the sun and the environment behave certain ways, like the gases, we were talking about gases, and they get excited, and we get climate and all
So
of these
there is,
things.
and there is a force. There is a force that is applied to the gas. Where does the force come from?
There is
That's the
the
question.
what is causing the heat, isn't it? What is exciting the gases
Yes.
to do what they do?
So it's the heat. The heat is generating the pressure. I'm confused. Can you explain? This is question and answer.
You're confused
Question
about the
and answer,
sun
right?
exciting gases? Okay.
No,
Yeah.
I'm confused. Well, I'm confused about your explanation.
That's not my explanation. You can look up the gas
What
descriptions,
is
the
causing the
way
pressure
gas
of the
behave.
gas?
The
Gas
container
behavior.
Temperature.
and the heat is causing the kinetic energy, right? And
Okay, where does the heat come from? Wait,
the
wait.
sun, bro. We just went over this 5 minutes ago, dude.
Okay. Nice and easy,
Oh,
one
comes
step
from
at
the
a time.
sun. But we are,
The
if we are
sun-
in a container, so this container
Axion.
doesn't block the sunlight.
Axion. The sun heats up the ground. The air that's against the ground, what happens when it's heated up? Rises. Creates difference in pressure because it's at a different temperature, so it moves around. That's it.
So are you saying that the sun hits the ground and the ground what?
That's a part of it. The sun
didn't listen.
is your heat source.
My heat source, okay.
The sun, yes, the sun is the heat source.
So the sun, but okay, is the sun inside the container or outside the container?
Don't know, dude.
You know why he's asking that, DJ? Because he's asking, if there is a container, how can the heat be coming into the container?
No, I'm not. Don't assume. Just reply.
He's asking. He's being ridiculous right now. At this stage, he's being
Actually,
intellectually
no,
dishonest.
Hey, DJ, I'll bite. Yes, it is inside the container.
So this container is able to gather all the sun energy and doesn't blow up.
You are in an exceptionally large dynamic system. Maybe, just maybe, the sun doesn't put out as much energy as what is claimed by your scientists.
Or not enough energy to blow it up. Remember, because heat dissipates.
Correct.
Remember, you have the day cycle, and then you have the night cycle, and heat dissipates. Remember.
I don't have scientists. You know.
Doesn't sound like it.
Axiom, have you ever seen a terrarium that you can build a container inside? You can put soil, water, plants, and it has like a dynamic system in it. And the heat source or the light can be outside of the terrarium, outside of the container. So, or you can put it inside too, or you can put multiple lights in the terrarium. You can put a light outside, and you can put lights inside of it too.
Yeah, but depends on the material, you know, because a material towards such a.
So it's not too difficult to conceptualize, right? It's something that can.
Can I finish?
That can be built.
So something Well, someone built this container. That's what you're saying?
I mean,
At no stage in the last 5 minutes did I hear somebody say they built this container.
No, I'm asking.
Or
I'm asking.
inferring that
I'm
someone
asking.
else did build this container.
well, the terrarium, I've seen
Catches-
people building them. The terrarium.
Axiom,
That's what I said.
the problem is we know there's a container there due to gas laws. We need the container for gas pressure.
So wait. So the sun. So this gas pressure is everywhere. It's even in the sun, right? The air is everywhere. So the sun, as the gas goes, they
Bro,
go
stop
until the sun.
strawmanning us, dude. This is ridiculous. The things you're saying right now, you're just trying to
I'm
like
trying to
mock.
understand. I'm just.
No, dude. What you're doing is dishonest right now. Now you're strawmanning us constantly, right? You're being fallacious. Now we told you clearly, right? We have the antecedent, which you said you understood what antecedent meant, right? So you were trying to cut us off when we were trying to give you analogies. Now we told you we can only get so high. We don't claim to know the details of the container, but we have the antecedent, right? Just like if you have the beefsteak, you don't have to prove, right, the color and size of the cow that it came from because you have the antecedent. Okay? Same sort of thing. We don't know what the sun is specifically, right? But we know that we get heat here on Earth, okay? And when heat excites the gas molecules, right, they move. Yeah? And then you need a container and gas molecules, and then you can get gas pressure. But you're going to need the container, and you don't have that for your globe.
But you have any evidence for this container, or is it?
Dude,
a
I
question
just
of faith?
told you it's an No, we have the antecedent, right? So just like I don't have evidence right now that you have parents, but I know that you definitely had parents, right? Because you exist, because you're the antecedent, right? Don't make us keep explaining it over and over again. You thought you had a gotcha, but it's not a gotcha.
Are you saying that, Axion, are you saying that you're not conceding that a container? Are you not conceding that a container is required for the gas pressure? Are you saying there is a different mechanism?
I'm
Axiom,
just
are you
asking
proposing
because
a
I want to
different
understand
mechanism?
your point of view. That's all.
Yeah, I think you want to. I think you want answers to questions that you have no You have no way of getting to a frame of reference to answer these questions. You want to understand the sun, you can't get to the sun. You want to understand this place, and yeah, it's natural. People want answers to these questions, but simply trying to infer that somebody else has the answers, it doesn't make it so.
You don't. You guys probably already read about fusion reactors. That's how we believe that the sun works. To achieve these temperatures.
Exactly. They believe it.
You're not going
But
to
nothing
be
to do with the globe, though. That has nothing to do with the globe. That doesn't demonstrate the globe.
What globe? I'm not talking about globes, dude.
Exactly. So nobody's disagreeing. If we can demonstrate a reactor with plasma or whatever, sure, yeah, that's perfect.
What's that got to do with the gas pressure argument? It's got nothing to do with the gas pressure argument that we're having right now. Right?
No,
your argument was how do you have heat? And we said the sun. And you said, oh, what? You guys believe in the sun? What? Like, you're just being ridiculous.
Because I didn't knew because maybe, because you guys don't believe in a lot of
Because you guys are so crazy. No, what don't we believe in?
No, because you guys... No, I'm not saying that. Did I say that you guys...
Dude.
So
bullshit's not going to fly here.
I'm just trying to understand. Because you say NASA is not real.
Axion, stop. What do flat earthers do not believe in?
Believe in?
You guys don't believe in going to space. Because...
Why?
Because a guy told me here.
Something to do with the gas pressure. Yes?
No, there is nothing to do with gas pressure. What it
really?
Is, I guess nicely what it is. You can tell me. I don't know. because I don't know what's your idea about this. So
Do you
there was
need,
a guy.
okay, do you need a container for gas pressure? Yes or no?
All right, guys, I'm about to be heading up. Peace.
No.
So you
sure,
don't
yeah.
need a container for gas
Take care, yeah.
pressure. Please demonstrate that for everyone here scientifically. Whether you use somebody else that's done this or whether you show us an experiment you've done yourself. Scientifically, please show everyone gas pressure with no container. Or how about I be very specific?
I don't want to troll because
great
I was going to
difference. No, you're not going to sidestep this. You've just made the claim that we do not believe in space. You were questioned on this. Why? And then I'm quite certain with the guys that are in this panel, and I can only see the top half of it at the moment, down to Immortal.
I'm not
the
seeing
guys that are in here.
I'm not seeing this.
I can assure you now that they would have explained to you why space is not real if you are talking about gas pressure when I come in here.
Huh?
And now he acts stupid. Right.
Okay, so no, I'm not saying. So I'm just saying. So if you want an explanation, the explanation is gonna be.
I don't want explanation. I want you to scientifically validate your claim.
Well, that's an explanation. Like, hello?
No, it's not. Any drunk down at the pub can give you an explanation. Whether it's backed scientifically or not, that's another story.
Yes, it's backed up on Einstein theory. So
gas pressure, as in high air pressure.
If I cannot stop shouting, dude, relax.
I'm not shouting. My microphone's cutting out. Axiom,
you are shouting. Stop shouting.
You are going to prove to us gas pressure without a container.
Don't shout.
You can use Google.
So go for it.
Why do you ask him this question?
I don't want to use nothing. I'm
No,
playing
you
a
don't
game.
need to answer his question. You can just go to Google.
You guys are interrupting, dude.
I don't need. Let them talk. They don't.
If you want to make positive claims, if you guys want to make positive claims in here,
against how many guys? 5
Axion,
guys interrupting me.
Axion, you're interrupting me right now, bro. Right? You're in our channel. Come in here with respect.
Okay, so I don't talk.
Okay, so your White Knight's gonna get muted right now, and if you interrupt me one more time, you're gonna get muted, bro. You're in our house right now. You're mocking people. Yeah, you're in our house right now. You're a guest here. I was going to explain. Yeah, but you look, dude, you're acting like an absolute douchebag. You don't think that we can click onto it just because you're not shouting doesn't mean you're not acting like an asshole. Okay, it's obvious to to us that you're acting this way.
Don't call me if you call me asshole. I'm gonna call you dumb.
Okay, whatever, bro. If you want to be childish like that, don't act like an asshole. I'm not acting dumb. Dude, I'm the one that had to explain you the basics of kinetic molecular theory. No, you're not, dude. You're being an arrogant dick. Right? That's what you're doing.
No, I'm not.
Yeah,
so I want to explain. Shall I explain space-time?
No, you don't need to explain.
How mass change the curvature
we don't want explanations. Dude, shut the fuck up. Right? You're going to go on mute too. Right? Because you can't shut up. You have double standards. Right? Anytime anyone else talks, you just interrupt them. But then as if anyone speaks while you're speaking, oh, you cry like a little baby. Oh no, he ran away. Does his White Knight want to take over? You want to take over, Mr. White Knight?
Because DJ, you're just not really good at your job.
Let's go 1v1. Yep, sure, let's go.
Like, can you go back to DJing because you're not really good at like what are you doing right now? You're just embarrassing. What are you doing?
No, I'm not. Actually, what he was doing was embarrassing. I had to.
Thank you. Good boy. Good boy. See, this is how you're doing it.
I didn't see that coming.
Yeah, this is not how we're doing it, bro. Right? So if you want to have a 1v1, right, you're in our house. Right? So do you have any evidence of Earth curvature? Yeah, you can't have it. You can't have. Okay, so I'm the one, right, that can mute you and ban you from the channel. So if you want to come in here, you can have a normal, respectful conversation, or you can piss right off. Simple as that. Right? So if you want to act like a douchebag, it's not going to go well for you. Nobody cares, dude. You can just piss off.
Just so you know, Immortal, before he unlocks you, chanting over him is a form of muting. Probability, and I'm just throwing this out there, he's just going to hit the red flag on you. So if you want to answer the questions or ask your own, you're more than welcome to do so. But you trying to talk through the top of somebody is exceptionally rude. So please don't. DJ, he's yours.
Yeah, so, I mean, I'm going to ask you the question. If you don't want to have a normal conversation, then you can go back on mute. But you're going to answer the question, right? Or go back on mute. So I'm going to ask you, do you have evidence of Earth curvature?
Well, first of all, it's really funny how you're abusing your...
Can't answer the question, can you? You're not here to have a good faith conversation about the topic, right? The topic is flat Earth. Okay, you just want to come in here and you want to whine about flat earthers. It's not going to go like that, dude. Right, so unfortunately, you can't partake in the conversation. I just had a good, 2-hour conversation with another guy before you came in here. All right, so I can have a good faith conversation with people about any topic related to this. But you don't seem to be able to do that. You just want to whine. So unfortunately, it's just not going to work, bro. Can just keep spiraling out in the side chat until you get banned.
Yeah, you got to keep some type of level of control of the conversation, or it just spirals out of control, and you have people yelling over each other, and no one gets a point across. It's just not constructive.
Yeah. He just wants to insult. He's not here to have a proper conversation. So he needs to take a time out, unfortunately.
Yeah, and you get into the meta of, oh, well, you're abusing your ability and your power and blah, 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 blah. It's like, dude, now you're not even having a conversation. You're discussing the nuances of discord and moderation. It becomes like this cyclical, nonsensical discussion of, minutia. But yeah, that's what happens when we get into theoretical mumbo jumbo that people accept as reality about places that they have no frame of reference of. They don't even know what they're talking about. It's like, it's basically you're just living in the land of make believe. Well, let's talk about this imaginary place that no one can verify, and about these imaginary conditions that no one can verify. So it's not constructive, other than to expose. Yeah.
Sorry, you're lagging a bit, John. Didn't mean to. I was just going to say, we've got a couple of new ones in here. There was Sky, Pew Pew, Nautilex. I think there was someone else just disappeared. But anyways, if any of you fellows, ladies or gents, have questions, queries, concerns, curvature, please step right up, bring forth your claims. Let's see what you've got.
Yeah, sorry about that, guys. Do I sound better now?
Yeah, it's coming through fine, man.
You sounded clear. It's just that you were lagging a little bit. Like, I saw your green light come on to say that you were talking, and it held on for about 3 seconds before the sound came out. That was all. It's just really odd.
All right, cool. Yeah.
You want to see if anyone else in here that wants to have a chat about the topic? An actual good faith chat, right? Without insults, without interruptions over each other. Just ask questions or present evidence for the globe.
I see Sky.
Yeah, we got Sky in here. Welcome, Sky. We got not Alex. Welcome.
Yeah, he's a flat earther, not Alex. Not Alex.
Okay.
Yeah, I mean, if the people who want to have have conversations with us are basing all of their information on unverifiable content, really, it's almost like a non-starter, because it's literally make believe. Let's talk about make believe. That's why it doesn't work when you're talking about empirical evidence. Like a matter of fact claim about how the sun works and what the sun's made of. And I thought Gemsey was really doing a great job at, picking him apart, about how many things he's assuming to be real. Same thing with that Yankee guy who was in here earlier.
We got Sekai. Sekai, welcome.
Yeah, and I mean, you didn't insult Axiom too. You said his behavior. You were critiquing his behavior. You weren't critiquing him as a human being, which is
he was being passive aggressive. He was being very passive aggressive by the end there. It's like he thought he had like a gotcha type argument when he came in here. And it didn't quite work out for him, and then he started kind of spiraling, but in a way where he tried, they try to act like they're still being calm, but then they ask these like sort of trying to trigger you with these like types of questions. Oh, you guys believe the sun exists? Really? Like, just absolute nonsense.
Yeah, definitely loaded questions there.
Yeah, super loaded. Yeah, they think that, show me the container or you can't have, the gas pressure or something. I don't even know what their goal is with that argument. It's kind of ridiculous. Like, what's the container look like? But they're the ones claiming.
Even if their aim is to truly understand what's going on, that's a good faith query. But when you're speaking about something that can't be confirmed or denied, other than the fact that it has to exist, right? The container has to exist to have the gas pressure. They're one and the same. The two are linked. That's where they're getting lost in the sauce. It's like, that replacement theory problem that happens all the time in these conversations where people are like, well, you have to replace, what we already have in our mind, these concepts. So.
Yeah. You know, if we've already explained to him 3 or 4 times that how antecedents work and that we don't know specifics about the container, but we have the antecedent, and then every 30 seconds he keeps asking for specific details on the container, that's just a sign he's just not being honest. You know, he's just like, that was his little gotcha he thought about before he came in here, and he's kind of clinging to it.
Yeah, wouldn't it be great for everybody to know everything about the inner workings of this realm and how it was created and how it all works? I mean, it would be, yeah, it would give you that nice little warm blanket, right? But at the end of the day, it's not important when you're trying to stick to what you can know, not sit here and make assumptions based on other assumptions, you know?
It's also cool to have things to discover as well, you know, like kind of like in the Truman Show, right? How they kind of broke his will a bit, you know, and he was in school and he wanted to be an explorer, and they just kept shutting him down. They're like, "Oh no, Truman, everything's already been explored. Don't worry about it." You know, that's kind of what they want us to think about this place. Oh, we've worked out everything, you know, don't worry about it. Just listen to us. We know how it rains diamonds on Uranus and sideways glass rain, and, you know, we know everything about the universe, and just trust us.
Welcome to the new people. Welcome, Vanessa.
Yeah, welcome, Ark.
You guys got any questions? You can direct them to
Gemsy,
John Luna, or DJ. Beast, welcome, Beast. Beast, if you got any questions about the topic, go right ahead. Any of the new people, you're welcome to open your mics and ask your question. Sky just joined. Go ahead, Sky. Go ahead, guys. I'm just checking on the new people. Go right ahead. That might be a good question for Sky. How does the sky works on a globe? Go ahead, Sky.
Yeah, and if anyone doesn't want a VC, you can chuck some questions in the side chat if you want. Tell me about clouds, says the Beast.
What about clouds?
Yeah, clouds are another thing that debunk the globe.
When water vapor goes up, bye-bye globe.
Yeah, you can't have clouds on a globe, can you, Jamesy?
No way. No way. Can't have clouds, let alone water on a globe. Raj, Raj, if you want to ask any question to the panel, go right ahead. Raja.
I don't have any.
You don't have a question. All good, Raj. Sounds like you want to be quiet. He sounded quiet. Most people around these times I want to keep it quiet.
The topic still going on? The flat Earth.
Can you repeat that, Raj? Just try to get it clear. Get it out clear.
He said, "Is it?" Well, he just said, "Is there a topic going on?" But maybe Raj, you can think of the topic. V, welcome.
Thanks. Hello.
Hey, what's happening?
Welcome, V.
What are we talking about?
Is that V for volume? Volume?
V for vengeance.
Ooh. Thought it was for volume.
Nope.
Got any questions for the panel, V? Go right ahead, V.
V's left to go get some vengeance somewhere else. But we have user. Welcome.
I'm guessing user is a Tron fan.
All right, so we have Beast in the side chat, and they want us to tell them about the theory of evolution.
Oh Lord, here we go.
All right, so
Oh, damn. So wait, we have a sound bot in here now?
Yeah, we have Vivek is awesome, bro. He got us our very own music bot that lives in here.
Wow, that's so W.
So it can play anything on YouTube, but we just got to be careful for copyright. So I mean, when I played that clip just then, I just deafened the bot for a second just in case.
Damn, man. Shout out to Vivek. That's awesome, bro. Thank you so much.
Yeah, man. So yeah, if you type in arrow left and then help, yeah, just like that, and it comes up with all the commands and stuff. So basically, you just hit the little whatever the left pointing arrow and then type play and then just paste the YouTube link after one spacebar.
Hey, was that you who pulled that clip up?
Yeah, I just pulled it up on YouTube and then
Hey.
just played it.
Have you seen that clip from Sunny in Philadelphia where they're like, science is a liar sometimes?
Yeah, man. I know the one.
That's a really good clip. We should play that sometime too.
Yeah, I
Because
agree.
they talk about Newton, they talk about like Newton and stuff, you know? Especially when they come in, they're like, Newton, it's Newtonian gravity. Whatever.
It's hilarious, man.
Do they talk about El Newtonio?
Who?
El Newtonio.
What's that?
Is Newton's cousin. He was walking one day. He was walking one day in Mexico, and an avocado fell on his head, and he invented guacamole.
Okay. Shout out to DJ. You've been cooking all day today, bro. Is there any ops in here?
Yeah, I've been on for way too long today, man.
No, you're doing a great job, bro.
Meant to be doing a bunch of work on my business, but been procrastinating.
Damn, I know the feeling, bro. Sometimes you just want to feed the people the flat earth.
Yeah.
Well, I think DJ deserves some W's in the chat, guys. Throw a W in the chat for DJ, guys. I don't know if I should advertise this just yet because there's no plans in place. I got a spoiler. I don't know if I should drop it yet. But be on the lookout. We got a surprise coming to you guys on Thursday. So be on your P's and Q's. I'm about to drop a freaking bomb on you guys on Thursday.
You can't say that.
Yeah, I'm teasing it, man. I can't give away too many details just yet.
Go ahead,
But there's
FLP. FLP. You just joined. Shut up, CB. Shut the fuck up.
Why?
Oh, my bad. This is the English channel. I should use proper English. Can you close your mouth?
What did I do?
I was addressing FLP. You just joined. You have to cater to the new people. Cater.
Okay.
Sky. Oh, Moshkin just joined. Moshkin, you're gonna be joining CB's event?
I don't know. Maybe.
CCB, I just got you someone to go to your events. Easy.
It's like a debate. Is it a debate? It's a surprise, man. Can't say too much.
You like surprises, Munchkin?
I want to debate Flat Earth Dave.
Who's that?
Flat Earth Dave.
He's offering bitcoins for debate or something like that. So I would like to collect that.
But you have to provide a one globe proof to get your bitcoins. That's where you're gonna fall short.
So what are you going to offer Dave as proof of Globetard? There, Mushcone?
Well, I thought it was like a debate. Like we'd have a referee and you get points or something.
Yeah. So you're going to try to debate someone. How about you practice putting forward your arguments with us? If you can't get past us, you're not going to be able to take someone like Dave down.
You guys are too easy because I always beat you guys like every day. So.
That's fucking cap.
You struggle to beat time with a stick.
Yeah.
So what arguments are you going to put forward as proof of curvature? We're sitting back pretty going, you know what, it's measured flat. And what are you going to say when we say it's measured flat? You're going to say prove it. We're going to bring out our laser tests. We're going to slap down citations of how water at rest is flat and level. And then you're going to say, nah, I've got... And that's where you speak.
Yeah, I'd way rather do a debate with Flat Earth Dave than the FE 24/7.
Come on, he doesn't want to give out his. He doesn't want to give all his his guns out here. He doesn't want to beat anybody because he doesn't want Dave to be ready for him. He doesn't want to.
He wouldn't want to give away his best globe proof, man. It's worth 3 bitcoins. Why would he want to give that away?
So, Mushkin, if you give your evidence now, does that mean that after you give it here, it doesn't work anymore and you lose it after you use it here? Or
No,
will it stand?
In debate, I don't know.
You can use it here and then you can use it there, and you will win here and then you'll win there.
Yeah, your evidence still stands if it's true and factual. It doesn't just magically become null and void because you've ran through us like a dose of salts and then you're going to try someone else.
Yeah, let's just be clear though, Mushkane, I'm sorry. If you don't look, you have to get his app, right? If you have looked into his contest, like seriously, you'd have to get his app. You'd have to watch the featured video for 2 weeks. Plus, all of the evidence that you would have to bring, like any questions that you have or any globe proof that you have, you'd have to look through all of his, all of the links in his app and the frequently asked questions. You'd have to do all that, and then if it wasn't in any of there, then you would have to bring your evidence to him.
I have weeks worth of content to fucking look at me, so we just both go in blind, and I'll just take him down. I don't need to do research. I've already heard what he says.
No, that's the requirements to earn the Bitcoin. That's what I'm saying. You would have to do those things. That's part of his contest.
Yeah. Well, make his contest then. It's unwinnable. He's the judge and the referee. You can't win that.
No, bro, listen, you have to take this a bit more seriously. Once you present your evidence and it's irrefutable, if he says, no, I'm not paying you, you sue him. And then in court, you demonstrate, the globe, and you win again. You win in the debate. He doesn't pay you. You go to court, you win in court, and then you win.
I'm not litigious. I'm against that.
You'll get more. You'll get more than the original price.
You're gonna sue anybody? That's evil. Suing people is horrible. Getting people involved in people, I would not.
Are you saying?
Don't wish that on your worst enemy, dude. You don't want to be
suing. Then scratch that. Are you pre-assuming that once you present the evidence, he just won't pay you?
Maybe he might not. I don't know. If I really changed his mind, I got to change his mind though. It's not really about me presenting the evidence. Well, it is, but the evidence has to be so good. It's really about persuasion. I just got to persuade him in a debate. And real time, give him real time cog dis, and then boom, slam it home, and then he might just like break down, and I win it. I think
The
I can
only
do it.
one that suffers from cog dis is you, my friend. So how are you going to give him real-time cog dis? He knows, as we do, the ground is measured flat. So if something is measured a particular way, how are you going to say, nah, it's still a ball or it's still round when it's been measured as flat? How are you going to get around that? Unless you've got measurements that say otherwise, in which case we then have contradicting terms, your measurement versus my measurement, and then we have to look into it further. So unless you come forth with a measurement of drop over distance, you're not going to stand up against him. You can barely stand up in here. Actually,
welcome to the new people.
You may as well stay laying down. Keep your head below the radar.
I think a debate with Flat Earth Dave would be way easier than a debate with like somebody with you. So I wouldn't agree.
I'll take that as a compliment.
It was.
You just said the opposite a
I
second
said
ago.
that about Flat Earth Dave. Whenever I hear his debates or his little arguments, I don't think they're very good. He doesn't do a good job. One time I thought he was going to admit it was round. It seemed like he was really thinking about it. I was like, oh shit, but then he didn't. He was like taking the other guy's point, like, oh yeah. Which is, I don't know, that's good if he's being honest, I guess.
Anyways, there's a whole truckload of new people that have just rolled in and out. We've still got Talk down the bottom. We've got Sky. Awais Tariq. Who else have we got? Hamil.
Brownies.
Al-Hima. And CB with his little salute there. I don't know whether he'd have to be a baller for sure.
Oh, CB is definitely a baller.
I know you've been camping out there for a while. But anyways, guys, for all you new ones, welcome. Please, ask your questions. Don't worry about Mushkane. He's just a pretender clown.
Oh, shit. Mushkane going to sit there and take that?
Like a man. But if any of you new guys have questions, Skal, you're another new one. Welcome. Or Skal. Sorry if I pronounce your names wrong. I apparently speak English, even though it doesn't sound like it sometimes. I'm not as lucky as a few of you who are bi and polylingual.
All right, Mushkin. If you debate CB and you can win, you're ready for Dave.
I'm ready.
Wait, what's
Go
that?
ahead, High Drug. No, nothing on High Drug. Go ahead, High Drug.
What's on the line?
Welcome, High Drug.
Thanks, bro. It's cool. It's cool.
It's cool?
Yeah.
I mean, it's not hot. It's cool.
Right now it's pretty hot.
It's pretty hot.
Yeah.
But it's not cool.
Well, it's not cool. Yeah, it's pretty hot.
There you go. Welcome to that. Heat and cold don't work on a globe, so therefore no globe.
Oh, are you French?
Yeah, I am.
Wait, are you Mexican?
No, I am French.
All right, W Baguette boys. Is the Earth moving in France?
What?
Do buildings move in France?
The buildings move in French. That's what I understood.
Yeah, like does the Earth move?
Sorry, I didn't understand. Sorry. I'm trying to.
Are you on?
I'm trying to enhance my English.
You're doing great, man. You're doing good.
Thanks, bro.
Do you think the Earth moves?
Do I think the Earth move?
Yeah.
Well, no, I don't think so.
Oh, okay. Me neither.
Good job.
Just the
That's
Earth
way better
rotates.
than many people.
Wait, rotates?
Yeah.
Oh shit.
So then it is moving then.
No, it's moving, but it's rotating. Yeah.
Okay.
Like it's turning on itself.
Why?
I don't know. That's just how the the nature is.
Okay.
That's why right now this beach turned on the sun, so that's why I feel the summer.
Because it's turning?
Yeah, it's turning. It's turning.
I don't think so, man.
Well, yeah, it's rotating now. Or is it the sun
Yeah.
that? It's the sun
Good
that
question.
rotates.
Good question. Yeah. Do you see the sun moving across the sky? Do you see that?
No, I don't see it.
I got 2 and I'm done. Gotcha.
What was it? Oh, hydro. So you saying that you don't observe the sun moving across the sky? You never seen that?
Well, the sun is just the sun just stays still. From my perspective, from my human eye, I just see a sun. But
So when you look at the sun in the morning, rising from the east,
yeah,
and then 6 hours pass by and it's noon, 12 noon, midday.
yeah.
Did the sun change position in the sky?
No, I think no, the sun just don't move from my knowledge. It's the earth.
Would you be able to test when you with your eyes, with your vision, your senses? You use when you cross the street in France and you're gonna cross, you observe the cars coming and going, and when it's clear, you walk to the other side of the street, right?
Yeah.
Yeah, and then when you see the birds flying across the sky, you see the airplanes flying across the sky.
Yeah.
You see the clouds moving across the sky.
Yeah.
And then you see the sun moving across the sky.
No, the sun for me don't move. No, I just see the sun. Just see the sun. He stays still.
Have you ever seen a time lapse of the sun? Have you ever seen a time lapse? Because it takes hours for it to move from one side to the other side.
Well, no.
You're saying you don't see this in France? When you're in France, you don't see the sun moving across the sky? Nobody sees the sun moving across the sky in France?
Well, I just wake up. The most time I spend is in night. So I just do my thing in night, and then I go to bed, and I wake up, and I see the sun. I don't even notice the sun, because it's something normal. And for me, the sun just don't move. It's just here. I just wake up.
Okay. 'Cause you don't go outside to look at the sun. You don't see it moving, but still, that still happens. You know, morning, noon, afternoon, moving across the sky. That's cool. You've only learned, like in cartoons, like you think the Earth is spinning and that the sun, like you're saying it doesn't move. How to approach it with you? The Earth is not curving, and the Earth is not moving.
It's not really important, but yeah, it's a scientific question. Yeah. Does the sun rotate over the Earth, or is it the reverse? But I don't really care, you know.
So there's places across the world like the Arctic Circle or the Antarctic Circle, where people can go there and they see the sun doing like a 24-hour sun across the sky. Have you ever heard this?
I heard I just heard that Sweden people have an endless night, you know. Yeah, I heard from Sweden people that have an endless night. They because of the sun. I can't even.
They have 24-hour sun. 24-hour sun. So even though you said that you don't see the sun moving, people out across the world, people observe the sun moving, right?
Well, from France, I just see the sun and I notice he's still.
You see the sun still?
That's
hilarious. I never heard anybody saying that. You're the first one. You're a unique person. Never seen the sun moving across the sky.
No, for the sun just stay still for me.
Do you think it's the same for everybody in France? Everybody sees the sun still in France? This is like a French thing.
It's not a French thing. It's just my point of view.
What about the moon? What about the moon? Do you see the moon moving, or does the moon also stay still?
The moon just stays still too.
This is a French thing, I'm telling you. Only in France.
It's not a French thing. It's just my point of view.
It is a French thing because you just said that in Switzerland, you said that they saw the sun moving. Remember?
No, I didn't say that.
What did you say? I told you the 24-hour sun, the sun moving, and then you mentioned Norway or something. You mentioned one of the northern countries.
I mentioned Norway because I know Norway or Sweden have
Sweden
have endless night. You know, they have
a longer day.
No, they have at some point they have
24-hour day
that can last for. They have night that can last for not just a night, but just the night can last for
24 hours.
No, more
than 24 hours.
Yeah, but anyway,
1 week, 2 weeks.
Yeah, maybe 2 weeks.
Yeah, that happens. That happens in many countries. So you see, if you reference that, that means that the sun is moving, because if it wasn't moving, that wouldn't happen.
Yeah, the school is not like I give a shit, you know.
Because some days during the year they have the sun, and some other days they don't have the sun. You see, so the sun is moving.
Okay, the school I don't give a shit. I mean, why would I give a shit if Earth move or Sun move? You know, it won't change my life, and I don't really care, you know. But yeah.
That's a great attitude.
Okay, go.
Well, just out of curiosity, if you don't give a shit, what are you doing in here?
Well,
He's
I'm just
practicing his
here
English.
to, yeah, I'm just trying to talk English with English people.
Well, fair enough. It's not to do with what the shape of the ground is. It's the questions asked after you understand reality better. The questions that you will ask, not that what I will ask of you.
So I didn't understand, bro.
Well, the Earth is flat. How did it come into existence? In the heliocentric model, we're told of this Big Bang. If it's flat, does this Big Bang still apply? I think not. So that
Big
means
Bang.
if it didn't just magically appear out of left field, it must
Big
have been
Bang,
created.
Big Bang has no. I mean, Big Bang. Why do you talk to me about flat Earth and then you talk to me about Big Bang? There's no.
No connection?
No connection.
Good. That's what I'm getting to. There is no connection. So if not Big Bang, then how did it get here?
Bro, I cannot. No one can answer that specific question, bro. It's impossible to answer.
Well, it was either created or it magically appeared from nothing.
Yeah, that's It's not the only thing we can speculate from human point of view is that it just appeared magically.
So it appeared magically. These are the questions that come forth after your realization that the Earth is measured flat.
Bro,
Questions of creation.
Actually, for magic, you need a magician and a mind to be able to observe the magic.
Yeah, well, welcome to everybody who's joined the room recently. We're just having a conversation with Hydrog here from France. If anybody
That's
has
right.
any questions regarding, if anybody has any questions in regards to the room topic, feel free to mic up and introduce yourself. Or if you're just here to practice English, please join the conversation. Thanks for being here. Thanks for watching and listening.
Hydro.
Yeah.
If something like the surface of the Earth, it's not curving, can it be a ball?
That's what.
Can you repeat your reply?
What?
If the surface of the Earth is not curving, can it be a ball, a sphere?
Yeah. So what, bro?
Okay. If it's not curving, can
Yeah,
it
not
be a
having.
sphere?
Huh? Bro,
You get it?
it's not even a question, bro. It's not.
Yeah, it's a question. It has a question mark at the end. You know, questions have question marks.
Oh, you can't express a question mark in vocal, you know? I don't know, bro. Are you just trolling? I don't know, bro.
No, not trolling. Listen, we have measured bodies of water across the world. Big percentage of the surface of the Earth is bodies of water. You know this, right? Oceans, lakes, rivers, that kind of stuff.
Yeah.
So the surface of Earth or the waters across are not curving. Water is described as flat, horizontal. You get it?
Yeah, I got it, but I mean,
So the Earth cannot be a ball.
the Earth has not be a what? Sorry, I didn't understand the last word.
The Earth, you know, this place that we walk across and navigate across, the place that we're standing on, this place that we're in, the Earth, it cannot be a ball, cannot be a sphere. It's not a sphere.
I'm poor. What do you expect from me to answer, bro? I cannot speak about that, bro. I don't know.
No, man, I'm just saying, like, remember, like I said, the surface is not curving. It's not a sphere. I'm just saying.
Bro, I don't know. You just say things without really knowing it, so. And then you just try to like ask me a question. If I understood well, bro, I can't answer this, bro. So yeah. I can't.
It's an observation and a measurement. It's not. I mean, the question that I asked you was about if something is not curving, can it be a ball or a sphere? And the answer, you say yes, but the actual correct answer will be no, because spheres will have to curve, right? Is that correct? A sphere curve, like a basketball, tennis ball, football, they curve.
Yeah, sphere. Sphere is a sphere. It curves. It's a ball. Yeah.
Yeah. Can you have a ball that doesn't curve? A ball that is not curving. Can it be a ball?
My favorite sport is skateboard. I play skateboard.
The who?
Easy E, can you wait your turn? Jemsy's talking to Hydrog.
Oh, someone else has a question? They can ask questions. Hydro, it's okay.
It's Easy E.
Tell me.
What happened? You got a question for John Luna?
Repeat, please.
I think someone has a question.
Yeah, we're discussing the room topic of the flat Earth. Just seeing if you had any questions or if you're just here to practice English. Welcome to the room, by the way. Welcome to everybody who just joined recently.
Wait. What is the Jesus Christ? What is the topic in the discussion?
The topic right now is that balls curve and horizontals, straight lines or horizontal lines don't curve.
Yeah, but Why do you speak about this, bro? I don't. I mean, you're trolling, or I don't know.
Man,
It's not true.
no, it's not a troll. But if you think it's a troll, just it's okay. Just don't worry about it, because you've been saying that multiple times now. It's like you're not even serious about the conversation.
Bro, you're saying like a sphere has curves, and then you speak to me about horizontal line.
Yes, you know, when you build the structure, the place that you're in, right? The building that you're in, we use a water level. And we establish a horizontal frame of reference, right? You know that, right?
No,
with the sea level, you know the sea level?
The sea level, yeah, but what?
So we have levels, horizontals, parallel to each other all across the world, and you cannot have this on a sphere, on a ball. You cannot have horizontal lines on a ball, but we have a bunch of those in reality.
You can have a horizontal line on a ball.
Exactly.
I mean, a sphere. You
Exactly.
can just, you cut the ball in half. But I don't really know where you want to go with your
line of questioning.
Speaking of ball, bro, I don't.
You know the sphere that people show you in the school books, that people say, and they show you in the cartoons, you live in a sphere, you live on a globe. Remember the globe that they showed you in the TV shows, the superheroes saving the planet, the ball, the sphere, remember that?
Bro, I don't have memories of that, bro.
Hey, good for you, man. Good for you. So therefore, you don't live in a sphere. That's it. That's the topic of the VC. If you don't believe in that, good for you.
Bro, I believe the Earth is a sphere, but why
you
would
do
it
believe it's
matter?
a sphere?
Why would it matter now? I don't know, bro.
Never mind. You don't care about it, so it's not a big deal, dude.
Yeah, I don't really care about the.
Yeah, that's fine.
The
You don't
form
got
of
any
the Earth.
questions. You don't. You just here in the VC, just asking about why it doesn't matter. It's okay. If you're not interested, I'm not interested in talking to you about it either. That's good. It's okay.
I'm sorry, bro. I just don't really understand your point. You're talking to me about balls. Well, a ball. Then you're talking to
Remember,
me.
you're the one that believes that you live in a ball, and I'm trying to tell you it's not there in reality. It doesn't exist, even though you believe it, but it doesn't exist.
Like you mean a ball doesn't exist?
The
He's talking about the Earth as a sphere. The Earth as a sphere is not accurate, right? It's a concept that has been pushed on the youth, right? Pushed on people as children. So
Maybe anyway. Why would it matter to think the Earth is a sphere or I don't know, a square, bro?
not a
We don't
sphere.
give a shit. We don't really give a shit.
No, I understand. No, we've gathered that, brother. It's okay. If you don't want to discuss the room topic, that's totally fine. So we respect your position, and your English sounds pretty good, brother. Sounds pretty
Thanks,
good.
bro. Just I'd rather speak about something meaningful, because if you talk about the Earth form, I mean, I don't really give a shit. Can be a sphere,
Well, if you
can
don't
be a
mind,
square. Why would I mind, bro? I'm just living on here, so.
Yeah, just put
if you
yourself
don't
in
mind,
mute. Go ahead, Hydro. Just put yourself
if
in
you
mute.
don't mind.
Go ahead.
Yeah,
No, for
I was
now,
about to ask him
I
that.
have no subject to talk. Bro.
No, it's okay, brother. Thank you for your time, man. Thanks for chatting with us. Yeah, just mute yourself, and we're gonna move on to a different speaker.
Yeah, man.
So, Easy E, did you have something that you wanted to ask, or were you just trying to clarify what the server topic is in this room? Okay. Well, if anybody has any questions or just wants to practice their English in regards to the room topic about the lack of curve on this earth, please mic up and we could talk. Otherwise, if you don't feel comfortable miking up, please just put your questions in the side chat. Be checking the side chat to see if there's anything that we could clear up or clarify for you.
Well,
The
you
people
just
who are returning,
wanted to have a conversation with me. I'm sorry, but yeah, you wanted to talk about the lack of curve in the Earth. That's right.
that's correct. You're starting to get it, I think.
So, okay, I'm interested now. So, explain your point, please.
Yeah, did you? I posted something. I tagged you in the chat. If you click on the text bubble in the middle of your control panel there, and what time was it? It was at 48 minutes past the last hour. I tagged you. That's a long distance observation that proves that the Earth is not dropping. It's not curving away from the observer. So
I have a hard time to understand what you mean by curving. Curving, you mean it's a sphere, ball, right?
yeah, from your position. Yeah, from your position, right? Everybody has their own position on the surface of the Earth. So everybody has a position. From your position, if the Earth is a sphere, there has to be a measurable drop down from your position. So down and away from your position. That would be curvature. So I mean, be curving down. So that's what we would call drop over a certain distance.
Okay.
Yeah. So that's what we're looking for to prove the sphere. And if we don't find that, then we know that we're not living on a sphere.
But when I look at my balls, they are very round.
Hey, lad, try and keep your conversations appropriate for the audience, please. We have many people here that don't deserve to listen to that nonsense.
My bad.
So it's a French guy.
So like that guy said, there's examples I brought up earlier. Balls that we have in reality are round, right? Basketball, footballs, all of those things. We can measure curvature, and given the geometry that we label them as spheres. But when we go to the Earth, we measure the Earth, and it doesn't measure to be curved, so it cannot be a sphere. It's not a sphere.
Well, you're talking in scientific language, bro. Do you have scientific knowledge to say that Earth is not a sphere? I don't know. Anyway, let's talk about something else. Where are you from, guys?
I'm from the United States, but yeah, we try and keep this conversation about the server topic and the room topic only because we're streaming live on YouTube.
Okay.
You see that bot at the top left corner.
Okay.
And the audience members that pay attention, please. The audience members that tune into our channel, they would like to hear about the server topic and the room
I'm
topic.
sorry.
Right?
I didn't even. Sorry, I didn't even see the topic of the Discord. It's flat Earth. Okay. Sorry.
Yeah.
I just joined.
Yeah.
Without knowing. Yeah. Sorry.
Yeah. No, it's all right. It's understandable. It's an honest mistake or an oversight, as they would call it. But yeah, man, we're happy to have you here. We don't take offense to it. So
Yeah. So right
glad to
now,
help you learn.
I can understand better why you talk to me about the all those things you told about me. No, not about me. I'm just bad at English. You told about the Earth.
Yeah. No. It's understandable, brother. Thank you for bearing with us. I mean, surprised you didn't notice sooner, but I'm glad we were able to clear that up and clarify for you.
Yeah, I just saw the Discord title, so I just understand now why you talk to me about the Earth, the form of the Earth or whatever. I don't know. You are better at to explain this. Not really good. I don't know about science thing about the Earth. I just know it's a sphere for me.
Yeah, most people are trained in that. Yeah, most people are trained that to believe that in school, but they're not really given a lot of evidence to support why they should believe it, right? So it's a lot of just, hey, listen to what we have to say, memorize what we're telling you, and believe it as fact without verifying it.
It's true. It's true that we just bound to learn that Earth is a sphere, but maybe it's not. I don't know. I just learned it in school, or maybe just on YouTube, but maybe it's not. I mean, I can't really say. I have no knowledge about it, so yeah.
Yeah, some of us have been studying this topic for over 10 years, and we've been testing it and putting it to the test in the real world. So some of us know that it's not a sphere. I'm one of those people. Gemsy's one of those people. I'd just like to take this moment to address the people who are on the panel and just give credit where credit is due. We got Daz68 in the room. We got EZE in the room. We got Flat Earth Batman in the room. We got Flatulu in the room. Gemsy, Hydrog. We got Jenna Massey in the room. We got Kembo Beats that joined us recently. We got Kiwi Buzz. We got Lad. We got Lucas. We got
I see
OS,
there's a lot
Harry,
of people, yeah.
we got Quiet Noobs. We got Sky. We got T-Dub. We got Tacy. We got the Ultimate Flat Earth Final Boss. We got Vitalis. We got Carr, and we got Zigmoid. Thanks for being here, everybody, and thanks to everybody who's listening on YouTube. We appreciate y'all.
You have a YouTube channel, bro?
Yeah, you see the bot at the top left corner? We're live on YouTube right now.
You are?
So yeah.
I don't see, bro.
Yeah, look
I don't see
at the list.
I don't see any live, bro.
Yeah, there's a YouTube bot at the top left. Yeah.
Top left.
Hey Kembo, you able to mic up, brother? You want to say something?
I cannot see any live. I'm sorry.
Okay, no big deal. Anybody else want to talk? Anybody else have any questions? Anybody else want to okay. Thanks for that, Kembo. Kembo can't talk at the moment.
No, in the discussion, you can send me your live or your YouTube channel.
Yeah, if you go if you scroll up the list all the way to the top of the screen, you should see a 24/7 live bot. If you click on that, that links you to the YouTube channel.
Bro, I swear I don't see any live in the. I don't see any live, bro. It's unfortunate. I cannot see any live.
I'll see if I can find a link. I'll see if I could get you a link.
Yeah, can send in the discussion.
Yeah, I linked it. I linked it in the side chat, so you could go ahead and check that out.
I see that. Yeah. No, it's the Discord. Yeah, got it. Yeah, I have it, bro.
All right, cool. Yeah, so anybody who wants to elaborate on the room topic, please go ahead. Feel free to unmute yourself and introduce yourself. Or if you have any questions and you don't feel like miking up, you could go ahead and type them in the side chat. Hey, Jamsey, when did you become a flat earther? Do you mind sharing your experience with us, or are you busy right now?
1 second.
Oh, yeah, take your time.
I'm one of those tricky ones because for me, the flat earther is more like a title that you can wear based on the knowledge that you have about a topic, like if you're a mechanic or a doctor. And I wouldn't say that's what I am. I know about the topic. I wear the label for the T-shirt for the FE team, but I learned it based on we'll say the earlier memory that I remember having that had me question was more based on the first time I heard about it was in school. Then they said that Christopher Columbus traveled across the Atlantic and discovered America, proving that the Earth wasn't flat. I remember hearing that in the history class, and that's one of the things that kind of early memory. It showed me kind of like an idea, thinking about the cosmology of the world or the shape of the world, and the concept that there was two ideas in between the globe and whatever people label as flat Earth or whatever that was back then. And also, I heard some Brazilians talking about some a long time ago, talking about some beings that told the children that the Earth was flat or something like that. That was another thing that I heard. And also heard, stories in TV, whatever. But then years passed after that, and the Star Wars, the TV I learned in school, or it was a globe, whatever. So that was the belief I was holding for a long time. NASA, but then I came up with the moon landings. A lot of people questioning that stuff, saying that it didn't happen, and it was like a Hollywood thing, and a few of those ideas walking around my mind.
Just the thing that I don't understand is why would it matter that Earth is flat or a sphere? I don't understand why.
You think it's a good question. Why does it matter, right? But the fact that they are pushing it to you and they put it in your books, in the TV, in everywhere in the news, they push you the globe. You know about the globe, right? If it didn't matter, why do they push it to you in every moment possible? They push you the globe. You think it doesn't matter? If it doesn't matter, why do they show you the globe on everything? Tell me that.
Well, that's a good question. I can't answer to that. Yeah, it's a good question.
So I flip the question to you, and you can probably realize that it looks like it does matter for some people, because these people are pushing the globe to you everywhere, all the time. So it does matter.
I think for some people it's because they think it's true.
I just understand your way of thinking to defy how can I say, to defy knowledge that is sent from school or shit like that. But to me, I mean, it doesn't matter if the Earth is flat or a sphere. I don't really care.
You know when it does matter too? Have you ever gotten in an airplane? Have you ever traveled from France to a different place in an airplane?
No, I didn't take the plane.
Okay, if you ever get in an airplane or decide to travel across the world, is that an idea you might have in the future? Maybe travel to a different country?
Yeah, for sure, yeah.
So do you want, let's say you get in the airplane and you bring your family with you, you want the airplane to function and to work safely and properly, right?
Yeah.
Yeah, so the engineers of the airplane, when they are making the airplane to work practically in reality, they assume that the Earth is flat and motionless, stationary. So to make you travel in an airplane from point A to point B, to make it safely practical and workable, they do take this into account. So it does matter, doesn't it?
Well,
it does matter.
You mean in the plane driver, the plane driver point of view, you're telling me if that matter?
Not just the pilot. You said the plane driver, that's the pilot, right? The engineer, the builder of the aircraft, of the airplane, the builder, they take into account reality, right? And the ground is not in motion, and it's a horizontal flat frame of reference. So they take that into account to build the airplane. And then the pilot, that you ask the airplane driver, the pilot, also takes into account reality. Motionless ground, horizontal frame of reference, and that's to operate the aircraft so you can make it across the land or the waters across, so you can go from point A to point B safely and make it there. So it does matter.
So the pilots and the engineers just keep the secret from the public for no reason.
No, it's not a secret. It's not a secret.
But why do they say that it is round when you ask if it is really flat?
No, it's not a secret because the thing is that people just believe the contrary away from the actual realist level experience. That it's not a secret. Reality is not a secret. The secret might
But
be that
my
it's in your
friends
mind. You believe in something
aerospace
else.
engineer says that it is round, it is globe. Is he lying? Is he does he not know? Is he an idiot? I don't know.
The engineer that built the aircraft has to pre-assume to make the aircraft, build it, to make it work. They have to assume that the Earth is not in motion and flat, a horizontal frame of reference.
Mhm.
To be honest, I didn't really understand your point, bros. I'm sorry, bro.
Remember, you said it doesn't matter, but when people build things to work in reality, it does matter.
Yeah, I remember.
It doesn't matter to you. Remember, to you, you're the one that told me that you don't get out and you don't look at the sun, you don't look outside, you don't travel in airplanes. But like I'm telling you, for other things that are practical, a lot of this stuff does matter. And when you go to school and people tell you, you said it doesn't matter, the cosmology or whatever, or if it's a globe or is it flat or whatever. But the people that tell you it is a globe, it matters to them because they're selling it to you in the TV, in the movies, in the cartoons. NASA is selling it to you. So it matters to them. Even though it doesn't matter to you, it does matter.
Yeah, I understand your point. For this,
because people matter, and the airplane point was that it does matter because people care about their families, they care about themselves, and whenever they want to get into an airplane, it does matter to them to make the aircraft to work in reality. So they take reality into account because it matters for them to make it from point A to point B in an aircraft. So it does matter.
but maybe I don't know. Maybe they just tell you that in an innocent way, you know. Just tell you that the Earth is a sphere. Just to tell you that
Yeah,
Earth
that's the
is a
fantasy
sphere,
part.
you know.
The sphere is the fantasy.
You know, to me, it's a bit. It's like I don't really. I don't want to be vulgar, you know. But why for me? Wait. Why will it matter? Yeah. So you talk about the people that wanna make you think that the Earth is a sphere. Yeah, a sphere. But why would I give a shit, you know, about this, bro?
If you don't give a shit, I mean, that's you, bro. That's all you. Nobody's gonna stop you for not giving a shit about anything. But other people do give a shit. Other people do care, and that's why people talk about it.
Maybe
But that's you. You're the guy that doesn't care. That's okay.
Yeah, that's right. That's right. I'm sorry. I might switch vocal. I'm sorry.
It's okay.
Yeah, if you're gonna switch, it's okay, man. You have a good night, and thanks for
you
today.
too, guys.
Thanks
You
for
too,
spending
guys.
your time with us, man.
And
Yeah,
no
take care, brother.
No disrespect to your, you know, your cause. I mean, it's not like. I mean, I just don't get. Why would you argue about the Earth is flat or a sphere? But that's just your thing, so it's your choice, I guess. Good night.
Yeah, it's a lot to
Good night.
unpack.
Have a
It's
good
lot
one.
to unpack.
Yeah.
Yeah, cheers, man. Cheers.
Cheers, man.
There was another French
Yeah,
guy
Lad,
saying Earth is round. There was another guy that said
Lad,
that the engineers think it's round or make it round or
well,
something.
that's Lad. Lad is in the chat, and I mean in the VC, and I linked some content on some YouTube content that you guys can check on your own time if you feel so inclined. The videos are 19 pilots confirm flat Earth, and 35 government documents admit flat Earth. So yeah, check it out if you feel so inclined. But yeah, there's plenty of data. You could check our home server. We have a home server with terabytes of data. If you want to peruse through any of that, I can help broaden your understanding. But yeah, Dempsey, I was curious. So in your story, you were talking about how you started researching into the moon landings and seeing the inconsistencies there. And yeah, I mean, I'm definitely curious to learn the rest of the story.
It was mostly about looking at the day-to-day information that I got from the media, the news, the propaganda, and whatever was being shared about the nature of this world and whatever the globe and the ideas about outer space. And I looked into that stuff and it was kind of cool. I kind of believe it for a while, but eventually I came up with the conversation, people talking about questioning the cosmology and the term flat earth. There was other people talking about inner earth, flat earth, concave earth, and all of those things. So the term itself, flat earth or concave earth or globe earth, I don't label the earth or any of those things. Those are just strawmans to the actual physical reality that we live in, that is way more than two words, whatever. Flat earth, globe earth, whatever that is, right? Is the realist level is way more than two words or whatever, one description, or round or flat. That's at least me. When I jump in the conversation, I was listening people having conversations about it and questioning one side and the other. I saw YouTube videos of people talking about it, and some people presenting a bunch of ideas of how the globe was impossible and it didn't represent reality. And I went through the videos. I jumped into some VCs back then in Hangouts, people listening to that stuff. I mean, talking about that stuff and debating. And I was just mostly in the background. I did spoke a few times, but years, maybe like a couple years passed after that. And then I found the Discord and that stuff. And it was just me questioning the globe came kind of easy. It took me a while because I didn't took all the information fast. I was just looking into it, then doing other stuff, then working, and the information. I was just gathering the information and listening to both sides for a while. But then I realized that a lot of the globe made no sense, and a lot of reality made a lot of sense, and reality didn't add up to the nonsense of the globe. Kind of like that. And also, like the sea level stuff, the horizontal. People were talking about the horizon and what the horizon was. People talking about that stuff. And it kind of like mentally, I had that back and forward and thinking about it and what made sense and what didn't make sense. And eventually, I came to realize that the globe couldn't make any sense. The motion of it, all the nonsense, all these spins, all the movements in multiple frame of reference and multiple speeds all at the same time is all nonsense. And
there's a lot to unpack when you're looking at all that data and trying to make sense of it all.
When it actually clicked for me, it was when I was thinking about for kind of ironic that a lot of people in this conversation, like the flat earthers, right? They say, "Oh, don't look at the sky to determine the shape of the ground or whatever." I don't do that. But when it clicked for me that it wasn't a globe, it was actually the movement of the luminaries, because they move like I can describe. They kind of reset and they move in certain how do you say, patterns that, for me, in my opinion, require some type of design. Some type of they move in a timely manner, like a clock made by the creator. And it kind of clicked for me. I was like, wait, that stuff moves like it's a clock, and that's impossible on the globe. And that stuff kind of clicked everything for me.
But why is it possible on flat Earth but not on globe?
Wait, can you speak a little slower so I can comprehend what you're saying?
Sorry, why is it possible on flat Earth but not on the globe?
No, flat is the description of the ground. A description, right? The sky, the luminaries are not the ground you're standing on. The luminaries, the sun, the moon, the planets. That's not the flat Earth. That's the sky is not the flat Earth. No, not the same.
But why can the sky not move like a clock, like you have said, on the globe Earth?
Oh yeah, on the globe Earth, you wouldn't have the ground positions that are fixed on the ground, like all the landmarks and all the places across the world that are fixed on the ground, and the movement of the sky kind of resets and have those ground positions fixed. So it doesn't make sense that the ground will be spinning, moving across multiple axes and multiple speeds, and you still will have all of these landmarks and ground positions in reference to the luminaries. So that doesn't make sense. The globe doesn't make sense. Reality does.
Yeah, there's a constant motion in the heliocentric globular model, where all of the Earth included would be following the sun around a galactic center, never to return to where it was before. That's a huge problem for seeing the same exact patterns every year, no matter how vast of distances between the luminaries that are being proposed by the heliocentric model. So,
but the Earth spins with a constant period, and that is reflected in the view of the luminaries that we see, no?
Well, Lad, how many motions is the Earth making? Just so we could clarify that we're talking about the same thing here.
Well, the only absolute motion is the rotation, and depending on the frame of reference, there is the orbital motion as well, but it obviously depends on what your frame of reference is.
Okay, so there's three motions, right?
The Earth is in motion, and how many speeds included with those motions? Different speeds, remember?
Well, there are many speeds, but you can talk about 3 speeds and 3 dimensions. If you speak about translation.
So you're saying the Earth is rotating in its axis at 1,000 miles per hour, then it's moving across the solar system at 66,000 miles per hour, then it's following the sun, and the sun is moving at 600 plus thousand miles per hour, then the sun is following the center of the Milky Way, right, at almost the speed of light, and then the Milky Way is moving across fast, like all of those movements, all different speeds. That's complete nonsense.
Well, the acceleration is very small, so it is hard to detect.
So yet again, the movement of the luminaries fixed with the landmarks on the ground, it will make all of those baseless assertions nonsense. It wouldn't happen like that.
It depends on where you are on the Earth, no? Because if you are on the equator, the sky would be very different at different time of year.
So the celestial north, you can put a little tube looking towards celestial north, and you're gonna be able to see through that hole all year round for decades and decades and decades, and it doesn't move from that spot.
Yes, because the Earth rotates about the north axis. So the view from the north is similar.
So even
But
though it's
the
moving
equator is very
across
different.
5 different axes, 5 different speeds,
Only 3 axes.
you still don't see any parallax happening when it's supposed to be happening if the globe was the case.
There is a noticeable parallax at different points of the trajectory about the sun, and that is how we determine the distance to the stars. But it is, yes, very small.
Yeah, it's obviously fixed. The celestial north is not moving, and that debunks the globe right there. Just that debunks the globe.
But we do see the parallax.
You gotta remember that it's not just this. There is no curvature on the globe, and the globe requires curvature. There is no curvature in reality. There is no motion that you can show. The globe requires motion. There is no container on the globe. You require container for the gas pressure that we have in reality. The sky moves like a clock. You cannot have that on the globe. So when you put all of these pieces together, you come to the conclusion that the globe is complete nonsense. It's pretty simple, dude.
But the orbit of the Earth must maintain its mechanical energy, which requires a constant period, and therefore there would be a periodic motion of the stars.
No motion has been proven. That's the issue, lad. There's a lot of talk about motion. There's a lot of talk about these things, but none of this stuff has been verified. And that's the real issue here. What has been verified is that you have various space agencies reporting to you and all other people that there's a fixed radius of this alleged sphere, right? They're telling you they know the size. They're telling you they have been to space. They're telling you that they've taken pictures of this alleged sphere, and they're giving you these numbers. Now, with these numbers, you can calculate how much curvature you should find on the surface. And over large bodies of water, like the ocean or vast lakes, you should find some drop over distance. This should be easily calculable and perceivable, right? So doing long distance observations, laser tests, we've put their radius to the test, and there is no measurable drop over distance. Now, due to this fact, you have to take into consideration that due to the fact that there's no curvature, that it cannot be a sphere. That means that whoever's providing you with this data is obviously not being 100% forthcoming with all data.
But to be fair, you are giving me data and I have not done the experiment, and NASA gives me data and I have not done the experiment. Why should I trust you? How do I know that you are more trustworthy than NASA? When you do not have the money or the equipment.
You can repeat the tests that have been done by us, but you cannot repeat the tests that have allegedly been done by NASA. That's what I'm saying. The difference between the two is one is verifiable here on the ground by anybody who wishes to do so. The other, you have to trust others. You understand? There's a difference. There's a difference. You can do the tests. They're repeatable by anybody. They've been verified by multiple individuals. And on the other hand, you have the fact that, you have government agencies that are all in.
There are people who do the same test as you very many years ago, very long time ago, and they get different results, and they say the Earth is round. So there is a different consensus. The majority of people will say that they do the same experiment and they find it to be round.
Do it yourself. That's what I'm saying. You don't have to trust me. You could do it yourself. That's the point. That's the difference between the two. You have to trust them, which you seem to have no problem doing. And I don't have to trust anybody. I could go and prove it for myself. So there's the difference.
All I have to do is look at the sunset and the sunrise, and that is proof.
No, that's not proof. That has to deal with optics, and has to deal with a local light moving away from your position on the ground.
Well, please explain. I am interested in this area.
Well, looking at the ground is not. Looking at the sky is not going to measure the ground for you, buddy. That's the issue.
Well, But that could not happen on the flat
to
Earth.
determine the ground. Yes, it could.
I should. How? Well, please show me. I would love to see.
Well, the way your vision works, if something moves away from you, it doesn't appear to get lower, right? If you're looking down a long corridor,
It appears to get smaller.
Does the ceiling not appear to
It does
get
not.
lower?
It does not. It does not disappear over a horizon.
The sun would disappear if it moved far enough away from you, if the land is long enough, right? And the sun is local enough.
But by what mechanism?
It would just appear to get lower in the sky, just by the way your vision works and the law of convergence, brother. You know,
but
if you're watching something get farther away from you, and it's high above you, it's gonna just work its way down until it's lower in the sky. Just like looking down a long road and the lights that are right above your head.
It wouldn't go below the horizon.
It just gets smaller.
Yeah, it would converge to the horizon, but you wouldn't see it dip down below. That wouldn't make any sense.
Eventually, it's gonna get too far for you to see, brother. It's gonna disappear.
But we see it go below the horizon.
Yeah, but that's an optical illusion, dude.
But the refraction moves the image up.
You see the clouds. When you see the clouds touch the horizon in the distance, you know the clouds are still thousands of feet above the horizon, but they appear to be touching in the distance.
Right.
That doesn't mean you're looking at a ball.
Because of the curvature of the
your
Earth.
vision works.
But they don't disappear.
But they wouldn't disappear if the Earth was. I mean, just think about it mechanically, right? If even if it's super far away, it might get so small, but it wouldn't go under the ground. That doesn't make any sense. And refraction.
Listen, the ground is raising
with the
up.
measurable
The ground
temperature.
is not actually raising up.
With the measurable.
The ground is not actually raising up, sir. Like that's what I'm trying to explain.
I didn't say the ground was raising up. I'm saying it wouldn't make sense for an object to be obstructed by the ground if it was.
Yes, it would. Why? Because
about the mechanically argument that he's trying to make, you're still missing the mechanics of the luminaries. You don't have the mechanisms of the heavens above to be able to determine those mechanisms.
First of all,
excuse me.
Sorry, go ahead.
So the observable phenomena that you're observing from the ground, you're saying that it has to work a certain way. Sure, you can demonstrate certain things down here, but then you're saying that the mechanism in place, that whole variables, though all of those variables in place, you're still missing the mechanisms of the luminaries above. You don't have. You can only pre-assume or assume certain conditions. So you're still missing a big
luminaries.
The sun, the moon, the stars. You're still missing those mechanisms of how that stuff actually works. What are those mechanisms? You don't have that complete. And if we add refraction, right? If you're gonna argue refraction,
let's get to refraction.
If you're gonna argue refraction, you can argue that the medium that you're in here. And if there's mediums above and there's layers between those two mediums, you can argue there's refraction, and the observable phenomenon that you're in is happening because of certain refraction. But none of that stuff proves the globe, though.
Wait, can I just say something with refraction?
Go ahead.
Because refraction's brought up all the time with this sort of stuff. With the gradient of refractive indices of the atmosphere, right? Because we can measure the density and you can measure the refractive index of the atmosphere as you change elevation. If you model that out on a flat Earth plane, right, you would expect images to be shifted upwards, right? You can measure that. So it wouldn't make any... Because refraction is always used as this argument for why things appear to dip below the horizon. But just from measuring the atmosphere... Well, first of all, on a flat Earth, if you're just looking at something completely straight on at the same level, you wouldn't expect it to move at all. But the refraction that we measure projects images upwards, right? So it wouldn't make any sense for refraction to be causing this. Basically, what I'm saying is, if you can see something dip below the horizon, there's no way you can make that make sense. with refraction based on the refractive index we can measure at different places in the atmosphere.
You would need a reverse pressure gradient.
Exactly. Right, which doesn't make any sense because that's contrary to what we measure. I mean, and that's something where that's something that you can't make sense to me, because that's an easy thing to measure and verify, and you can directly observe things dipping below a horizon, right? I mean, you have to give me a mechanism for why things would appear to dip below the horizon when there's no the mechanism just doesn't make sense that you're proposing. Convergence doesn't make sense, and refraction would do the opposite.
You never seen this gif of people holding a candle between the table and I don't know, it's like a mirror or something, or a glass, and you can see the candle going below the horizontal on the table.
I mean, yeah, because they take if you're off by a slight angle, it's going to look like that. Think about a straight line.
To the point that I told you, that on the ground you're seeing one thing, and then we're adding whatever mediums are above in the luminaries, about whatever those mediums that you don't know what they are. You don't know the medium between you and the luminaries. You don't know what medium they are in, and you don't know what's in between those two mediums. The refracted and Snell's window, Snell's effect, refractions effect can be in place and can be part of the phenomena that we observe, but you're still missing certain mechanisms that you might be pre-assuming.
Yeah,
well, I mean, I'll say
with always have a factor in the way your eyes work, brother. No matter what you're witnessing, you're always going to have that vanishing point. That's the way you draw. That's the way your eyes see. I mean, anybody who's taken a perspective drawing class in high school or in elementary school or in college will know this. Now, I posted something in the side chat. This is a video of a sunset shot with a solar filter. You're always going to have an issue with the sky ramping down, the ground ramping up, and the left and the right of you ramping to the point of convergence. And that's always going to be the way your eyes work.
But
it doesn't change the fact that the clouds are still thousands of feet in the air, and they appear to be touching the ground very far off in the distance.
But even in that video, it goes below the horizon.
Yeah, like even in that video, it still gets cut off. It doesn't just get smaller to a point; it gets cut off by the horizon.
Watch the whole video, brother.
Yeah,
there is a discrete cutoff.
It's just not continuous. I mean, again, it doesn't we're not talking about a perspective drawing class. We're talking about basic physics. The mechanism you're proposing doesn't make sense. If I did a handstand, with the
globe doesn't make any sense, dude.
I mean, that's a bit of a claim.
Well, the globe doesn't make sense. You don't observe curvature. You don't measure curvature. Doesn't make sense about the rotation of the ground. That doesn't make sense.
I'll just say, having worked on high-powered rocketry and telemetry, yeah, it makes a lot of sense.
Yeah,
with the measurements we get.
Rockets go
yeah,
up
and when you work on guidance systems that use GPS and magnetometers, right, and you have to take into account navigating on lines of latitude and longitude, not a discrete coordinate plane. There's it makes a lot of sense.
There was somebody who claimed. You can have navigation on a horizontal from a reference and a motionless ground. You can have devices that go high up, like whatever GPS devices or whatever you're claiming those are. Satellite.
I'm just saying what I've actually worked on, like hardware and software and measured things.
Nothing to do with a globe.
I believe it was Jim C. who claimed that aerospace engineers assume the Earth is flat and does not move when they make their calculations. And it is like that the planes do not crash.
Because as an aerospace engineer, that would surprise me that you would claim that, because we absolutely don't.
Aerospace doesn't mean outer space. Outer space.
It's a combination of aeronautical and space engineering. It means both. I mean, I don't know why you're getting the semantics of it. Because if you claim that we use a flat Earth model for things, that's not That's not true. You can make certain.
You don't use a model to do
simplifications.
things. You build them to work in physicality, in reality.
Yeah, but when you design them, you use a working model.
You don't
on
use
which
a
to base your
model.
assumptions.
Architects,
Yeah,
for
absolutely
example,
do.
architects they plan in regards to a flat Earth. They don't take into account any curvature,
right?
or anything
Because
like
locally, like, okay.
So you
but
have to
bridges-
retract
okay,
what you said
hold up,
then.
hold
So
up.
there is modelling that in certain
Right,
professions that
no,
just
I didn't retract
involve
anything.
treating the Earth as flat, right?
The architect would not say the Earth is flat. He just doesn't care because it isn't on scale. But he would still
so
say
for
use
example,
the
like
Earth model.
so for
Hold up.
another
First of all,
example,
bridges
another
also have to
example,
account for that.
another
If you look at
example is
bridges, they
elevation
have to account
profiles,
for
right?
curvature.
So elevation profiles. That's just that's a flat Earth model, right?
Hold on a second.
That's a
We'll
flat
go
Earth
back to
model,
that.
isn't
We'll
it?
go back
Is
to
it,
that.
is it or isn't it not?
I'm
Is
not
it
familiar
or
with
is
the
it not?
terminology, but can I just get on those last 2 points before we
It
go on to
makes
this?
no judgment on the curvature of the Earth.
On those first two judgments, first of all, there's a different, like I said, locally you can make certain assumptions. I've worked on very small scale navigation as well. In some applications, you can basically treat latitude and longitude as a coordinate system as long as you're far away from the poles. Like, it's such a small difference, it's close enough. And locally, curvature is incredibly, I mean, you're not going to observe it locally, right? So if you're building a house, a skyscraper, do you need to account for the curvature of the Earth? No. If you're building a
I'm
really
not
long
looking for
bridge,
your excuses. I don't care for your excuses, bro. The fact is, you're wrong. There is modelling involved in certain professions that
just saying the
involve treating the
fact
Earth
is,
as flat, right?
locally. But if you build a
He
bridge,
just said that you don't take into account the curvature. It's planar. He just said.
I say because locally it's close enough to where those assumptions are fine. But when you build a long bridge, for example, you can look this up. When they build bridges, they have to account for the curvature of the Earth, because otherwise your ends would meet at an angle. Or like if you build from two sides and you meet in the middle, they meet at
Bridges have tension. Bridges do this and bridges do that.
Like, they have to
that
account
doesn't
for
mean
the
the Earth is curving.
Yeah, they never did. They never did for railway tracks that extend for hundreds of miles. Nothing. Never.
Because railway tracks are made up of links, like, maybe 100 feet. I don't know exactly how long, but they're made up of many, many small links that are joined and welded together. So there's always, there's not one continuous, perfectly flat rail. I mean, like, I don't know.
For sure, yeah. No, they're not perfectly at all. The Earth has topography, but you know what it doesn't have? Curvature that conforms to the 3,959 miles. Doesn't have
I would just ask you this: Can we clarify on the issue of things going below the horizon? Because you need to explain that, because that's like a very basic observation I can make, and as long as I can make that observation, like, a flat Earth just doesn't make any sense to me. And based on all the things
if you have water, just having water in the liquid state, that debunks the globe.
How so?
But what?
Well, you need a pressurized system. Gas pressure. Gas pressure is the force that the gas exerts on the walls of its container. You don't have a container on the globe.
If you take your hand out in front of you, or if you don't even take your hand in front, if you just blow in the air in front of you, you've changed the pressure right there. There's a difference in pressure.
For you to be able to breathe air in the first place, to be able to blow it, you have to expand the volume of your lungs.
Right.
Your
So
nostrils.
there is
and
a
the gas
force
pressure
acts
that is
between
around you.
molecules.
The gas pressure that is around you, right? It requires a container in the first place.
Oh, it does.
as
You
an
just made that
antecedent.
assumption. And now, of course, you're going to say gravity doesn't exist.
Why does water boil? Why does water boil at a lower temperature at elevation?
The pressure? Is it
there
lower
is a pressure gradient. There is a pressure gradient, you said.
There is a pressure gradient, that is pressure, and pressure requires container. You just admitted to that.
By what axiom? By what law of nature?
Yeah, I mean, if you look at a model with gravity in it, gas is made up of molecules that are subject. I know you don't believe in gravity, but gas is subject in the globe Earth model. Gas is subject to gravity, as is all other matter, right? So if you had, just bear with me, if you had a sphere, a massive sphere,
the gas laws. You saying there's gravity in the gas law?
Okay, so you can use really basic fluid dynamics for local systems. When you're talking about mass being gas, yes, there is a force, right, on like trying to expand that gas, but when you also have gravity acting on all of those molecules, right? It's not just going to magically
I get it.
and not be
There is
subject to
certain
gravity.
phenomena. There is certain phenomena, and some things that you can say gravity is that thing. But when you say this thing that you label gravity, that is on the gas behavior, right? Let's give you that. Is that the gravity that you claim it's creating the globe? Is that the same thing?
I mean, yeah.
There's one gravity.
Yeah,
But how can that be if you don't have curvature over a surface of the Earth, and this gravity thing that has to do with the globe? That doesn't. You cannot marry those things. You don't have the globe. You don't have the motion. You don't have the.
I'm not sure. Can you clarify why you can't marry those things? Because I don't follow.
Okay, the gas behavior and the way you're saying that there is a force, that the gases are behaving a certain way, and this is happening with the gases, sure. But the gravity that you're saying is happening on the globe model, that has nothing to do with the gas behavior.
Well, I mean, yeah, it does have something to do with the way the gas doesn't
Can you
just expand
demonstrate
infinitely. I mean, you're just okay.
So
you're
saying
making
that
this
the warping
claim that it
and bending
makes
of
no sense,
space-time
and then you're
is
asking me to
affecting-
demonstrate.
you're saying that the gravity of the globe, the warping and bending of space-time, right?
Uh-huh.
That one, is that the gravity that you're talking about?
Yeah.
Okay, can you demonstrate that gravity affecting gases? Go ahead.
I mean, if you can affect it, if you can demonstrate it affecting any mass, which there's the Cavendish experiment is one that you can do with a precise enough but still manageable do-it-yourself setup. I believe it's the Cavendish experiment. I might be misremembering the name, but if you can demonstrate that happens between mass, right? I mean, hell, you could even condense down air into liquid form and probably conduct that experiment. And I would imagine that those air molecules probably still be subject to gravity if you then let it go back into a gaseous state. So I think as long as you can demonstrate that air is made up of
this
matter.
gravity that you're talking about?
Sure.
What is that demonstration?
Jump up and down.
No, search at the Cavendish experiment. That's actually how we've determined the gravitational
You flex
constant.
your muscles. You flex your muscles. You jump from the ground. That's gravity.
Why do you fall
yeah,
down?
and it's the
Why not keep
bending and
going
warping of
forever?
space-time. Is
So
the bending and warping
when I
space-time?
release so you're saying that helium, hydrogen, water vapor, that's anti-gravity?
No, it's just that there's pressure between the molecules.
Oh,
right,
so
that
going
allows
down is not gravity. This guy just said that going down is gravity, but going up is not anti-gravity.
I mean, because there are forces locally that are greater than the pull of
So
gravity.
is going down gravity? Yes or no?
In that case, yes, because you.
So going up is anti-gravity.
No.
It depends. I mean, in the
Oh,
sense that you're
yes
working
and
against
no.
the force of gravity. I mean, on Earth, if you're moving upwards, that's because there are forces acting on you stronger than the pull of gravity, and vice versa.
So nothing to do with the globe then.
I mean, it has to do with gravity, and then the fact that the globe has its center of mass and therefore center of gravitational attraction at the center that would be pulling you towards the
Center
middle.
of mass of the globe. Do you have any evidence of that?
I mean,
You
I
do
haven't
not
been
need
to the center
evidence
of
for
the
center
Earth.
of mass. It is a
I think
mathematical quantity.
a fellow by the name of Jules Verne wrote something
Is
about
that like,
that.
is that like a cartoon that someone drew and they say, look at the center of this cartoon, this is what's happening, and that's what you're claiming right now, a cartoon?
Well, I mean, if you want to measure, if you look up the Cavendish experiment, I'd encourage one of you to try this. I mean, you have to do it pretty precisely, but we determined not me when I say we, but the scientific community determined the gravitational constant through the Cavendish experiment, which is a direct measurement of attraction between masses. Now, I can't really prove to you
That's
that's
not the
curvature.
warping and bending of space-time.
Right, I can't prove that's the warping and bending of space-time because, one, I'm not really smart enough to know about
But
that.
the mass attract mass idea was debunked, was superseded by Einstein, and that's not. Is that Cavendish? Is the warping and bending?
Well, the
of space-time
Cavendish is a way that you
Cavendish?
can say there's attraction between masses, and then you could go on to say that's a curvature of space-time between that. But as long as you can prove that mass attracts mass, you can
But those
rectify
two
the
are
global
mutually
model.
exclusive.
Well, I mean, in the same way that orbital levels and and atoms are an abstraction of what's really happening.
The curvature of space-time is simply an explanation for why the mass attracts mass. They're not mutually exclusive.
But the mass
That's the issue that you guys are having, that you're explaining certain phenomena. You're saying that explanation, you can extend it to the Earth curving and spinning in the vacuum of space, that you cannot demonstrate in any of these things.
Well, it doesn't. You don't need to demonstrate the curvature of space-time, because if you can demonstrate because first of all, no one can say on a fundamental level why space-time curves. Why does something exist rather than nothing? But your whole argument with the flat Earth is we can base this on observations, right? And expand those observations to develop a coherent model. Right. So if you can do the Cavendish experiment and you can see that mass attracts mass, right? Then you can use that as a basis for. That's the definition of what gravity is. I'm really confused by what you're getting at, because if you can show that mass attracts mass, right? That is literally the definition.
Where do you see that in nature? Where do you see mass attracting mass in nature?
When they leave all matter
ground. Because when I look at gases are not attracting each other, are they?
It depends.
Yeah, they are. But there's also a force between those gases, right? The electrons repelling each other.
There's a van der Waals force, yes.
He said yes, they are. He said gases are attracting each other.
Yeah, sure they are. All mass attracts all mass.
With no proof. Yeah, with no proof of that. That's Newtonian gravity.
Cavendish experiment. Right, and the theory of space-time curvature is perhaps a more accurate way of describing it, but you can observe, right? You're not getting around this Cavendish experiment thing. Why would mass attract mass?
Observe these plates moving towards each other and doing what they do. How does that prove the curvature of the Earth, the motion of the Earth, and gas pressure without a container?
Again, okay. This is one of the things I really don't get about the gas pressure thing. Is just try to conceptualize a bunch of molecules. Doesn't matter if they're gas, liquid, solid, right? And imagine gravity. All these molecules are.
So wait a minute. Just to clarify.
I mean, I just don't get what's so difficult to understand about gas being subject to gravity.
You're saying Cavendish proves mass attracting mass, correct? That's what you're saying?
It's an experimental demonstration. It's not proving the space-time curvature nature of it.
Cavendish was trying to work out the density of the ground. Had nothing to do with gravity.
Exactly.
No, it had everything.
And it has no hypothesis.
I'm not sure what you guys are getting at, because you're not going.
How about you do it the easy way? How about you go and look up Cavendish's papers, and it's written in the title what he was trying to achieve.
Right, and then explore it for a hypothesis, because there is none. It's not a scientific experiment. It wasn't a scientific experiment. It wasn't based on a scientific hypothesis. It's not a scientific experiment, period.
Okay, if I observed something happening and I don't attach a hypothesis to it, that doesn't negate what I've just observed. Like, you're getting to the semantics.
Yeah, but you can't conclude what you observed. You can. Okay, so I saw these two balls. I saw these two balls moving towards each other in this contraption. All right. Okay. Yeah, and
right,
you didn't see mass attracting mass. That's your interpretation of what you saw.
I mean, again,
this is now a debate about empirical physics and the nature of observation, but it is you build a theory based on observation, and maybe sometimes the observation.
No. If it's natural science, then it will have occurred in nature first, not in a man-made contraption. Nobody ever saw two things moving towards each other like that.
In physics, nature just means reality. It does not mean in the forest.
No. In physics, nature means not man-made, not synthetic, without human intervention.
But why would
that's what it means.
Because all of
that is absolutely 100% true. Excuse me.
I have a bachelor's in physics, and that is not true.
Yes, it is 100% true. It's called natural science for a reason, because it's dealing with things that occur in nature without human intervention.
Human intervention is allowed because humans are part of nature.
No, but if it's synthetic or man-made, then it's not occurring in nature.
No, nature is all physical reality. It is the same thing.
No, it is not.
They are broken down into separate categories for a reason, lad. And anyways,
humans and their contraptions are subject to the same laws of physics.
Someone like you who claims to be up there in physics would understand the nature of physics of such as water, flat and level. Yeah? At rest, flat and level. So how can you have a ball if 70+% of said ball is flat and level? Interesting, hey? There's your physics for you. It's a base axiom. We all know that water's flat and level at rest, and yet you want to argue with it. That is very interesting. But anyway, thank you for interrupting. How about we go back to the other fellow up the top? Facts and Logic, I think it was talking.
Well, I mean, I agree with everything that Lad said. I'm an aerospace engineer, so I don't have the full extent of the knowledge of physics that he has, but I mean, I agree with everything he says, and everything he says matches up with the...
So if you're an aerospace engineer, you would understand that planes would have to tilt their nose to navigate around a ball.
Sure.
They don't do this in reality. Black box data shows that they do not.
Because attitude is measured relative to the surface.
Black box data shows that they do not.
Could you elaborate on that?
Their attitude claims that they follow the curvature and therefore it is not needed. You can laugh all you want, my friend.
But
the elevation would change.
Can I ask you a question?
We've got black box data showing this is not the case.
Do you know how they measure attitude?
Off of the gyroscope that's inside them, yes.
Right, that based on magnometer data and also...
Excellent. So the gyroscope holds its position in space.
Yes.
So don't tell me that there's all these other things like pendulous vanes and whatnot. That's just to mitigate the effect of the gyroscope moving. Normally most people do. So I'm nailing that to the floor before you start.
Can I tell you something as someone that's worked on avionics and sensors?
Excellent.
Can I tell you something?
At the start, when a plane takes off, the gyroscope spools up, holding that position.
Speaking loud does not make you right.
And interrupting doesn't make you any wiser. At the start, before a plane takes off, the gyroscope spools up. That's the position that everything is relative to. So once it takes off, it then takes off, flies up into the air, flies, positive pitch, and then goes and lands somewhere.
Right. So, as I was saying, as someone that has worked, I've worked with gyros, I've worked with accelerometers, magnometers.
So you would understand that gyroscopes hold their position in space.
Yes.
Relative.
I will get to that. I will get to that. I promise you, my friend. When you look at black box data, the readouts from planes, when you're looking at attitude indication, right, or gyro, that is a number that is being spit out by a computer based on raw sensor data. When you get a number like attitude, that's an aggregate of a bunch of different data. And attitude, as defined by the flight computer, is always going to be relative to the surface, right? So if you're constantly flying level to the surface, right, as measured by attitude, you would actually technically constantly be, slightly angling down your nose. It would be imperceptible.
No, it's not. If it's slightly angling its nose down, it would register. You know that as well as I do.
Well, yeah, if you looked at the
planes fly across a flat and level horizontal surface. If they were tilting their nose down, and you know bloody well how accurate those things are, if they were tilting their nose down, we all would know about it. They do not tilt their nose down to navigate around the ball.
Again, I think there's a little bit of a misunderstanding.
Repeating it is not going to change it. See, your perception is it's flying across a ball, and therefore the gyroscope is always pointing to the center of gravity. The gyroscope doesn't do that. The gyroscope holds its position in space. It is rigid. That's the purpose of the gyroscope. The plane maneuvers around the gyroscope. Pitch your roll. You know this. So why are you trying to pretend it's something else?
I think there's a little bit of I want to elaborate on this. It might not be exactly obvious because it's... the best way I can describe this, I want to use orbit as an example, but that's probably just going to make things worse. But when you're measuring relative to the surface, right, the computer readout, because I think this image was just sent in the chat.
It's not measuring
right?
relative to the surface. It's relative to the gyroscope. That's where you're coming unstuck. You seem to believe it's measuring relative to the surface. It is not. It's based off the gyroscope.
Hold on a second. I'm sorry, Matrix. I have to interject now because earlier on this gentleman said that that flat Earth modeling is not a thing that's performed in industry.
I never said that. I said absolutely. It's used
Yeah,
on a
you
local
did.
scale.
I heard you
No,
say.
I didn't.
I heard you
I actually
say
said
it.
in my
Yeah.
first statement that on a local scale, it's valid, but on a lot of things.
No, that was after I said something, and then you changed your.
No, I don't know.
Are you not aware? Are you not aware of all the documentation that we have stating how that they use flat Earth non-rotating flat Earth models in order to manufacture and design and test aircraft?
Yeah, they always use a horizontal baseline in their flat Earth simplifications.
I'd also
if you're an aerospace engineer, then you'd have to be aware of these sort of documents that we've read.
Okay, well, I haven't read every body of knowledge as it relates to the flat Earth consensus, but I will also say one other thing I wanted to get to was that gyros also use accelerometer data, which is basically just a stand-in for gravity, to correct for drift. If you know anything about PID controllers, anything with controller logic, which is something I do a lot of, right?
Yeah, I've got a PID controller. I use it on my still.
Great, yeah.
Control the temperature. I know exactly what they do.
Awesome. So, as you know, right, that I term, the integral term, you can get error buildup by an external force. In this case, your gyro is constantly being corrected by other sensor data. So when you see that readout, right, that's a corrected readout.
So what sensor data, hold on, so what sensor data would be picking up the fact that you need to tilt your nose down to traverse around a ball? What would be opposing that?
I think the easiest way...
And where's the data for the instrumentation that corrects the other thing?
See, the problem you've got now, Fax, if you claim that this is constantly being updated, you've just negated the whole purpose of having pitch, yaw, and roll data in the first place, because it's constantly being updated, therefore you would never know what position you actually were.
Well, I mean, all measurements...
The gyroscope, as you know,
right,
spools up at the start, and that's what holds its rigidity in that from that position.
Yes, but it can be corrected.
The pilots...
Because it will
pilots,
no
once they get to cruise altitude, tilt their nose up between 1 and 3 degrees, depending on what craft they're in, how much weight they have, how fast they're travelling. And once they do that, they then zero it. But it is still nose up to travel. Any indication outside of that, 0.5 a degree, would be indicated. You have to get your nose below zero in order to fly around a ball.
Yeah, and we have pitch data that shows for at least 2 hours, one aircraft just maintained that orientation and that pitch for 2 hours without losing altitude, without losing or gaining altitude.
Gyro data is corrected for gravity, so you're always going to be level.
Just
even if
we're not interested in the excuses.
It's a marginal
we're just interested in the data, which shows that an aircraft is rotating.
Right, but you got to know how to interpret that data, right? So you just claimed,
show us the data. Show us the data then.
I mean, if you read up, I assume you guys
show
have
the data.
But if you've worked with with gyros, accelerometers, and on a higher level, there are whether it's a mechanical system, an electrical system, there are a wide variety of different ways that they correct for gravity. It is absolutely something that goes into the design process.
Okay, show the data that indicates that this occurs, and the plane has to rotate over thousands of miles.
This would show up.
Gravity is not a force.
Yeah, you said gravity. Don't say it again because that voice comes over. You'll work it out.
All right. I mean, if you want to get into the minutia of it, I'd probably have to dig into this to give you a satisfactory answer. But my guess...
Yeah, well, we've been asking for it. If you're in that field, if you're in a position that you could provide that data for us, we'd very much appreciate it.
I mean, that would take
we've been
more
asking
than
for it. No one's been able to give it to us.
I'm not going to be able to get that to you this instant, right? I mean,
Don't expect it right now. We're here 24/7.
But I could say this to you, just conceptually. You could probably do the math on a napkin. How much do you think you'd have to pitch down on the scale of travel that is the Earth? What sort of pitch do you think you would need to maintain?
It would have to be below 0, as in negative pitch. And I think it's only about 0.8, but it still has to go below 0 in order for you to go around a ball.
I don't think you reckon it would be something along the lines of 8 inches per mile squared.
I guess this is hard to put into words, but if just imagine a plane, right? The plane is going along the surface of the globe. Just imagine this. As the plane is going along that surface, right? All the flight systems, the autopilot, the pilots, whatever, they're constantly trying to maintain level to horizon. The sensor data is always reading a pitch level to horizon. So you
hold on a second. Stop.
Can I
Is
finish?
it level to horizon? Because I want to clarify something. Is it level to horizon or perpendicular to gravity?
I'll say perpendicular to gravity would be how the sensors measure.
So not level to horizon.
I might have used a colloquialism, but the sensors use relative to gravity. I mean, if you ask me from the aerospace engineering answers, the sensors use their best estimation of where gravity is pointing for that. I might have used a colloquialism of the horizon, but the semantics don't matter. It's irrelevant. Anyways, as the plane is moving along the horizon, or as the plane is just moving along, right? Let's just put it that way. There's constantly oscillations, right? It's constantly moving, but at every instant, the plane is roughly targeting flying perpendicular or parallel, I guess, to the surface below it, right? So you wouldn't ever see a constant pitching down, if that makes sense, because there's a constant oscillation.
Yes,
but
it would.
At every point,
the data would show up. That's your problem. We've got data in the side chat there.
And level regardless of
it would show.
Well, someone in the chat just said a lot. Microsoft Flight Simulator is based on a spherical model.
Every time the plane makes any adjustment, that data gets recorded. It gets shown on a graph and printed out for your convenience as a aeronautical engineer.
And you see how there are very slight oscillations in that data? As a matter of fact, I'd also like to say, with pitch and angle of attack, that is not your direction of travel. If you get pitch data, right? So there's something, I don't know who's familiar with aerodynamics, who's not. Angle of attack is basically the, relative to what's defined as the horizontal and vertical axis, right? It's how much is your plane pitched.
How much does it have to tilt up to catch the air, basically?
Right, because of where the wing is positioned, where the pressure gradient creates a lift vector. Exactly. So, you can look at this data in a vacuum of this pitch. That number is really not going to tell you anything because for some planes,
well, yes, it does.
Will be higher, some planes it will be lower.
I'll tell you why. See where it's got the pitch data there in the diagram? The one that's got the big blue box in it?
Which line am I looking at?
Pitch data, orange.
Pitch data, gotcha.
Right, in the blue box, pitch, straight line. Then you go down to, elevation? Straight line. Or altitude, down the bottom, black, straight line. So just so you know, this was from, what'd they say? It was LA to Honolulu. This one was an incident. They had an engine blow up. But they landed safely, so you don't have to worry. Nobody got injured or hurt, so we don't have to have any sob story or news about it. Anyways, for that just over 2-hour period, there was no elevation change and no pitch change. Flying, flat, level, horizontal. Now, if you're flying around a ball, if you're flying dead straight, not pitching up, not pitching down, so that your angle of attack is correct and you are flying horizontal, you would then show a change of altitude. If you're not showing a change of altitude and they are both correct, you have a flat surface.
I think I know.
That's how we know. Because if you have a ball, one of them will be pitching down to fly around it, in which case it's not, or The other one will be showing a change in altitude, in which case it's not.
Brother. This is actually the best way I can explain this. So we established with angle of attack and stuff, right? We know that you might have to pitch up just to go level, right?
The issue is you still have to change your nose negative to go around the ball.
Okay.
If you say the angle of attack gets lowered, what happens then is you decrease your elevation.
Can we get to that? Because let's say to travel
it still
around
doesn't
the world,
tilt your nose around the ball.
I will accept that we need to have our vector of motion be slightly
okay. How
below
about we do it the easy way?
Yes.
So you don't overcook yourself. Inside chat, 15 minutes past the hour. See the shit stick figure planes?
Yes. Can I?
Excellent. See the one on top. See the one on top.
Please let me answer your question, man.
Can you see the one on top?
Yes.
Yes or no? Excellent.
Yes.
See the one at the side. Notice how it is facing down 90 degrees. In order to go from horizontal down to 90 degrees, it would have to tilt its nose down.
Absolutely.
This does not show up on the data. That's your problem.
Can I please answer your question? Give me 20 seconds.
It's not a question. I made a statement.
Can I respond? Let me respond. Give me 20 seconds. That's all I ask. Okay, so we're going around the Earth. We need to be pitching down constantly, right? Keyword, constantly. We need a constant direction, constant attitude. We also know that the attitude of the plane, the pitch, is not the actual velocity vector, meaning that you would definitely expect a constant pitch reading, and there might be an offset because of the angle.
You still have to pitch down for your constant vector to be showing around the ball.
You have to pitch down at a constant
and you're not pitching down constantly. You're pitching up. Your vector is horizontal. It is not at a constant negative rate. Your angle of attack is shown also, but your vector, how are you going to differentiate between vector and angle of attack? Please tell everyone.
Okay, I'm just trying to conceptually, you've made this claim that this data is directly impossible with the globe Earth. I'm just trying to explain
It is impossible because if it was a ball, if it was a ball, the data would, number one, show that you're pitching your nose down to fly around it, or number two, if we're flying horizontal, it would show the altitude changing up and down. That's it. It does not do either of those. For 2 hours and 5 minutes or 2 hours and 8 minutes, it shows zero pitch change. It shows zero elevation change. That means that you're not flying around a ball, mate.
I think there's going to be a little bit of a disagreement in how I understand things. It's not going to. If you would be open to talking one-on-one at some point, I think I could articulate it better. But I think you're not what I said is just maybe I didn't say it right, but that's
okay. Your claim is angle of attack at positive 3 degrees, which is what that plane is at. Your angle of attack then allows you to have a negative vector. This is incorrect. Yeah, no, you're not. Okay, stop. Okay, facts. I want you to use your brain. Grab a piece of paper and draw a line. A straight horizontal line. And then what I want you to do now is, with a positive attitude, I then want you to draw negative below the line. So you are going to trace that line, and with a positive attitude, so that means it's got to stay above the line, you're now going to go below the line with a negative. You can't have both, my friend. You're either positive, zero, or negative. Which one is it?
Yes. So can we first clarify what angle of attack is? Because there might have been some.
We know what angle of attack is.
Can you explain it to me? Because I don't think you do.
It's the angle required for the wings to catch the pressure for that particular speed, wingspan, weight of that aircraft.
It's not so
Some
much
of them requiring from positive 1 to positive 3 degrees for most craft.
Right, so angle of attack is defined, okay, as the difference between where the aircraft is pointing and where the aircraft is actually going. That's all it is. You don't really even have to think about the airfoil. That's all you really got to think about.
So you're claiming with a positive angle of attack, right? You are flying negative numbers. That's what you're claiming.
Yes, because imagine if
Excellent. If that's the case, the data would show it. The data would show a change in elevation because you are following a ball.
Yes, but elevation is measured relative
The claim
to the
is
surface, right?
you're
So if the
following a
surface
ball.
was a ball,
That's
then
your
the
claim.
elevation-
Facts.
Yeah.
Your claim is you're following a ball. If that is the case, the data would show it. I'm sorry, mate. You can claim all the technical bullshit you like. The data's not showing what you're claiming.
Okay, so
Like T-Dub said earlier, if you have data that shows contrary to this, please, for the love of God, bring it in here. We are more than happy to accept it, go through it, scrutinise it, read it, and if we're proven wrong, I'll even apologise.
would you be willing? This is just brother to brother. Would you be willing to one-on-one talk? Because I'd love to
Bring
talk
your
to you about
data in here.
Because I don't have it. I mean, I just came on here on a whim. I don't have. all
I'm not
the data.
expecting you to drop it right now. I'm not that nasty.
Yeah, but would you be open to a one-on-one? Because I don't, I have no interest in I'm happy to talk in here too, but I'm not here to.
Just bring your data in here, because that saves me sharing it with everyone. If they're in here, we can just go, there you go, lads, he brought his data. Happy days for
Right,
everyone.
but in here I get muted, I get yelled at. I'd like to just talk to you one-on-one.
I get accused of yelling people all the time. This is my normal volume right here.
All right.
Excellent.
I mean, but I think it's.
Bring your data in.
The question
We're more
is
than
not-
happy. It's called 24/7 Flat Earth, not 24-second Flat Earth. T-Dub already said we're
I would
quite happy
love
for you to bring it in.
I would love for you to take an aerodynamics course, something, because some of the things I'm saying, it's like I don't know how to better describe them, but we have very different understandings of the same words, if that makes sense, to the point where I can't explain something to you when we understand the words differently. You know what I mean?
Like what, level and flat?
Right, because I'm talking about level as relative to a surface. That surface is changing, so of course the elevation wouldn't be changing if you're flying at a constant elevation.
Excuse me for a second. Why do you need to redefine the word level, horizontal, flat? Why the necessity for that?
I mean, because as it pertains to the situation, words have different context.
So you're telling me
no point
every
arguing
time there's a different context, every time there's a new context, I can redefine words based on that context?
I mean, you could do whatever you'd like, but I'm just saying that why would we get bogged down in the semantics, right? Let's just
The reason for it,
clarify what we mean.
words are
There's no reason to
defined
argue that
already.
stuff.
Words are defined already, so we don't get bogged down in semantics. So you have changed the
Exactly.
definition of level in order to suit your needs.
Okay.
So what was wrong with the original? What was wrong with the original definition of level?
I just mean parallel to the surface. If we want to agree on a different definition of level, that's
parallel
fine.
to
but
the
it
plane
doesn't-
of the horizon. Horizontal. Yep.
But I'm saying parallel to that surface of this.
The plane of the horizon.
This mystical
yes, the plane
sphere.
of the horizon. Exactly. The
Why
plane.
does it
No, the
matter
plane
what
of
the
the
semantics
horizon.
are? Why does it matter what
Horizon.
the semantics
Horizontal.
That
Horizontal.
has nothing to do with the argument. These are
Yeah, it does.
We're just
It has
talking about
everything
what
to do with
words
it.
mean.
It has
nothing to do with the
everything.
physics
It's
or-
the fundamental principle of the argument.
Okay, our definition of level has nothing to do with the physics of a plane flying about the Earth. I mean, why
Yes, it
are we
does.
arguing about? It has
Yes, it
nothing
does.
to
It's
do with-
fundamental to it.
All we need to do is clarify what we mean and then move on. There's no point arguing or yelling about this.
Excellent. A basic question: do planes fly flat and level? Yes or no?
Based on how I would understand it as
Very
relative
simple
to the surface.
question.
Yes.
Very simple
absolutely.
question.
And you're going to say,
they
"Oh, that
do
means you're on
fly
a flat
flat
Earth."
and level. Excellent. No, that's not what I'm going to say. The only thing you have now is to redefine flat and level as to mean that you're following the surface of a ball. In which case, you then have to prove the curvature of your ball. So if you wish to go that path, you're more than welcome.
If I said, actually, you know what? No, planes fly spherically. That doesn't prove my point. Why are we arguing about this semantics? It has nothing to do with the physics of the situation.
The reason you're now bunked down in the
Explain to me how
meta
it
is you
has-
know you've had your ass handed to you. You're supposed to be an aeronautical engineer. I thought you would have put up more of a fight.
I mean, look, I'd love to, you say you don't want to, so whatever, but I'd love to just talk to you one-on-one. Like, I mean this in the best way, but there are certain things here that you guys, like, it's hard.
Bro, you have been. For the last half an hour, I've been listening to you and Matrix alone. Nobody else interjected.
Okay,
We
I
even
just mean
muted
in a
one guy
different
that
way.
wanted to.
Oh, let Lad speak. I'd love him to speak.
No, he was muted because he was interrupting. and stopping the one-on-one.
I mean, I interrupted him to begin with when he was speaking to someone else. So
facts and logic. Why is it so difficult to explain the globe nonsense when trying to describe what's happening in reality in reference to
because I say one
airplanes?
thing and then you guys argue about semantics when it has nothing to do with what we're talking about.
Semantics? You're saying that what mathematics has been telling you he's wrong? He's just using semantics about it?
I mean, I'm trying to explain to him why the data as someone that has spent months and years working on sensors and vehicles that fly and navigate and working on all this stuff, right? I'm trying to give you my best interpretation of the data, right? And then you're just throwing out in the window and saying planes fly flat and level, therefore Earth cannot be a sphere. You know what I mean?
So basically what you're saying, when the next guy walks in here and he interprets the data differently, are you going to be right or wrong?
Well, it doesn't need
interpretation anyway.
I might be incorrect, right? I didn't study this particular incident with this plane. I don't know all the specifics of how that data is collected and processed by a computer. They're different. Do
you have access to more of those flight data sheets?
No, I don't work in commercial aviation crash reports. I have just as much access as you do.
I was going to say, if you have access to more of those, can you get any one of them? I don't care what make or manufacturer or company. Even if you have to black line some of the names off it, if you can get those, I'm after a long range flight. Like I'm talking 6 hours plus.
You'd need different data because, as I said before, the gyros are corrected for gravity. So what you're looking for with that pitching, you wouldn't be able to.
So the pitch data is null and void. If the gyros get consistently corrected, that means the pitch data would be useless.
Right.
Why is the pitch data there if it's getting corrected regularly?
Because it only matters relative to the surface at that point.
Do you know how much correction they do? There's a little dial on the front of the gyro. Once they get to flying flat and level, aka nose up or angle of attack, they then dial back to 0 so they know they are at flat and level.
Yes.
And then they fly that way until they get to where they're going. That's it. That's all the
offset, but there are also
that's all the adjustment is.
No, it's not. You can Google this. Just Google gyro.
Why would they need to adjust anything? Once the plane is flying level, horizontal, flat, why would they need to adjust anything?
Because as we established before.
Because as you are trying to push onto us a bald Earth that you can't validate or verify in the first place.
Hold up.
So how about we put the planes aside? So how about we just get the whole plane bullshit and we'll stick it to the side? In order for you to convince us that your plane that we just put to the left flies around a ball, you've got to prove you live on a ball. So what proof of curvature have you got?
I mean, as I said before, you guys can't, you can't on a basic level get around the fact that things go under the horizon.
Under the horizon. I have never yet seen anything go under the horizon.
I mean, I've looked through a telescope and seen ships do that. I've seen the sun do that.
Yeah, Mr. You said
you're asking me what it's like.
And I showed you plenty.
You showed me a picture of a table where I can't see what the angle that is. That's an incredibly small scale.
I showed you an actual sunset with a solar filter, and you said no, that's not. That's not what's happening.
Because you can see the sun being cut off at the end. I mean, I don't know what you want me to say.
Listen, you know about the point of
his claim. John, hear what he said. He said that he has observed things going under the horizon.
Exactly. And I already talked about the refraction, and we already talked about the convergence, and we just moved on. Because you guys couldn't provide a convincing answer.
He's seen through the Earth. He's seen through the water or through the Earth, right?
Under the horizon.
Yeah. How did you see through the dirt or the water?
I mean, I saw something cut off. Like what else?
Cut off, right? It appears to be right. So we've seen examples of ships where it appears the bottom part is cut off. Right? Is that reproducible in any other way, apart from actual physical obstruction of view?
I mean, that you can see it? Like you can...
Have you investigated that at all?
I mean, I think my time is better spent with other things, but I mean, I've seen things dip below the horizon.
Mainly because you've been taught the Earth is a ball. You just took it at face value that's the reason why, right?
Okay, I want to rather than argue about let's talk about what we can see.
Wow, you're not a straight shooter, are you? You're not a straight shooter.
No,
I'm trying to get to the physics of it.
Okay, facts and logic. Facts. How about we make it nice and easy for you? You're claiming that the ship's disappearing bottom up is the effect. Cause is the curvature. Excellent.
Yes.
I'd like you to look inside chat. There's an image of cans of classic decaf. I don't know if it's your poison or not, but each to their own.
Not a decaf guy, but yeah.
Excellent. Can you see the bottom-up obstruction on the bottom can in that image?
Yeah. I mean, we're just talking about...
That's at 22 feet on a flat surface.
I mean, when you're talking about like lensing and stuff at that small of a scale,
facts. I didn't say anything about lensing. I wasn't talking about lensing.
Well, no,
all I did was post it. Hey, hold on. All I did was posted an image of two cans. One of them you can see the entirety of the can. The other one you can see the bottom clearly missing. Bottom up obstruction. The claim from you guys is ships disappear over the curvature. That's why they disappear from the bottom up. Here is a demonstration of bottom-up obstruction on a flat surface.
I mean, how flat is that? You'd have to prove to me that surface is flat enough for that to be a valid assumption.
I'll tell you something now. The guy that took that photo, and if you said that to him, he'd probably just mute and ban you for practice. So, because he's a builder.
I'm not convinced by a can of
he's a builder. What you've got to understand is bottom-up obstruction happens at extremely short distances. We've got video footage of radio-controlled boats disappearing bottom up. I think it's 100 yards. That's it.
Right,
your curvature doesn't even appear before then, allegedly, at the distances these were taken from.
I mean, you might have like local effects with waves, or
assume that bottom-up obstruction is caused by curvature. When you start looking into this, you will find out that bottom-up obstruction is just an optical effect. You don't need curvature for it to happen. Okay?
Look,
once you understand that, and once you start looking into this a little further, you'll sit back and go, holy shit, it's not bottom-up obstruction caused by curvature, it's bottom-up obstruction caused by perspective, convergence, angular resolution, angular view, the Rayleigh criterion. But since you're so busy at work, and I fully understand that.
But, like I said,
let's not forget to mention weather conditions, and also the potential for like at sea, right? So if you're 6 foot, so if there's any sort of swell out there that's higher than your observer height, that has the potential to give that appearance as well out in the distance, and you won't be able to distinguish a swell at, say, a mile, 2 miles, 3 miles, 4 miles, 5 miles, 6 miles, right? Away from the rest of the surface that you're looking at.
I got a question. Why would the sun go down the horizon with this bottom obstruction? Because the sun's not level to the ground, right?
Well, what about when it doesn't appear to do that?
Can you show me an example of? I mean, like I don't get what you're saying. You're just saying, "Oh, what if it doesn't?"
So you've never seen the sun set larger than what it is at lunchtime? You've never seen the sun set smaller than what it is at lunchtime? You've never seen the sun fade away into the distance? You've only ever seen it drop vertical. And it looks like it's setting about 500 mile away.
Perhaps. What are you getting at?
In my lifetime, I have seen all of those. I've seen the sun set smaller than what it appears at lunchtime. I've seen the sun set larger than what it appears at lunchtime. I've seen the sun look like it drops vertically out of the sky, straight down. Looks like it's about 500 mile away, maybe even closer. And I've also seen the sun fade away into the distance. Now, which one of them is correct? I've seen all of them, so one of them's got to be wrong.
I mean, like, again, it's just the setting thing. That's nothing to do with
nothing to do with humidity, nothing to do with temperatures. No.
Okay, but if it was circling above us,
so our perspective. Okay, so as things get further away into the distance, they appear to converge, right, with other things.
Yeah,
that are
but it wouldn't
that are with
magically go,
distance.
like, below it. Yeah.
Right. So you can have something at distance, right? Like a light, for example, like a street light that appears, in your perspective, very close to the ground, but it's not actually, is it? Because you know it's at the same height as all the other ones that are in front of it, right?
But it is not obstructed by the ground. It just gets smaller.
Right, but it'll appear to converge. So, like two headlights at a great distance on a car, right, will just appear as one headlight, right?
But
to fractionally
not have a headlight.
Yeah. Oh, so what happens when they get to the point where they're just merging together? They won't appear to be like half merged with each other.
You would not see a semicircle.
Yeah.
Why not?
I mean,
well, just look at it.
Yeah.
Why wouldn't you? If something's
because nothing is obstructing it from below.
If you include all these other conditions that were mentioned, right? Like, weather conditions, air conditions, the light trying to push through all the air, right? At that distance,
it ignores the weather and makes things too complicated.
Right. So you can't fathom that it would. You could produce similar effects. We've got there's photography, right, where it's taken. Zoomed out, right, where it appears the sun is kissing the horizon, and then you zoom in, right, the photographer zooms in, there's actually quite a great angular separation between the sun and the horizon. So to you, right, to your eyes, your optics, it looks like it's touching the horizon. It's not.
But there is a point at which we go discretely from we see the sun and the brightness to no sun. It is gone. Darkness.
Yeah. So what happens? So what happens when something gets that far away from you that you can no longer distinguish the difference between the bottom of something and the top of something?
Well,
do they appear to converge? Do they appear to meet?
There is a convergence, but not a disappearance. That's
right. So, and also the angular resolution is going to take effect too, right? And you won't be able to make out the difference between the two things as well. But
sure, but it doesn't explain the top.
There's other guys here that I wish they were here that would be able to, be able to express these things better than I can. My understanding of it is rudimentary at best, and they might understand the mathematics behind it and everything like that, which I don't really. But yeah, so look, if you want examples of things like this, like we can present them to you. So it is these effects are reproducible without the necessity of a surface that's curving. If you're interested, we can provide them to you.
The flat Earth model, please tell me if you agree or you think something else is true. The Earth is sort of like a disc or a plane or something. And
I know. I don't adhere to any particular type of model, like of the entirety of reality. If that's what
you agree there is an objective reality, right?
Yes. And to experience that, you just go outside, and that's it. You don't need a model. Just go out and experience it.
But you agree, probably some model, maybe we do not have it yet, but that can describe the flat Earth correctly. Is that right?
No, I don't.
But there is a model that exists, maybe that says it's flat Earth, that is better than the model, perhaps.
No, there isn't. No, that'd be a reification fallacy anyway. So what we want to do is just go outside and experience reality as it is, as you observe it. You don't need any particular type of modeling to describe it. You can just describe what you experience directly.
How can you compare your experience and your understanding of the world if you have no model? Your model is just your understanding.
Well, to do that, you'd actually need you'd need all the variables in your model to actually be experienced from that type of perspective. And if you can't, and if you don't, then don't add it to the model.
Well, sure, but you must want to know how the world looks, no?
Yeah, I'd love to know. Unfortunately, I suspect, reasonably suspect that I'll never have that vantage point ever, and I'm not going to attempt to present a perspective of something if I can't actually obtain that perspective. That would be called a reification fallacy.
I am perhaps not familiar with the fallacy, but it is just very hard to have a conversation if we cannot even agree that there is a way of viewing the
it's
world.
lending concretedness to an abstract idea or concept, right? So I could present you a concept of what the entirety of reality looks like, and if I've never had that vantage point, and if I'm adding in variables to that I haven't experienced, and then I'm telling you that that's an accurate representation of reality, that would be a reification fallacy.
Well, I think we start, like you say, with the concrete, what we can see with our eyes, and then we make the abstraction. But the reality is not.
No abstractions are needed. No abstractions are needed. No conceptualizations are needed. There's no representation from a perspective that you can't obtain that is going to accurately represent reality. What accurately represents reality is going out and experiencing it directly.
But even your own experience is an abstraction. It is not an objective. It is not reality as it is. It is your perception. It is not a complete.
Yeah, that's all we've got. If that's what you want to call it, fine. But that's all we've got. There is there's nothing else.
But my point is, what you see with your eyes and your ears.
So, okay, if that's the case, then how are you ever going to accurately depict it in a model? If that's the case, bro, you just shot yourself in the foot.
Well, you just look at what science does. What I'm saying is, you're appealing to the concrete versus the abstract, but I'm saying everything is abstract.
Can someone else jump? Sorry, man.
You're appealing to the abstract. Look, bro.
I gotta do some shit.
Yeah, I do too, actually. I've got about 3 minutes. Lad, have you got proof of curvature?
Well, we've been arguing about the sun, and I would say that is the easiest proof.
No, the sun is not proof of curvature. Nothing that is not the ground would prove the curvature. The horizon, horizontal, flat, level. So the horizon proves curvature. So the horizon is a geometric location, yes or no?
Depending on your position, the horizon can be identified on a spherical model, yes.
Okay, I'm standing on my head in my lounge room. Is the horizon a physical location, yes or no?
It is a physical location which is relative to the point of your perspective, but the horizon will be different forever.
So my perspective will be sitting at the beach. Is the horizon a physical location, yes or no?
Yes, you could map out exactly the points that correspond to your visible horizon.
Excellent. So, from a 1 foot elevation, the geometric horizon should be at 1.22 miles. Based on the formula, 1.22 times the square root of the observer's height in feet. Do you disagree with this?
For short distances, but the quadratic model is not accurate at the global scale.
Quadratic model? Oh, please, enlighten everyone.
Is that not what you're getting to? It is only approximate for a small distance.
I didn't say 8 inches per mile squared. I said 1.22 times the square root of the observer's height in feet.
You're
this
just
gives us our horizon. Did I say anything about the number 8? 8 inches per mile squared. I didn't mention that. So, 1.22 times the square root of the observer's height in feet. That would give you your horizon based on a ball with a radius of 3,959 miles. Do you disagree or agree with this equation? Yes or no?
The presence of a square root. Is the presence of a square root tells me you're using quadratic model.
Ball. You have to.
But
it's claimed to be a ball.
I will assume your formula is
If I don't square it, you will get a straight line running at an angle.
Yes,
probably some kind of diagonal. Please don't help him. Facts and logic. I don't need his help.
Wait, but you said you weren't using a quadratic, but then you just did a square root. If you just square both...
I tried to say shut up as polite as I can. Now, lad, do you agree or disagree with this formula given the radius of 3,959 miles?
I agree that for a short distance it may be an approximate model.
An approximate model. Do you have something that's better?
Let's see, the trigonometry you would have to do. Not off the top of my head, I don't have the formula.
You don't have anything better. So you're happy to tell me that mine is only great approximate over short distances, but you're not willing to offer anything better? That's rude.
Because the square root is associated with a quadratic model, which does not correspond to a sphere.
Yeah,
So
great. That's awesome. That is awesome. The problem you've got is it still allows us to do how much of a sphere accurately?
I think yes, at a short distance, it is a decent model.
At the short distance, what distance? At what percentage of a sphere?
Side chat for you, Matrix.
Maybe like 10 degrees. I don't know.
10 degrees. So all you're going to give it is 10 degrees.
I'm just guessing.
Wouldn't 90 degrees, 1/4 of a sphere, be correct?
Maybe closer to 45. 90 degrees, no. A parabola is not a sphere.
Anyways.
But what is
unless you're gonna, hey lad, I'm gonna spell it out for you. Unless you're willing to offer something that's more accurate, this is what I'm going to continue to use. Deal with it. Anyways, you have not offered anything more accurate, so you're gonna have to agree with it. 1.22 times the square root of the observer's height in feet, based on a radius of 3,959 miles. Now, why is it when we go for our little walks outside and we're looking around the place that we see further than these given distances based off this formula, based on the alleged ball? Why do we see further?
Well, assuming your model is accurate at a short distance, then there are probably propositions like the local curvature is less than that, which is the global average.
Local curvature. Hold on a minute. There's a difference in curvature. There's a difference in curvature. Local curvature. I've heard a lot of people say it's locally flat.
Well, it depends on the terrain of the region you're in. The Earth is more curved.
We're at the beach. We're looking over the water. We're looking over at the water. 1 foot elevation. The horizon should be at 1.22 miles.
Where
in the image that's in the side chat, the horizon. Well, how about we ask you where the horizon is, and you can tell everyone. In the image that's at 51 past the hour, where is the horizon?
Well, I think the question now is about the geometric versus the perceived horizon, because...
Well, your claim is it was geometric, so we're sticking with that.
Well, I'm saying
Remember
the
earlier,
horizon,
it was geometric? Yeah, you remember now?
Assuming light travels in a straight line.
Just hold on a minute, stop. There was no caveats to your geometric earlier, so why the necessity now? Did you just look at the image and you realise that the horizon is beyond 9.41 miles, so that's your sidestepping? You've got to add these extra little goalposts in there for me to try and kick towards.
Let me explain. Because in the beginning of my speech,
you don't have to explain. Why did you have the necessity to modify your statement?
Because I said in the beginning of my speech that I will not consider weather because it complicates things. But if we consider weather, we now have to think about refraction.
Against the weather. It's a sunny day.
Yes, and
you can see that. There's no clouds in the image.
There is atmospheric refraction.
Atmospheric refraction. I'm glad you brought that up. Because guess what? Your atmospheric refraction only takes you out to 1.34 miles. Congratulations. You just crossed one of the nastiest flat earthers here.
But
welcome
we're looking
to
at
flat
the model.
Earth.
We're looking at 6.1 versus 9.41.
As well, you've just tossed your geometric horizon under the bus. Yeah, you've just sacrificed it.
It is an approximation, but how do you explain it in the globe Earth or in the flat Earth by any chance?
Yeah. See, either the physical geometric Earth curvature is represented by the horizon, or it's not.
I think there is a geometric curvature, which is straight line, light trajectories, and then there
is the horizon. Is the horizon representative of that or not?
It is approximately the same, but you will see further.
Is it representative of it or not?
What do you mean by representative?
So, is the horizon we see the result of the physical geometric curvature of the Earth? That would be its curvature rate, the rate at which it is curving. And then we look out, and we can only see that far. No. Either it is or it isn't. Right, so we're either seeing a horizon at 1.225 times the square root of the observer's height in feet, or we aren't.
You're making a false dichotomy fallacy, which is a logical fallacy.
No, I'm
No,
not.
it's not.
Are we?
You are.
Are we seeing
You're
that? Are
proposing
we
it is
seeing
a
that or not?
geometric
lad,
Is the horizon
lad.
that or not?
Which one is it? Is the horizon physical or is it an optical? Which one?
It is a combination.
Okay, so which one comes first? You're looking across the beach. Which one do you see first? Physical horizon or optical horizon?
It is a compound effect, and you will see the combined result of both the physical and the optical effects.
So they're both the one and the same thing. You can't have your cake and eat it too, mate.
No,
Which one would you see first? The optical or the physical? If you're claiming they are both separate, one of them will obstruct the other one. Now, which one do you see first?
What I'm saying is that there is...
Lad, I'm going to give you the option. Lad, you're not thinking logically. You've
seems
claimed
like you
us to
don't
be
have my answer.
fallacious. Lad, this is what's going to happen. If it's optical, the optics would change on a daily basis, on an hourly basis.
And they do, yes.
And the physical horizon would get in the way at some of those viewings. So sometimes you would go out and you would see the physical horizon in front of the optical horizon. And other times you would go out and you would see the optical in front of the physical, in which case there would be some miraging effect causing a issue. You can't verify that. You can't back that up. You're just making claims of split horizons in order to protect your own ass because you realise that we can see beyond your geometric claim of 1.22 times the square root of the observer's height in feet. Based on a ball
that is your claim,
of 39.59 miles. So this is what you've got. You've got a ball claim
Seems like you
of
don't put my answer.
39.59 miles. How are you going to validate the ball claim when we've just debunked it? Your ball now, based on that one image alone, would need to have a radius of about 250 to 270,000 miles.
Hey,
do you live on a ball
So
that
to
big?
begin with, I
Where's
would need
the
to
image?
verify the data in your image. You've provided it to me, and you've not given me the
Yeah, put up the image.
Service of
It's
showing
already
me the
up.
actual locations.
I don't see anything.
But what I claim
okay then,
is that
lad, hold on.
Share your screen.
If you would like to... If this guy doesn't stop talking, I'm going to mute him. Beaver, look in the side chat, please. Now,
All right.
lad, all you had to ask for was, do we have any accompanying data? And guess what? Yes, we do. I shall get the video for you and post it in the side chat.
Thank you. But to return to the point, I think you are confused over the question of the horizon and what we see. I do not claim that we see two horizons, rather that we see one, and the location of that horizon as it is perceived by an observer at a given position is the combined effect of both the optical and the geometric processes.
And
The
you've got to
horizon
validate this how? How are you going to verify there's two separate horizons, both combined together to make an optical monstrosity that you can't tell the difference between which one is physical and which one's optical? If you claim they are optical, you're negating your physical curvature, therefore sinking the ball. If your
I've
claim it's
explained the
physical,
criteria.
if you claim it's
criteria
physical,
by which I determine
if
the
you
horizon.
claim it's physical, guess what? You've also sunk yourself because that image debunks your globe. I don't care which way you go, but you're going to hammer yourself, and we all get to listen to it.
Now you're in a position where you no, wait. Now you're in a position where you have to justify and validate the curvature of the Earth in order to claim that light is behaving in a way that allows us to see beyond its geometric limitations.
Well, are we accepting that optical refraction is a physical process that occurs, or do we have to?
No. First, before we even deal with that, because that's a sub
what you asked.
topic, right? That's a derivative topic. No. That's first we're going to have to establish that
It's a
physical
pivotal
curvature act exists.
Well, I'm telling you that the fact of the geometric horizon is proof enough.
No, there is no geometry. You threw that away. No, you threw that away, bro. You threw that away. You threw your geometric horizon away. No, you say that we don't see it. You had to. You had to say that. You say we don't see it. We don't see it. No, we don't see it.
We do. We do.
No,
but
we don't. No, we don't.
it is a compound
We do
effect.
not see. No, we don't, bro. No, we don't see a horizon
you
at
speak English, my
1.225
friend.
miles. No, okay, purely geometrically speaking, without any other variables involved, you would see a horizon at 1.225 miles times the square root of the observer's height in feet. That's a geometric horizon, and you threw that out. You say we don't see that.
I did not say that. You misunderstood me.
Oh, so we do see that. So the horizon is at 1.225 miles times the square root of the observer's height in feet.
Yeah, I suppose so, if Samantha is correct. What I was saying, I think what is misconfused is
You're trying to invoke refraction. Lad, the problem you've got, and this is something you need to comprehend, if you're going to claim refraction, you need to understand how much. In extreme cases of refraction, it goes from 1.22 times the square root of the observer's height in feet to 1.29. Well, that's moderate refraction. Extreme
Depends on
refraction.
your elevation as well.
No, it doesn't.
Yes, it does.
No, our elevation is locked at 1 foot. So you're claiming at 1 foot, the refraction index will change. I'm explaining to you now the differences in the refractive index. So moderate cases, it changes to 1.29. In extreme cases, it goes to 1.34. So if you wish to redo the maths, 1.34 times the square root of the observer's height in feet, which is 1 foot, gives us 1.34 miles. Now, as you know in that image...
That happens in numerical.
No. Your problem is you've realised that you've invoked refraction, and all of a sudden we're telling you what the refraction would do, and you don't like it because it doesn't do enough of what you require. The problem is with your refraction, lad, your refraction, you need something like 1,000% in order for you to get what you want. This is wrong. It's not going to happen. At best, you're probably going to get between, I think they recommend somewhere between 7 and 10%, and off the charts extreme cases, maybe 15% extra. So 1.22 plus 15%, let's go the extreme. What does that give you?
Plus 15% of 1.22 is like 1.45 perhaps, I don't know.
Okay, I'll go with 1.45. I'm good enough with that. How about we stretch it right out to 2?
Help. 2 doesn't
still
help.
doesn't help.
How
about we stretch it right out to 5? And it still doesn't help. That's the problem, mate. The levels that you need are off the charts impossible.
Plus, you're asking us to accept that the Earth curve exists in the first instance in order for light to behave through the air in a way that allows us not to see the geometric horizon. This is the thing. You can't say that you see the geometric horizon without throwing refraction away. Right?
Well, I suppose you do see the geometric horizon.
You're in a catch-22, bro. So what you have to do now is justify the Earth's curvature.
What do you mean?
Well, you've got to prove it. Go and measure it.
Prove that there is drop over distance conforming to a sphere with a radius of that value, 3,900.
It's a very picture.
371 kilometers.
The very picture yourself that you show, it maybe perhaps does not correspond to the radius, and we don't know what it is, but it does show that the platform which is further away is dropping below the horizon, which implies some kind of curvature.
No. Those platforms, no. Not in that. No.
Empirically, it implies a curvature.
No, there's no dropping behind the platforms. What the platform dropping behind the horizon? What are you talking about? Are you talking about
a different? We see more of the bottom
matrix.
Okay, lad. You're claiming that the back platform is lower because it's behind the horizon. Is that correct? Yes or no?
If I understand the image correctly, it seems that is the case.
Excellent. So when you look at the image, why is it the horizon is behind the back oil rig? If the oil rig is hidden behind the horizon, that means the horizon should be in front of the oil rig. Even you can work that out. That's pretty simple.
Well, I suppose the one at 6 miles is not obstructed by the horizon.
Do things get smaller as per perspective?
Neither of them are.
Yes, but they're not obstructed.
No, neither of them are.
Why would it be
they're in front
obstructed?
of them. They're in front of the horizon.
Well, it seems like a deceptive image.
It's not.
Like the point is the distance to the horizon. Okay, that's the crux of the argument, right? Not whether something appears to be obstructed bottom up from view. Okay, you see a horizon there. It's not in front of those oil rigs. Its distance is way beyond the geometric limitations of a sphere Earth with a radius of 3,959 miles, even granting you standard refraction. Even granting you a little bit more. Well, actually, a lot more than standard refraction. A lot more than what would even be accepted as reasonable within academic standards. Okay, so what you're going to have to do now, if you're going to claim that light is behaving in such a way that allows us to see beyond the geometry, the curvature, then you have to go ahead and justify that the curvature actually exists in order for that to happen.
I think me and Facts and Logic have explained several different ways why that is apparent, but...
Yes, and one of them was obstruction of view by a ship, right?
The sun.
Or the sun, right. So that requires a geometric horizon, bro.
Well, of course, yes.
And we push it right. So you've invalidated that. You've forfeited your geometric horizon by crying out refraction.
What I would say is that the refraction. So technically, you can actually see the geometric horizon.
Now we're going to go around in circles, because if you're going to claim that light behaves in a way that allows us to see more of the surface beyond its geometric limitations, you're going to have to justify the curvature exists in the first instance. You want to use circular reasoning and go back to the sun appearing to be cut off? Circular reasoning, bro. Well, we know that the Earth's a sphere because we see the sun cut off from view, half cut off.
What is my invocation of refraction invalidated?
The reason that the sun appears half cut off is because the Earth's a sphere. It's circular. What justification do you have for the curvature existing in the first instance? A measurement drop over distance, for example?
As you said, the spherical nature of the Earth implies a curvature because it is a geometric property of a sphere.
That's circular reasoning.
It is not.
It is. It's begging the question.
No, a sphere has curvature, Mike. It's one over the
You're using them inversely. To justify the other inversely, going back and forward. And then when we press you on the geometric horizon, you claim refraction.
No, I said that there are two effects.
Okay, lad. The problem you've got two situations. And for each situation, you're using a different excuse. The problem is, my friend, you can't do that. If you're going to claim refraction, you claim refraction for everything. If you're going to claim geometric horizon, you claim geometric horizon for everything. We don't care which way you go, but you seem to change depending on what you feel like.
Let me be very clear. If there was no geometric horizon, then we would not see any horizon, even with refraction. In fact, the Earth would appear to be convex.
No, you claim you don't see the geometric horizon. Is there ever a day where there's no refraction?
No, because there is always a pressure gradient.
No, so you never see the geometric horizon. Listen, I told you earlier, the geometric
horizon would be right in front of the optical horizon. So you can actually see it.
No, you don't. It's not forming a horizon. A horizon is the place where the land and or sea appears to meet the sky. We only have one of those. You don't see two places. You don't see two things of those. You don't see two instances where the land and or sea appear to meet the sky.
What I've said is
you only see one.
The geometric horizon. If you look at the sphere and you look at if you put the position above,
you've got to prove the sphere in the first place. Look, we understand that spheres have curvature. The issue we've got is when we go out into reality, we don't measure any curvature. So, if we don't measure any curvature, we don't have a sphere. Okay? It's that simple. You're making excuses for all of these optical effects and all of these things. But the base matter is, if we don't measure curvature, you don't have curvature. If you don't have curvature, you don't got a ball. I'm sorry, mate. But if it's measured as flat, it's... What the fuck did you just say?
One of you, maybe not you, but your friend says that there is a sphere. And the fact of a sphere...
No, he didn't say that.
Perhaps I misunderstood.
He said you did misunderstood. We understand that spheres have curvature. I think it's one of the main aspects of a sphere is its curvature. Excellent. So, if there's no curvature, what do you have?
Well, obviously a flat surface.
Excellent. Now go and measure for the curvature and get back to us. Go and measure the curvature for us and get back to us.
It's more of a roundabout argument, but the idea is...
No, this is not a roundabout. This is a direction. Go outside and measure the curvature and get back to us with your results.
Well,
and you watch what happens.
I can't do that right now, but I can read the many measurements of other people. But what we were saying is that the fact that...
So how do you know whose measurements are true? How do you know whose measurements are true and correct? How do you know whose measurements are false?
Well, how do you know that mine are true?
Unless you do it yourself, you will never know.
I can make a mistake. So can you.
And what's that got to do with the price of eggs in China? Everyone can make mistakes. So how do you know that your jumping on YouTube is true and correct? So if you watch 10 videos and 5 of them say flat, 5 of them say curved, which way do you go? Do you just bring up another video and say, oh, number 6 says it's curved, therefore consensus, I believe it's curved. Is that what you're going to do?
If I ask scientists and 100,000 say it is curved and one says it's flat,
scientists,
think it is flat?
Which field of science deals with shapes?
That's a branch of mathematics called geometry, which is employed in science.
And it's science. So pseudoscience or science?
What? No, science is a study of the natural world.
The definition, to separate the two of them, science follows the scientific method. Pseudoscience does not. So, does mathematics follow the scientific method? Yes or no?
It uses logical reasoning, yes?
No, it doesn't. So it does not follow the scientific method. So it's a pseudoscience. So, when
because
you
math
claim
is an empirical
that
study and
scientists... Yeah, we're talking about shapes. We're talking about shapes, geometry. Is geometry a science or a pseudoscience?
It's closer to a science. I would say it is an empirical science.
So what's your observation? So what are the steps in science following the scientific method? You make an observation. So what observation are you going to do? Oh my God, it's a square. And then what are you going to do? You're probably going to measure it.
Sure.
Yeah, exactly. So you're not doing science. So therefore it's pseudoscience. So you're in a category error.
What?
You believe that scientists are dictating the shape of the Earth, proving the shape of the Earth. They are not. This is a category error, my friend. You're in the wrong field.
You make a hypothesis and then you perform an experiment to either confirm or deny that hypothesis. And you repeat the experiment many times.
Of a square. Excellent. Yeah, no. That's just silly.
Well, it would be silly to think that
in order for you to validate all of your stuff that you claim, you probably should come back with measured drop over distance. If you come back with that, then you can claim geometric horizon and you've got no problems. But till then, I don't think you've got a leg to stand on.
Well, he can't. He can claim a refracted horizon of a sphere.
If he measures it, he can claim whatever he likes. I'm happy with it.
Yeah,
I can observe it.
Hello, what's going on here?
I think because it is impractical to do, it's sort of an appeal to authority fallacy in a way because I can't do the experiment myself. And so you're saying I don't have a right to argue until I do the experiment, but I can't.
So you'll never know.
You can make observations which contradict it.
So I make exactly. I can make observations, and I have made
You
observations.
can falsify it. Yeah, falsify it like we did, like we showed you. We falsified that claim.
Well, we can talk about things we all observe in the same way, like the sun setting below the horizon. Is a very easy thing to talk about.
Is that proof that the Earth is a sphere?
It's proof that there is curvature at the horizon. It's proof of a geometric horizon.
How is it? How is it?
Because there is no geometric horizon in a flat Earth.
Wait, what? Wait, are you saying there's no horizon at all on a flat Earth? Not a geometric one.
Here. I know.
Just a horizon. Just a horizon. Can you have a horizon on a flat Earth?
I would argue that if you had an infinite flat Earth, there would be no horizon.
What? Why?
Because light rays would continue.
What would it look like then? What would it look like then?
What do you mean? An infinite flat Earth would be like a plane.
So what would it look like then? You were standing at the beach and looking out over a vast distance of flat water. What would it look like?
It would be an infinite expanse, and in principle, you could resolve objects at any distance. The problem would be optical effects, atmospheric refraction, and obviously the resolution limitations, which would not allow you to resolve objects. But the distance at which you could see would be much greater than in the global Earth.
Yeah, we've shown you that that's true.
But no, you've shown me some images of some numbers which are not verifiable.
Being able to see further than the geometry of a sphere with a radius of 3,959 miles allows for. Yes, we've shown you that. Exactly what you're talking about.
We still see the objects dip below a visible geometric horizon. They don't fade out because of resolution issues. They don't blur out and become small. They dip below a physical horizon.
So how about, instead of saying because a horizon can't exist on a flat Earth, how about you prove how the sun appearing to be cut off from view by the horizon is proof that
Because if the sun is above the flat Earth, then there is no way for me to draw a line.
Don't mention flat Earth. No, don't mention flat. You don't need to mention flat Earth. If it's indicative of the Earth being a sphere, then just talk about that.
It's proof by contradiction.
No, you don't. No, it just needs to support its own merit. How does it tell us that the Earth is specifically a sphere?
Because in the dichotomy which I'm proposing, which is either a flat Earth or a spherical Earth,
no.
You can prove that if it is not one, it must be the other.
No, because you're excluding other potential shapes. So do you know
there is a convex.
So the ancients looked out at the Earth. So the ancients looked out at the Earth and saw a flat Earth, and they assumed, by your standards, that the sun was actually going below the flat Earth because the Earth looks flat. Okay, so how did you determine that it is the result of the Earth being a sphere that you see that, and not some other thing, not the result of some other variables like optics and weather conditions?
Because the sun is visible at every time by people in different parts of the Earth, so that is how we know that this is going around and not under.
No, that's an affirming the concept. That's fallacious, bro.
Isn't that what you say?
Do you not know what logic is?
Well, let's talk about. There are three types of curvatures.
You need your premises to be true for your conclusion to be true. Yes or no?
Of course.
Right. So, can you formulate that into a logical syllogism for us?
Which claim?
The sun appearing to be cut off by the horizon, indicating the Earth is a sphere, or drawing the conclusion that the Earth is a sphere.
Well, it's like you said. It is not a straight logical argument. What I'm saying is that if we were arguing between a flat Earth and a spherical Earth, it would not be possible on a flat Earth.
No, it either proves the Earth is a sphere or it doesn't.
It proves that this is not a flat Earth. It does not prove it is spherical. No, but a spherical Earth would allow it.
Right. So it's not proof. It's not proof that the Earth is a sphere. Okay. Have you got any proof that the Earth is a sphere? Have you got any proof the Earth is a sphere?
Well, the fact that you can walk in a straight line around the Earth and get back to where you started. That's one.
Okay, who did that? When did you do that?
There are people who've sailed around the Earth.
Okay, I thought you said walked. I thought you said walked.
Well, by some means of transport, sure.
Okay, so who did that? Who sailed around the Earth in a straight line?
Perhaps not a perfectly straight line, but the trajectory is such
Okay, so
that...
then we can throw that out. Have you got anything else?
There are many experiments, such as if you look at the telephone towers that go to a great distance over bodies of water, they sink with irregular
Anyway,
rate of sinking.
If there's, sorry, one sec, hold that thought. If is anybody else here, I'm probably going to be pissing my family off right now, but being talking like this and being loud. Can someone else please take over?
Well, I guess by elimination the Globers wins because I'm the only one left.
No, surely we've got somebody else in here. Hang on, let me see. Who else is in here?
Oh, don't worry. I was just out in the other room. I just had to do a run.
Oh, cheers.
And would you say
Excuse me.
by elimination you win? I don't think so, Tim.
Well, it's the same logic as whoever speaks the loudest is right, as you've adopted, but...
So what is your claim with telephone towers?
Well, okay, maybe not a boat, but that's about... Maybe look at a plane. We have seen planes circumnavigate the Earth in roughly a straight line. That's a better example.
And what did they prove?
Well,
I'm sure we had this discussion earlier. You
can't
chose
fly in
not
a straight
to listen.
line on
That's
flat Earth.
No, you
wasn't
don't
here.
fly in a straight line. You fly horizontal over a planar surface. That's what the discussion was with facts earlier.
Yes.
You weren't listening to that?
Relative to the local tangent
Excellent.
space.
Relative. Excellent. So now you've got to prove your curvature. So you've made a claim. Now you've got to prove it. This is where you guys come unstuck, is the validation of your claims, the verification of your claim, proving your claim. How are you going to now prove drop over distance? I would suggest measuring it.
What's so funny to me is the flat Earth is like afraid of actually having their own model. They can't. They never.
So now you're going to sidestep.
They can't.
So in order for you to prove curvature, you're going to talk about me not having a model. Why does me saying I live on a planar realm, why does that necessitate a model in order for you to have some kind of validation that it even exists? Why do I need to reify reality on a freaking map in order for you to feel better about yourself? Don't understand? I'm not going to complain if you don't.
Well, it's just it's very hard to, if you don't have a worldview.
Lad, the basics of it,
can work with.
I do have a worldview. It is planar with topography. It's got hills and rivers and valleys and trees and stuff growing on it. Also animals living there of all different shapes and sizes.
Well,
some live in the water, some fly in the air. Some walk across the ground.
So you have a model. You have a
It
model.
is planar. Do you know what planar means?
It's a plane, yes. It's
Excellent. It is measured as such. Unless you can provide measurements that contradict this, you're not going to go much further with me.
I think that's sort of the root of what I'm getting to, is that we both have our own models, and so...
No, stop. You have a model that you haven't verified. I have reality which I've measured. You have not measured. So which one is going to have a higher ranking? A direct measurement or a model that is yet to be verified? Which one do you believe? Let's just say you and me are walking down the street. We're walking along, talking about cars, having a great time. And two people walk towards us. One of them says, I've measured my table. The other guy says, I think my table's a circle. Which one are you going to believe? The one that's measured his table or the one that thinks his table is a circle?
Sorry, I was talking with somebody. But what I'm saying is that if I can look at your model and I can see something that happens in real life, which does not make sense in the model.
Stop! lad, all you have is a model. You've got no backing. The reason we have flat earthers is because they grabbed the model that you're talking about, they went to reality, they tested the model, and it failed.
Because
Do you understand that?
And they're too dumb to understand it. It's very simple.
So how can you get a tape measure wrong? Please tell me. How do you measure a tape measure wrong? Do you use the wrong coloured one? You're supposed to use a yellow one instead of a red one. We're talking about measurements. Drop over
You
distance.
sit on boats of different heights and your calibrations are incorrect. Many different ways it can go wrong. Or your
So
flashlight
you don't even know what I'm talking about. So we grab a laser, and point it horizontal. That's it. So
how do you know your level's correct?
Question. How much variation? So let's just say, for example, that I'm at the right distance for a 10-foot drop over distance. So 10 feet. So from one end of the laser, it's 1 foot off the ground. At the other end of the laser, it's 10 feet off the ground. At what point would you say it could go either way? 9 foot? 8 foot? 7 foot?
Depends on the error margins of your calculation, how accurate
No. You've got a choice.
Yes, absolutely.
Somewhere between 1 foot and 10 feet. It's supposed to be a 10-foot drop. Where do you draw the line and say, no, could go either way? At what height would you say the laser could go either way? 10 foot? 9 foot? It's got to be somewhere between 10 and 1. At what point do you say it could go either way? At what number?
What do you mean either way? And what is the numbers?
Well, the laser... Listen, if the laser is at 1, that means ground is dead flat.
Okay.
If the laser is at 10 foot, that means there's drop over distance. So where do you draw the line at it could be either way, let's redo the test? Or we've messed up, let's redo the test.
What is the distance between the measurement
do you
points?
draw the line? It doesn't matter.
It does.
We're talking about No, it does not.
For me,
We're talking about the end result. It is somewhere between 10 foot and 1 foot. 10 foot means the curvature is true and correct. 1 foot means it is dead flat. At what point, when you're doing the test, would you say we need to check our calibrations because it's in the middle? So 4, 5, and 6, 5, 6, and 7. At what point do you pull the pin and say, no, we have to do this again?
Tell me, throw out the distance. Like between the points you're measuring, tell me how far.
Not relevant.
Yes, just tell me. It helps me.
No, it's not relevant. For fuck's sake, how many times do I have to say it? Not relevant. It's a 10-foot drop if it's a ball. It's a 1 foot if it's flat. So, at what point do you... Exactly. Okay, fuck me, Dad. I'll get a curve calculator out. The distance has no relevance to this argument. I just want to know where you draw the line and say, I'm not sure.
But the
laser. Okay,
the amount of drop
you've got a laser.
Right?
Lad, we've got a laser. We pointed across a lake.
Okay.
It's supposed to be 1 foot. It comes out at 10 foot. That would mean it's curved. It's supposed to be 1 foot. It comes out at 1 foot. That means it's flat. So, where does Lad draw the line and say, hang on a minute, we have to do this again? So, for example, if the laser came out at 5.5 feet, what would you say? Is it flat or is it curved? Or would you say we should do this again?
If the boats are 10 feet apart and it's 5 foot difference, I'd say probably do it again.
That's what I wanted to know. So at some point, you've got a line that says, we've fucked up. Now, the problem is, the distances these guys are doing the tests over, we're not talking 10-foot difference. We're talking 400 feet difference. Okay? So if you're out by 10 foot and it's closer to the curved end, I would say it's curved. If you're out by 10 foot and it's closer to the flat end, I would say it's flat. The problem you've got, these guys are out by about 4 inches, I think, in one of the tests, and 8 inches in another test. 8 inches, and it's supposed to be 400 feet. This is the problem, lad. When we're testing this, we're only out by point stuff all of a distance. Your margin of error that you require for us to be out exceeds 1,000%. You don't get this. For some reason, you don't want to accept it. These laser tests show. Now, before you turn around and squawk refraction, I'm going to allow you to have 15%. So have a go at this. A drop of 400 feet. So 400. I'm going to get me little calculator out so I don't stuff this up.
Maybe if you have a diagram of the experiment so I can better visualize, because I think maybe I don't understand exactly.
They've posted the laser tests already. I'll get another one for you. Hold on, hold up. I'll grab another one for you. Stand by, because I've got a whole pile of these things somewhere. Click on that map. Down to laser, laser tests. Here we go, nice. There's one. Actually, we'll post that one first. Copy link, go back to this channel, and post that for your convenience. Right, there's one. When it pops up, there it is. 21 miles, no curvature. 21 miles. I wonder what the drop over distance should be at 21 miles. Let's have a look.
Is this a safe website?
Curve calculator. Let's have a look. Target distance. 21 miles. Excellent. Observation height. 0.5. Oops. 0.5. Calculate. We've got a 270 foot drop. So, that's what it's supposed to be in order to have a ball. Now, let's say the laser at the other end was out by 5 foot. Would that be an acceptable tolerance for you, yes or no?
A margin of error of 5 feet.
Margin of error for the numpties at the other end didn't point the laser correct.
Oh, it's about 2%, right? So that's probably good, yes.
Excellent. So, what's your problem with the flatness of the ground? Maybe you should watch that video.
There is no laser test where if the laser wasn't leveled, it would be it would help the sphere Earth anyway. I mean, there has to be that drop over distance, not a rise over distance, unless you want to claim concave.
So, just so you know,
if it was not, you would see, you could see both.
Hey, check this out, lad. Allowing for your refraction, it would take 40.5 feet off of that drop over distance. So that would take you back to 230 feet. So that means that at that range, inclusive of a 15%, 15% allowance for your refraction, you would still have to give me 230 foot of drop. You guys just don't get how flat it is.
But we see
230 foot. I've given you refraction. I'm letting you have refraction. So you can take refraction and you can cuddle it. It's there. I've included refraction. No refraction, 270 feet. With refraction, 230 feet. That means that that target has to be allowing for the ball 230 feet below your eye line.
Wait, I joined late. What's the argument here?
What was the observed hydro up at the distance of 28.6 miles?
The 28.6 miles. What do you want to know about that one? Sorry.
So it was the height drop difference they measured. I can't find it in the video.
I was talking about the first one, the 21 miles, but the 28 mile, I'll just redo it, 28 miles, glasses on, that might help. What was the viewing height for the 28? It was 1 foot or half a foot? I can't remember now. I'll put it at 5 foot just to cover it, just to make sure. I know it's below that. Okay, for the 28 miles, based on a 5 feet elevation, is 425 feet drop. Would you like me to give you some refraction too? I can do that for you.
I mean, like, only a misalignment with level in the minus. If it was in the plus, right, then one could actually say, well, thanks for proving the ball, right? You claim it was level, and it wasn't. It was misaligned, and it was in the plus, above level, and that could give a deviation, which might meet the standards for someone claiming it is a globe. But in the minus, that's not going to happen. It's right. If it hits its target, even if it's in the minus, that's not going to help your ball. That would be upward refraction, right?
So just
if it was a flat Earth. Yeah, but how is a miscalibration, right, going to help in any way?
Okay,
it wouldn't. It would just invalidate the experiment.
Let's just say you and me go and do a laser test. This is what we're going to do. We're going to stand on one side of an exceptionally large lake. It's a beautiful, clear night. There's no waves. There's no ripples. The water is like glass. So what we're going to do, we're going to set the laser up at 1 foot, right? So this lake is 28.6 miles across. We're going to set the laser up at 1 foot. And then what we're going to do, instead of setting it up perfectly horizontal, we are going to lower the laser down so it touches the water, and then we're going to lift it up so it just clears the water. That, if you live on a ball, would be a tangent. Now, if that is true and it is a tangent at the opposite end of the 28 miles, you would need to have 478 feet of drop. So we don't even have to set it up perfectly horizontal. We can lower it down so it touches the surface, and then we can back it off so it just clears. And that is the optimal way to do it. The only problem is sometimes there's waves, sometimes there's some moron in a boat fishing. There's all these things that interfere with doing laser tests. So we aim the lasers across them or above them, which changes our numbers slightly due to elevation. But at 1 foot, and if you lower it down so it touches the water, you're going to need 478 foot of curvature. If we get to the other end and you can touch that laser, or better still, if that laser is within 20 feet of you, shit, mate, you might want to be looking for another ball or another job, especially if you're out surveying.
Yeah. I mean, if it meets the target at all, like an area with a with a tolerance level, right? That's that is with with it's where it's not outside of the the expected deviation of a sphere, then it wouldn't matter if it's aligned or not, bro. Like, what I don't get it. Like, that wouldn't be an indication that that they've done like the test wrong or anything, or the Earth's a sphere, or I don't get it. Like, because like Matrix is saying, over that sort of distance, there's like a significant amount of drop, a lot.
Oh yes,
right. So how would misalignment of the laser, right, even if it hit the target, being misaligned from level, how would that make any difference? You seriously think that's going to allow to reach a target 230 feet
If it was
below level.
If it was beyond the optical horizon, you're right. It shouldn't make a difference because it wouldn't be able to contact it to begin with in principle. If it was in front of the optical horizon, then you could imagine that the laser was miscalibrated downward, so that could show a result pointing to flat Earth when indeed it could be round still.
It pointed downwards not going to help you. If it hits the target pointed downwards, it's not going to help you. It's not. It's not going to be pointed downwards 230 feet below the geometric horizon or whatever it is. Below the point of tangency.
Well, if you're sitting, if the target is elevated perhaps above the horizon, but the boat is sunk below its level, you can imagine the case in which...
How high would it have to be? 6 stories?
Could be off by maybe 1,000th of an angle.
No, the laser would have to be like 6 stories high, bro.
What? No, I'm saying if the perhaps if the boat is sitting on the optical horizon, something like that.
Oh my god.
Okay, if you're claiming the optical horizon and or physical horizon, when I say drop over distance, these 478 foot at 28 miles, what I'm talking about is how far behind the horizon a given object is hiding. That's what we're talking about. So when I say 478 feet, that is allowing for your horizon. That's how tall your item needs to be in order to be seen. Do you understand that? So your claim of optical or physical horizon in this context means nothing because we're already using that. Just so you know, type into Google Earth Curve Calculator. And everyone can do this. It's very easy to do. And it will bring up a whole heap of them. The one I am using is the one from GitHub.io. That's the one I'm using. So you put in whether you're metric or imperial, your eye height, you put in your target distance, and then you press calculate. And it works it out for you. And down the bottom is a picture of an arc with a flat horizon, and it shows you HO, which is the height of the observer, H1, which is the missing height or target hidden height. It also has distance D1, which is distance from the observer to the geometric horizon. And that's what we allow for when we're talking about this drop over distance.
Where is your source coming from saying that optical refraction can only account for up to 15% beyond the geometric horizon?
There was actually a physicist that was it was on a video. I did have it here somewhere. Stand by, I'll go and find it. It was a physicist talking to...
I'll post it.
Oh, do you have it, do you? Please tell me you've got it.
No, not that. It's probably in DJ server, but I'm just going to post aty.edu.
Yeah, the one I was talking about was the one that DJ posted up the other day. It was a physicist. I think it was talking to Dave Weiss. I'm not sure now. And yeah, he was asking about refraction. And the actual physicist himself turned around and said, yeah, somewhere between 7 and 10%, maybe 15. I just give people 15 because I'm being ultra generous. But the way he was talking, you're not going to get much more out of 10. And even then you're going to get change. So, yeah, I found that very interesting because every second person comes in here, as soon as we mention anything optical, it's refraction, and we've heard it a zillion times, and they don't even know how much refraction there should be, refractive indexes of whatever they're trying to push through. Like, half of them wouldn't even know what the refractive index of air is, but yet they claim it. It's crazy.
We had to do the calculations ourselves, I think, because it's sort of also not right to appeal to the authorities, some random physicist, right? I don't know if he's right. Maybe he is. But Let's find the formula and do the calculation to see what would be possible.
Well, we already know with the Black Swan that instead of being times by 1.22, I'm allowing you to times it by 2. Extreme cases of refraction will take you out to 1.34. And I'm going to allow you to go up to 2.0. That still will not cover what you require. The horizon is clearly at 10 miles. And just to add insult to injury, if you watch the video, just to the right-hand side of the oil rigs, there's an island. That island is 27 miles away. You probably shouldn't even be able to see it at all. That's a lot of refraction to cough up. You're worried about the 10 miles and the oil rigs? Those oil rigs are for demarcation. And just to explain it to you a bit further, I want you to imagine that picture with no oil rigs, no boats, no nothing. Just a beautiful horizon. How do you tell how far that is without some kind of demarcation there? That's all the oil rigs are for, is for demarcation. So, because we know the distance to the oil rigs from that given position, and we can see the horizon is clearly behind the oil rigs, we know that one of the oil rigs is 9.41 miles. We can guarantee that the horizon is behind that. So let's just cap it at 10 miles. If that's true, that your geometric horizon is at 10 miles, it should be at 1.22. If it's at 10, that means your Earth's radius, instead of being 3,959 miles, it all of a sudden goes beyond 250,000 miles. That's the levels of magnitude, how far you guys are out. And most people don't even know that. They just go, oh yeah, it's because of refraction. That's all. That explains it. No. You have no idea the levels of refraction required to even get halfway. Hell, I've doubled it for you. I've tripled it for you. And it still doesn't get you halfway. Maybe instead of just squawking the rhetoric that we've all had jammed down our necks from school, maybe you should have a look into this stuff. You might find it interesting.
Are you sure the observer height is 1 foot, actually? Because
I'm quite
how are we
certain.
seeing...
In the Black Swan, it is 1 foot. Watch the video. You can watch him place the camera down on the sand.
In the picture which says bye-bye ball?
That's just one frame out of video footage. The video was put up for your convenience. The video is there. I posted it already. I'm just going back to find the timestamp.
It appears he's elevated by at least 10 feet in the video, if not more.
It appears he's elevated at least 10 feet. Well,
it looks like he's standing on an
embankment. I might repost it because I've just scrolled up a shitload and I can't.
Sure.
Hold on.
Not really sure that the 1 foot claim is true.
Yeah, well, it's actually about 8 inches, but they just cap it at 1 foot so they can be nice to people like you.
I wonder how he sees so much of the water. He should be almost level.
10 feet wouldn't help. 10 feet wouldn't help you.
No.
I think you need something like 30 feet or even 60 feet or something.
There you go. Inside chat. 47 past the hour. YouTube video by BMLSB69.
Nice.
Okay.
So just so you know, lad, you claim it looks like it's at 10 feet. I just put that into the Earth curve calculator. 10 feet, 10 miles. Okay? And when I hit calculate, the geometric horizon distance is at 3.87 miles. Still in front of the right-hand oil rig.
Well, okay, maybe it's 8 inches above the ground, but the ground itself is elevated above the water. You can see it's on the hill.
No, that's above water level. He goes right down to the water. If you watch the video, he nearly drops it into the water. It leans over. It starts leaning and he picks it up from dropping into the water.
Look at 4 minutes and 30 seconds.
Four minutes and 40. Was it 4 minutes and?
About maybe 4:20 actually.
4 minutes and 20 seconds. Hold on, I've got to get the video back up. Video, come here. Okay, 4 minutes. Oops. Let me slide it. Nope.
Is that not the beach I'm seeing right in front of him?
4 minutes and what we after? 4 minutes and?
About 20.
4 minutes. I'll let it play from 15 onwards. That dark patch?
Yes.
No, that's not the beach. That's still water. That was on the left-hand side. That is still water. Yeah.
It seems like he's quite high above it, no?
Zooming out, zooming out, zooming out. From that point, he is quite high above it. That's when he's walked back. You've just you've done what we call skimming. You've skimmed through the video. So
well,
what I'd like you to do now is go to 1 minute 22 and play from there. Because I know it's in the start. It's only early. It's like 1:30 or somewhere.
Oh, smarter. Okay.
It tells you where it was taken, date it was taken, wind direction. Hey, get back here. I was looking at that. Significant wave height, dominant wave period. Oh, it even has atmospheric pressure. Oh, look at this. Pause.
Well, the temperature was also very above the water, but...
Oh, how? I never realised this, T-Dub. It has air temperature and water temperature. Get away. This is for the original Black Swan. All the shit that we've heard from people squawking about. Indeed. 2.6 degrees difference in temperature. That's not going to generate much refraction at all. Look out, globetards. It's hammer time. Oh, yes. Oh, this is going to be too good. Oh, man. Yeah. Sorry,
so
mate. I just noticed something that I've been looking for a while. Apologies.
I would propose to you that the obstruction you're seeing at the bottom is actually the waves, it appears.
Well, on that surf report that I was just looking at, which I was somewhat entertained by, I'll let you have your obstruction because significant wave height, 5.6 feet of wave. So the problem you've got there, we're seeing beyond 9.41 miles with inclusive of a 5.6 foot wave height. Oh my. That does leave a problem. It leaves a lot of questions, actually. How would you explain that? Maybe there was no waves at that particular time. The issue is, if there was no oil rigs there, we would have no way of determining how far the horizon is. That's all we need to know. How far is the horizon? We know with the given mathematics and the given radius that we're all taught at school. Maybe you were taught in kilometres. I was, but it's easier to translate from miles to kilometres. A radius of 3,959 miles. That's what we were taught this ball is. This imaginary ball. It's that radius. If that's true and correct, then we should be able to calculate the horizon. So where is the geometric horizon? 1.22 times the square root of the observer's height in feet. So all I need to know is how tall are you? Were you lying down when you took this? Did you put the camera close to the sand? Is it 2 foot? Is it 3 foot? Did you hold it up at head level at 6 foot? Hell, you might be a giant. You might be 7 foot tall. Whatever your eye line is, you add that into the calculation. And then you go, excellent. I should be able to see the horizon at this distance due to my height. That's all it is. It is ever so simple. If the horizon is closer than that given distance, you should ask questions. If the horizon is further than that given distance, you also should ask questions. Don't just band-aid refraction onto it, because maybe there's something else going on there.
Okay. Have you personally done the calculations for the refraction? I'm finding... I can't... There's not one formula, but you have to piece a bunch of stuff together to do the calculation. Okay. Let's see.
Well, anyways, to start off with, if you go to 1 minute and 46, that's where he's down on the beach. That's where the original image was taken from. Out of that video footage, it is one frame that's been grabbed out of the video footage. Anyways, while you're looking that up, there's been a whole pile of new people come and go, and they're probably waiting ever so patiently for a turn. So up the top, we've got Blue. Welcome, Blue. We've got Dirty On. Or you can just run away. That's cool. Dogma. We've already spoken to Facts and Logic. He's floating around having a bit of a listen. That's cool. Joyce. I don't remember hearing you speak yet. Mido Surreal, welcome. Morez, welcome. And Teddy, welcome to the channel. I'm quite sure you guys have got questions, concerns, queries, maybe even proof of curvature. I'm good for all that, but I'm going to put my feet up for a while and let someone else have a bit of a yap, because I'm getting hungry and it's feeding time at the zoo. So I'll be having a listen. If someone else wants to step in, Jamsy, or John Luna, I'm good either way, but I'll be just sitting at the back for a while.
Okay, guys, I have some questions about. Is there anyone who believes in flat Earth?
Yeah, hang on, mate.
Sorry.
Hang on a sec.
I forgot to mention,
Sorry.
it's not a belief. Oh, you're up, T-Dub? Cheers, man.
No, I'm not. I've just seen who's in here. So, Jamesy, can we get check-in, or John Luna, Kembo, who else? Orion, Ethergrass, are you available? Anybody? FE Batman? Anybody? Injana? please, any of our regular speakers, anybody out there on YouTube that's listening, Flat Earth, that can come in, that has a spare moment, come in, please. Matrix and I got our hands tied, seems. We'd appreciate somebody.
Devil's advocate.
How's it going, everybody?
Hello. Some people here got some questions.
We're switching sides or what?
Who's got the questions? What's the question? Go ahead and ask your question. Well, golly, why did it go quiet all of a sudden?
Okay.
Who was it? Was it you, Fax, or was it who was it? Was it Blue? I'm not sure who it was asking. But someone had some
No,
questions.
it was not me. I don't remember his name.
I think it was Morez, or does he say it?
Morez. I
might misremember. Not to put you on the spot.
Yeah, I'm done. I'm here. Yeah, I want to ask some questions about from the fans of Flat Earth.
Ask your question.
Okay, and my first question is, I don't know why, if the Earth is flat, so why do different stars appear in the sky in the northern and southern hemispheres? I mean, on a flat Earth, everyone should see the same star. So why there are different stars in?
That's not true. That's just a matter of your position on the Earth.
I mean, no, it's not just a perspective. If Earth were flat, we would all be looking at the same sky dome. So, but in reality, Polaris is visible only in the north, and the Southern Cross only in the south. Then that's only possible on a sphere, not some flat objects.
That's not true. Think about looking down the corridor of a hallway, and you'll notice that you won't be able to see the end of the hallway anymore. As a matter of fact, the ceiling will appear to meet the floor, and the floor will appear to meet the ceiling. This is the same thing that happens with, say, Polaris, for example, when you get too far away from it. It appears to drop in your field of view. It's all perspective, 100% perspective.
It's not just about that you're looking at the different angles of the dome. It's just about the exact position of that star. For example, you won't see Polaris in the south. So it is only visible in the north, and that's what you can be in a sphere, not in a flat object.
That's not true. Just because you don't see it doesn't mean that Earth is a ball under your feet. I don't know. I don't know how.
In a flat thing, you can easily see everything. I don't know. I'm not.
That's not true. If I were to put a small itty bitty little light at the very end of a really, really, really long hallway, and we'll call where that light is north. Okay. And then we'll go all the way to the other end of the hallway. We'll call that south. At a certain point, you're not going to be able to see the light anymore across a flat floor down a hallway. Like it's all perspective. It's all been explained through perspective and through things like light attenuation. It's pretty simple.
But that's just because the hallway is like a small area, but the sky is open. There is no, like, you know what I mean? There is nothing to block the view of this light.
what makes you think that you should be able to see the stars? No,
I'm not able to see, so that's why I'm asking that question from you.
Yeah, he's saying like if it's level and I'm standing in the north, I'm seeing one star. If I'm standing in the south, I should see the same star because it's level.
Okay, if you go to a very large and you are standing at one end, you have trouble seeing the lights all the way down the other end. Then when you walk all the way down the other end and you look back, you have trouble seeing the lights all the way at the start.
Yes.
Excellent. That's the same thing that happens outside.
No, but the problem is...
Why, stop. Why did you say no? So you understand that by moving, it changes your view, and all of a sudden you go outside and it's because of curvature.
No. I was not going to say you're jumping the gun here. I'm saying the light you're talking about, like if you're saying normal light or the lights we know, it's not as much of like a big source of light like a star. It will not be dimmed by this small
same difference. Exactly the same difference. The only thing is larger scale. So inside large factory, you look up at the lights at one end of factory. So end A, we look up, we see a particular light pattern. And then when we go all the way down to B, we look up, we see a different light pattern. That is what is happening outside. At your house, you look up, you see one set of lights. From my house, we look up and see another set of lights. Funny part is, in between, we see the same lights in between. So we are just on a very large flat surface, looking up from a different perspective. That is all.
So are you saying that we are seeing the same light but from a different point of view?
Correct.
But it's totally like the shape.
So what that means, what that means, I can hear not two at once, so it just wrecks everything. What that means is, it doesn't prove the shape of the ground. It doesn't prove flat, doesn't prove curve. So it's not a very good reason.
Okay, wait. Let's go back to the point. You're saying that like if you look at a certain star with a telescope, for example, from the north, and if I look it from the south with the same
I'm going to
telescope...
stop you. Blue, I'm going to stop you because looking at the sky doesn't prove the shape of the ground. I just don't want you to waste 10 minutes trying to explain that and converting from your language to English, and because it's not easy to do, I know that, because English is horrible to learn. Looking at the sky does not prove the shape of the ground.
If I'm looking at the sky and I'm seeing something...
I mean, just Matrix, can you just show me one photo of Polaris from Australia or the Southern Cross from some European countries such as UK, for example? Just one. I mean,
just out of curiosity, why the necessity for photographs of things that are exceptionally long distance away? What will that prove?
People, for example, people in Australia never see Polaris, and people in
I know. I live in Australia. I know this. And Morez, stop. I know. I live in Australia.
Yo, why are you getting angry, bro?
I live in Australia. I know what you're talking about. I want to know, what is this image going to prove to you?
Because
what does it prove?
That you can see Polaris from, so it is not.
I just explained to you that it's too far away, and then you turn around and say, after you've been told it's too far away due to the low angle, you won't be able to see it. You still expect the same thing as just what was refuted, and a reason given for it. Why is that?
Well, if you're in Australia,
it is too far away. You cannot see that far because of how low it is. Due to perspective, it is exceptionally low in the sky. Anything beyond the equatorial line or equator is too low in the sky to be witnessed. There is claims that some people have seen Polaris from the top of New Zealand. I personally think this is bullshit. But anyways,
I mean,
I'm
if
still
you say
looking at
the
that
stars are
information that was
fixed
given.
we are okay. And do you agree that in your theory we are all under the same sky?
Not a theory.
Okay, your fact. Okay, the flat Earth is real and it's a fact. Okay, if based on your fact, we are all under the same sky dome and the stars are fixed to it. I mean, even not only you, but the southern people, such as European countries, can easily say Polaris, or you can see Polaris. So we should be able to move anywhere on Earth and still see some part of every star pattern. Just at a different angle, but that's not what happened. That's not gonna.
Wrong. You're not listening. You're repeating the same stuff. The reason is perspective. When you are looking long distance, things that are high appear to come down. It's called convergence. So, do you know when you're looking along railway tracks, they appear to rise up? Have you seen this?
No.
Well, not that I would advise anyone standing on railway tracks. This is probably not safe. But if you are standing along... Actually, I'll get a picture for you. I'll put a picture up. Much easier. Much easier. Perspective. Where is the railway track? There it is. Come back. Railway tracks. Right. Someone's already posted up a picture of the corridor. The other funny thing, see how the railway tracks appear to fade away to a point. See how the power lines appear to fade down to a point. The stars do the same thing. When they are directly above your head, very easy to see. When they are a long way away, they fade down to a point and you can't see them. When you pick up a telescope, all you're doing is improving your optical range. You may see a little bit further due to the optics of the telescope. Actually, it's highly probable you will see a little further due to the optics of the telescope. But the same effects still apply. Perspective, convergence. Angular resolution.
Perspective doesn't make stars disappear behind the curve, okay? It just makes
there's no curve. Okay, Morez, there's no curve. The reason we know this is because we don't measure any. If there's curvature, we would measure it. That's the problem. We measure as flat. So if we'd measured curvature, I can assure you now, my friend, I would not be here.
And how do you measure curvature?
You can use a laser to measure over long distance. Over a lake, for example. Whoever just asked.
Doesn't
I don't know
even
who just
reverse
asked.
sport rays, okay? How can people in the southern hemisphere all see stars?
Okay, there's two of them talking at once. I missed that. Start again, please. I missed that.
What I actually understand about you guys is you think that perspective is your favorite magic trick, but at some point,
no, it's not.
If your model can't predict what real people see,
we don't have a model.
It's time to upgrade your fake theory, okay?
No model. Morez, no model. I don't know what model you're talking about. There is.
That model that you're saying that we use telescope, okay, we easily can see
all I said with the telescope
distant objects from that at any place.
He's regurgitate the same crap we learned at school.
Relax now. Just calm down and just wait for a response before you start talking again, please.
In the image with the railway tracks, do you see the power lines come down and the railway tracks go up? That's what they appear to do. Do you see this? Yes or no? And now he doesn't want to talk.
Yeah, say again.
In the image that's on side chat, do you see the image of the railway tracks there with the power lines and the grass on either side? see that.
Okay.
Yes.
Maybe post the power lines over water as well for comparison.
I see the image, yeah.
Excellent. Can you explain to your friend, see how the power lines look like they're pointing down to the center of the image? As per perspective? Right, the stars do the same thing, except they start from a little higher and they come down to the horizon. The horizon is just the point where everything converges. That's all. Where the sky appears to meet the ground, or ocean if you're on the ocean. That's all it is.
Okay, bro. I mean, yes, parallel lines appear to converge at the vanishing point based on your picture, but I mean, this is just how our eyes perceive depths. It has nothing to do with these objects.
That's what the stars do.
Behind the curve. Okay.
That's what the stars do. Same thing. The stars do same thing. Yes, yes. The stars do the same thing. You can say no, but you just said that's what our eyes do.
Hey, you wanted an answer. You asked how flat earthers explain this, and you've been given an explanation. Why are you telling them that they're wrong? Are you a flat earther? Okay, so you explain it on a flat earth thing.
I explain if it's a flat earth? What?
No. Yeah. You asked a flat earther how they explain that. How is it that that's happening, right?
Yeah.
And you were told, and you're saying no, that's wrong. So you tell us the flat earth explanation then.
No, I'm not saying it's wrong. It's what,
okay. So it's been explained then.
Okay, so you just want to not talk and just say okay, or what?
No. You asked how does a flat earther explain it? How is it explained on a flat earth? And it's been explained. All right?
And we're discussing it.
Okay. So you can't tell a flat earther that their explanation's wrong.
I didn't.
You'd have to. No, listen, bro. You'd have to contest that the Earth is actually flat, that it's actually a globe, or whatever other position you hold about the nature of the surface.
Yeah,
that's where you'd have to go after that. So not to tell them that they're wrong about the stars and how perspective works. Okay.
I didn't say it was wrong.
Okay, well you did. You challenged it. You said no, that's incorrect.
No, it was Morez.
Well, okay, whoever it was, right?
Yeah, T-Dub, sorry, there's two of them. There's Blue up the top, and there's Morez, who's now got his earplug. Probably got a phone call or something.
All right, so you've got your explanation, right? Okay, so let's move on. Like, what is there? Do you want to talk more about that in particular, or do you want to move on to another point?
It's up to you.
Considering that I've been on for more than 10 hours straight, I'm going to let you ask the question, Blue. I'm more than comfortable with whatever you can throw at me.
No, it's fine. We're I don't know what you're saying for is a fact or no. You just showed me the picture and I see, yes, it appears to meet the ground, but
excellent. So what was the original claim? What did he originally say? He asked why we only see the stars in particular spots. For example, in the north, they see the North Star or Polaris. In the south, we only see Southern Cross.
Okay.
The reason for it is see what is happening in that picture there, how everything converges to the middle. The same thing happens to the stars. They converge down on the horizon. Now, once they hit that convergence point, the horizon, we can't see them because they are at too low an angle, too sharp an angle to see. That's all that's happening.
Why we see a totally different set of stars that are very clearly visible but just distinctly different?
The same reason.
Okay,
What is
wait,
that
wait. Before
Are
we
there
move
different
to-
distances? You're saying?
I never mentioned different distances.
No, before we move, just on the picture. If the poles in the picture were higher.
The picture is just an example. If
Yeah.
the stars would be at a higher elevation, but they still come down to that convergence point, known as the horizon. That's it.
Yeah, but
you guys believe the horizon is the curvature of Earth, in which case you would have to prove the curvature. All we're saying is the horizon is the optical limit where the sky appears to meet the ground. For your eyes, it might be 1 mile. For my eyes, it might be 2 miles. Everyone's eyes are different, okay? When you pick up a camera or a telescope, it has a different optical range, and that horizon would be further. Now, if you think about it, if it's a ball, you can't see around the curvature just because you picked up a telescope. Can you?
Okay. Can I ask the question now?
You can ask a question, yes. Go for it.
If the poles were higher, like what would we see? It will take longer for them to meet the ground, right?
Same effect.
Yeah. They will meet eventually, but it will take longer.
No. Same effect. They would meet at the same point.
At the same point? Even a higher pole?
They would just appear to ramp downwards at a faster rate, at a steeper angle.
If the star is directly above you, to which point on the horizon would it vanish? In front of you, behind you, to your right, to your left?
If the star is... I don't know why you're still hung up on stars. I've made it quite clear earlier on.
Bro. You just
apologies
wanna,
to these... Apologies to these
you want to say, okay, you're right, and end it and move to another?
Don't prove the shape of the ground.
Bro, you're just, okay, we're discussing it. If you just want to say, okay, you're right, we can move, no problem.
Well, yeah, I mean, not even...
It doesn't help us in any way to just sit and listen and do nothing.
Yeah, well, not even the star positions are any evidence that the ground is curving.
No, we're saying if it's like in the picture, the poles were meeting the ground. If they were taller poles, they would take longer to meet the ground.
They would still meet the ground. Still
yes,
the same.
But it will take longer distance.
No, wrong. Same distance. The reason for this is because the pole, how fat the pole is, as you can see, it disappears. It would still converge at your personal optical limit. That's where it converges. Every person has their own personal optical limit. A camera, a telescope, binoculars, all have their own optical limitation.
No, it's not
that photograph
point. It's not the point
shows the limitation. It is the point. Wait for it. That camera, that photograph shows the limitation of that camera. Now, if you have taller poles, all that would happen is they would appear to run down at a faster rate. They would still exist. They would still disappear at the horizon line. That is all that happens.
Okay, we take thicker and taller poles. It's still the same?
Still the same. They will disappear at the horizon line.
And what is this like?
Unless you've got something exceptionally large, like a mountain, which still follows the laws of perspective. The problem is your angle of resolution, so your ability to resolve clearly what is in front of the mountain. You will see the outline. You will see a white cap on top where there's snow, but you won't be able to clearly distinguish the line where the snow appears to touch the dirt.
Okay,
it will just be a white blur versus a brown blur. So it's to do with your optical limits. That's all that's happening
but are you saying,
in
are you
all
saying
the cases.
The mountain will disappear at the same distance as the pole?
I'm going to try and repeat it one more time. And seriously, guys.
No, it's a yes or no.
It is to do
yes or no.
with your optical limitation.
If you're not going to let me speak, there is no point in this.
If you're not going to listen, there's no point in this. It's to do
I'm just
with your
asking a yes or no question.
It is to do with your optical limitation.
Okay, a
Is
yes
the
or no
answer
question.
to your question. Try asking the question in a different way.
If it's a pole and a mountain, they will both disappear at the same distance?
No, they will not.
Okay, good. So the height and the thickness will make a difference. Or how large it is will make a difference.
How large the item is will make a difference. But what you've got to look at, you're instantly going to assume something different. It is to do with the limitation of the optic. Actually, I'll post a picture. Hold on. I'll show you something. Where is it? Here we go.
Sure.
Here we go. Here we go. This will make it better for you. This will show you how perspective works. Okay. There is a 6-foot guy. There is a 6-inch guy. And there is a 6,000-foot mountain in the background. See how they're all different sizes?
Yeah.
Based on the range or distance to those items? That's what happens. That's how perspective can play with things. Excellent. Okay. I'm hoping that fixes it up for you.
No, we're saying if the pole and the mountain are the same distance, which one will be closer or get closer to the ground first? The pole.
If the mountain and the pole are at the same distance, you would not see the pole.
Exactly.
It would disappear first. Why does it disappear first?
No, but I will still see the mountain, right?
No. Why does the pole disappear first?
Why does the pole? Because it's far away.
And it's
we know.
And it's what?
And it's smaller than the mountain.
There you go. Yeah. So the angular resolution limit of the human eye is about 0.2 degrees. So anything, right, that reaches that angular size, right, in your perspective, will begin to become unresolvable, and and depending on the object's actual size, well, that will vary with distance, then, won't it?
Yeah, I'm not disagreeing with that. I'm just saying that the larger the object, or we can pick from the north and the south an object that large or an object that bright, or in between both of us, and it shouldn't disappear from this side or this side.
So based on angular size, what object are you going to be looking at that's near my house that you can see from your house?
No, not necessarily on Earth. That's going back to the star point.
There is no point with the stars. Your stars are equal to the telegraph poles. They are very small. They disappear into the horizon as they get further and further away. That is it. That's why I cannot see Polaris. That's why you cannot see the Southern Cross.
How far away do you think the stars are?
I don't make a claim to their measurements.
Do you have maybe a guess based on your personal experience?
About that far.
It's unknown.
Maybe a bit further.
It's unknown what they even are, man, and what sort of medium they exist within. But we know that in our field of view, things with elevation will appear to come down with increased distance.
Would you say that the distance of the stars from the Earth are on the same length scale as the Earth itself?
Don't know.
It's kind of hard to say them, because the angular resolution is not... If they're very far away, then the angular resolution will not change much.
I don't know if they're even a physical object in order to be able to determine that they have like an angular size. Like, I mean, you can zoom in on them with a telescope and you can kind of get an angular size of the light that's being emitted, or, you know, that you're seeing. Like, but you don't know if that's like the surface of an object or if it's glare, you know, like you don't know. Like, so you're just seeing an apparent size, an apparent angular size at that of a light. I mean, you're not going to be able to gauge anything from that, really. You'd have to know what's producing the light, how big it is, how far away it is, and all those unknowns.
Would you say that the vanishing point effect of the stars disappearing over the horizon is because the star is physically distancing itself from Earth, or just from individual observers on the planet?
I don't know, man.
Yes, I think the whole argument depends on what kind of model we even have about the stars. Otherwise, it doesn't really make sense to talk about
Well, your whole argument would stem from what shape the ground is. So here we are, we've measured the ground as flat, and we don't care what the stars are doing. You're assuming it's a ball, and you have a model that goes with it. So with the stars, there's a thing called your sphere of vision. And I absolutely hate this term because, number one, it's a hemisphere. And number two, as soon as you say the word sphere around anyone that's trying to prove a globe, they instantly think that it's some kind of gotcha moment. And it is exceptionally infuriating just to use the term, because even you took a hard breath when I said it, because we could hear you. But anyways, there's a thing called the sphere of vision. Do you know what a planetarium is?
Yeah, of course.
Excellent. I want you to go to a planetarium because the planetarium is your sphere of vision. That's how it works. You stand in the middle, and as you look around, that's how your optics see things. In reality, what is happening is, due to perspective, the stars are lowering down to the horizon. What people think is it's based on a sphere. It is not. But anyways, that's the basics of it.
Well, you're arguing this. In order for the star to lower down to the horizon in the perspective, it must be going further away from us. So my point is,
that's correct.
How is it moving relative to the Earth?
You're getting further away.
So how far away is the star from us? How is it moving? That's kind of the question I had.
We went through that. We don't know.
It must be very close, no? In order for it to be dramatic perspective.
Well, maybe they're not as far away as what the so-called scientists proclaim. They are actually treated in celestial navigation as infinitely distant, which is very odd. I don't know why.
Well, the distance is so great that an infinite approximation is accurate.
Excellent. So how far away are they?
Depends. Thousands to millions to billions of light years. On which star?
And how do you validate that? So how do you validate that? Science tells us that these stars are thousands of light years away, hundreds of light years.
You look at the redshift.
As you and me, how do we validate that? Redshift is to do with electromagnetic interference.
It's to do with the distance at which an object emitting radiation is traveling away from us.
But yet, radio signals can interfere with redshift, blueshift. So, how do you validate this redshift, blueshift now knowing that there's other interferences?
Well, you would just take multiple measurements and then the background noise would
You can't. That's the problem.
Yes, you can. Of course you can.
There's other effects that interfere with these measurements. And it is based on an assumption.
You can assume a radio background
the only way to measure something, lad, the only way to measure something is by direct measurement. If you claim that you've got a measurement to something via any other method, you are fooling yourself. For example, I can look at my computer table and I can go, that's roughly 5 foot across. Or I can measure it and go, oh wow, it's 4'8". It's measured at 4'8".
What are you trying to say?
How do you measure the distance to the stars?
By using the Doppler effect, you can correlate the redshift to the velocity at which the object is traveling, and making an assumption that all objects started traveling from a singular point during the Big Bang.
Stop! Please stop! You said make an assumption. We're not assuming. We're doing direct measurements. There's no assume in direct measurements.
You're assuming your tape measure is correct.
That is an instant fail.
You're assuming your eyes work.
You're assuming that stars are closer to us, so the Earth is flat. There is many assumptions.
I'm not Blue. I'm not assuming the Earth is flat because the stars are closer. I'm knowing the Earth is flat because it's measured as such.
No, but we're saying when we're looking at the stars.
Don't say no. Do not say no. When someone says they've measured something, you don't say no.
Okay,
you ask them how it was measured, where it was measured, when it was measured. You don't just go, no, stars, therefore I'm correct. Nah, I'm not going to play that game. I've been on someone
Okay, how did you measure it? I didn't say no, I was correct, but how did you measure it? Let's go your way.
We use lasers to measure it.
How did you do it?
You get a laser, you point it across a large body of water. Actually, I'm going to post a video for you so I don't have to talk. Stand by.
Sure. And you did the same thing the video did, or what? Did you do the same as the video matrix, or did you just believe the video?
What do you think?
I'm just asking because he's saying we are believing the scientists. We should do it as well. Did you do it, Matrix?
Scientists don't do anything to do with shapes. I don't know why you guys keep referring back to scientists.
Did you do the experiment in the video?
It doesn't matter because I've done other experiments. I've done other observations and I've done other work involving the sun, taking light measurements from the sun so I can calculate its distance. See, again, calculate, not measure, because you can't measure directly.
Yeah, but to calculate, you need a formula. And the formula you're taking from someone who made it, and you didn't...
Yeah, okay, stop. You need a formula. Go and look up how the inverse square law of light works. You then apply the given distance of 93 million miles. You then apply your given energy levels that you take a reading on. And then when you come to the realization that the inverse square law does not allow for 93 million miles, you then have to go, oh my God, we've been lied to because the numbers don't match up. Exactly. That means a lot. But that's another story. Lad, stop talking. Blue, for your convenience, in the side chat, there's a laser test. 21 miles over a flat surface. No, but
if you didn't do it, there is no point for me.
I didn't say no. What? Okay, so because you're not a scientist, I now don't have to listen to anything you say. Because science does not deal with shapes. Logic? Blue, by your logic, because I didn't do this one particular thing, you're going to dismiss everything. Now, because you've done nothing, I'm going to dismiss all your words.
I didn't say
so where do we draw the line?
Words in my mouth.
You just said you're going to dismiss this because I didn't do this.
This, not everything.
Okay, I'll get another test for you. That's easy.
Yes.
That's only one. So why does it have to be a test I personally did?
Because when we said we saw
hang on a minute. Stop.
Okay.
If you're going to dismiss every single thing because I have not done it, I am going to dismiss every single thing that you have not done.
Yeah.
So, number one, you have not proven gravity, you have not proven curvature, you have not proven the distance to the sun, the moon, the stars. You have not even proven that you can or cannot see Polaris in your house. You have not proven that you can or cannot see the Southern Cross from your house. So your words now mean nothing until you can prove you've done something by your logic.
Yeah.
Or we can have a look at some of the stuff and go, oh wow, I can validate this. So some of the things you would be able to test for yourself. Some of the things you may not. You may not have a $40,000 laser in order to go and do some of these tests. I agree with you, because I don't either. This is why you get these videos and you scrutinise them. You go through them. You see what is correct, what is incorrect.
How do you figure out?
We can both do this together.
Incorrect?
Well, you can do the measurements yourself. If I get a laser and I point it across the ground, and this is Lad talking again when he shouldn't be. If I get a laser and I point it horizontal, and at the start of the laser it is 1 foot, and we shoot at 28.6 miles, or in this case, 21 miles. How far should the drop over distance be at the other end at 21 miles?
I have no idea.
How about we grab an Earth curve calculator and we'll look it up? Let's go together. Earth curve calculator. Okay, target distance 21 miles. Says that in the video. Excellent. Eye height. Did you watch the video yet, or are you still complaining about it? You haven't watched it yet? Have you watched it yet? No?
I'm listening to you. How can I watch the video?
How high was the camera in the video?
No idea.
Don't know?
I didn't see it.
Oh, that's a shame. Well, I'm going to say 5 foot high, just because I know that's above what they did it. So, at 5 foot high, your target height should be 32 feet. So, this is how simple it is. When you get to the opposite end, you have a look and see if you can see the laser. If you can't see the laser, it's probably because it's hiding behind said curvature. If you can see the laser, you should question why, because it's supposed to be hidden behind 32 feet of curvature. That's how simple it is. There's nothing complex to do. All you have to do is go, how high is the observation? How far is the observation? And even you can go out and take your camera with you and just go out into the real world. Take a photo of long distance ships out at sea. Take photos of them. And then ask yourself, how far is it to the ship? If you see the horizon behind the ship, you could probably get onto a GPS tracker and track where the ships are. And so you can go, well, I'm at this point. The ship is here. That is X amount of miles. My elevation, because I'm standing on a cliff, is 30 feet, 40 feet. The ship is at 30 miles. The horizon is behind the ship. Is this possible? That's how easy it is. You don't have to go far out of your way to do basic observations and basic tests to see if the numbers we're given are true and correct. Myself personally, I have issues with people that allegedly live in the Northern Hemisphere telling me that the sun's or Earth's orbit is an elliptical around the sun. And at its closest point to the sun, it is wintertime. At its farthest point from the sun, it's summertime. I personally think that is retarded, because the last time I went near a heat source, the closer I got, the hotter I got. So I purchased a light meter to go and test what these readings are. If you are really lazy and you don't want to purchase a light meter, or you can't afford to, that's great. Look up your local observatory and they collect a lot of this data for you. So you don't even have to buy a light meter. All you now have to do is look up how the inverse square law works. So as light travels, it dissipates. Double the distance, 1/4 of the energy. Double the distance, 1/4 of the energy. Again. That's it. So in order for our energy levels to drop down to 1/4, we have to, in effect, move double the distance. Now, when we have a look at the Earth's alleged rotation of 3959 miles, that's how much closer we will move. So when it's nighttime and it's just about to be daylight, up to lunchtime, we rotate, allegedly, 3959 miles closer to the sun. That is 0.005 of 1%. In order for the numbers for the sun to ring true, we would have to be moving multiple millions of miles closer to the sun in order for the energy levels to be true and correct when you graph out or plot out the data sets. So, that's what I have done. Something of note, allegedly the sun is 93 million miles away, but if I change that number anywhere between 2,500 miles and 5,000 miles, the inverse square law works a lot better, given the readings that I've done. So there you go.
Anybody else? Next. We moving on, or any
Sorry,
response to what Matrix said?
No, I'm not saying sorry I want to talk. I'm just sorry for rambling on so long.
Yeah, it's like I've got an issue with flat earthers saying that I see the sun in summer. I see the sun rise in the northeast and set in the northwest when I don't, or that I see the southern celestial axis of rotation sweep across the sky towards the west. Like I just don't. It never happens.
Yesterday there was a discussion around the North Pole location and the flat Earth where the South Pole and North Pole are located. So I just want to continue if someone can explain here. Because Jedi has explained something like the celestial points, and I asked him 2 times like to explain it clearly, and he was still, I don't know what he was explaining. If someone can explain it here.
Yeah, I'm not quite sure what you're asking exactly. Sorry, Agni.
Okay, so the question, the thing we were discussing yesterday was the North Pole's location, South Pole's location. Like there are 6-month winter at one place and 6-month summer at another place, and everybody, I don't know, I use the word claimed that North Pole is in the center of the Earth. So then South Pole also have to be at the center. So they are.
No. Neither have to be the center of anything, except a rotation above.
You have a differing claim. Like they said, I guess
to
Jedi
who?
and Jin.
To who? To who? No, Jedi never said that was the center.
Oh, you were present, right? Yesterday. You were present.
Yeah, no, Jedi never said that.
Okay, he was saying that he did not say that North Pole is in the center.
No, Jedi never said that. No.
Okay. So where is it?
You mean it's in the sky? And there's a
let's
location
not
on Earth
talk about the
underneath that.
location. We can come to the location. Like, first of all, if the Earth is flat, so we will assume that, like a open book. Let's assume an open book. You have problem with that? Like the open book? Like for imagining.
No, I'm not imagining anything.
No, I mean you have to imagine because there has to be
No, I don't.
n. Sorry.
No, I don't. I don't have to imagine
So
anything.
you're saying there is no end.
No, I'm not saying that either.
No, but there has to be end.
Yeah. Okay.
Yeah, so there has to be a periphery, right? You agree to this or not?
A what? A what?
A periphery. Boundary.
A periphery?
Periphery. Yeah.
All right, a boundary. Well, yeah. Yes, we're in a closed system. Yeah, there would be a limitation to the extent you could travel horizontally across the surface, but where that is and what shape it forms ultimately, I do not know and don't make a claim
No,
about.
I got that. I got that. You have not seen what shape it has formed or where exactly the boundary is, but logically speaking, like taking our extending our thoughts, there has to be a boundary, right? And like a periphery or a boundary. So we can assume an open book. Is it okay?
No.
No, I know it looks like a square or rectangle, but I'm not talking about the exact shape. Just imagining. Like what else it can be then, if you're saying no?
Say cloud shape.
Flat shape?
A cloud.
Yeah, the book
cloud shaped. Cloud shaped.
Cloud shape.
Yeah.
Yeah, but the cloud has a flat surface, right?
No, I'm just saying as in its 2D aspect. So
Okay, yeah, I don't have any problem. Yeah, that's what I said.
Yeah,
there is
asymmetrical, like irregular, right? It doesn't have to be symmetrical.
No, I got it. That's what I was saying. I'm not talking about the exact what we say, the symmetry. I'm just taking a rectangle or a square.
Yeah, there's a large extent of a plane, right? And I don't know the shape of it.
No, I got you. There can be any possibility of shape. But the thing I was asking, so now can you explain me, like, if it is unsymmetrical, whatever, how the sun, like what happens? Where is the North Pole and where is the South Pole, and how exactly the 6-month things happen?
Well, this was what Jedi was trying to ask you about when he said, "What is the North Pole, and how do I know when I've got there?"
How do I know? Like we have a map, right? And the 2D map or the
So
globe
what
model.
do you define as North Pole? How would you know when you got there?
It's just a word, North Pole.
Is there a red and white candy cane sticking out of the ground and a sign that says North Pole? How do you know you're there?
Now, let's say you don't have a map.
No, but we have a map, so we'll talk according to that.
You don't have a map. Let's you want to go with hypotheticals? Let's hypothetically imagine that you don't have a map, but you want to get to the North Pole. How are you going to get there?
You can use compass in simple terms.
Well, that would be magnetic north, which differs to geographic north.
Okay, the geography. Okay, that I got. Yeah, but I mean there is a way to. Yeah, so then just go opposite. Like you want to go to the geographic north, right? Hello?
Yeah, you want to go to geographic north. So, and you don't have a map. How are you going to get there? What are you going to reference to be able to say, I'm heading in the right direction?
No, so then just go opposite to the magnetic north.
No.
Why no? Because
opposite. No, that'd be going south.
No, that is magnetic north, right? Opposite to the magnetic north.
Would take you south. That would take you towards magnetic south.
Wait, the magnetic north, where we point the magnetic north, that is... Okay, so, no, where we point the magnetic north, that is geographic south, right?
Technically speaking, that's what that is claimed, but we're just talking about...
Claimed, like, it's the magnetic... Earth's magnetism.
Yeah, I understand. I understand, right? But they don't call it that, right? They say that magnetic north, even though it's really magnetic south, right, is in Siberia or somewhere like that, like heading towards Canada or something like that, or Alaska. Like it's offset from geographic north, right? We're just talking about the place where the compass needle that says N on it points to, right?
Yeah,
that's offset from geographic north. Geographic north and the place that your compass points to are not the same thing, right? But you want to get to geographic north, so don't worry about your compass because that's not going to take you there.
Yeah, I got that. But but if you go to opposite, like just simply because
that would take you south.
No. Because it describes the opposite direction. Like the magnetic north is the geographic south, and the magnetic south.
No. We're talking about the place. You're comparing that with the magnetic field, right? We're just talking about what your compass says, right? Which is the N, the little arrow that points north, right? Is offset from geographic north by I don't know how many hundreds of miles or kilometers, right? But they're not the same location, but they're in the same general region within the Arctic Circle, right? They're not opposite one another. They're not opposite one another.
No, they're not exactly opposite, of course, because
so they're not even closely opposite to one another.
No, they are closely opposite. What I remember.
No, they're not. No, they're not. No, they're not. No, you're incorrect, sir.
Yeah, okay, that's what I'm checking.
They're in the same region, the Arctic Circle. And they say that magnetic north is moving, like, I don't know, 6 inches a year or something like that. I can't remember how fast it's moving, they claim.
Which north is moving?
Magnetic north. Even though technically they say it's magnetic south, right? Because polar opposites attract. So they say that your compass needle saying north is actually pointing towards magnetic south. But we don't need to complicate things like that at the moment. We're just going to call it magnetic north because that's the way the compass is pointing, right?
Yeah,
so you want to go to the
pointing.
So you don't want to go to the magnetic North Pole. You want to go to the geographic North Pole. If you want to go to the magnetic North Pole, you just follow your compass and you'd end up somewhere in Siberia. Okay? You don't want to go there. You want to go to the geographic North Pole.
Okay, let's not fight in this. Because there will be some adjustment or manipulation where you can go to the geographic North Pole. Of course, it's not exactly the magnetic North Pole, but you can, right?
No, they're quite a distance away from one another. You just want to go to the geographic North Pole. So how are you going to get there?
Can you give me the number? What is quite a distance away?
Well, it's just a Google search away. Hang on.
Yeah, I'm also searching.
Okay. They're not in the same location and their distance varies over time and by location. The magnetic North Pole is currently located in the Arctic, like I said, in the Arctic Circle, roughly 400 kilometers or 250 miles south of the geographic North Pole, right? However, the magnetic North Pole is constantly shifting, like I said, and its distance from the geographic North Pole can vary, okay?
Yeah, it is shifting more faster than 6 months.
The distance between the two, the USGS also says that the distance between the two can be as much as 1,000 kilometers. But anyway, look, they're in the same region, all right? So, but let's say you don't have a compass or a map. You want to get to geographic North Pole. How are you going to try and get there? What's going to indicate to you that you're heading in the right direction towards geographic North?
Why are you eliminating all the options? Like, they are made to take us to the desired position.
Because you're missing what's relevant to geographic North.
No, because it's the exact. Because what we imagine that Earth is a sphere. So according to that, the geographic North and South.
No.
According
Do
to
you want me to just tell you? You want me to just tell you?
What?
Okay, the way you would head towards geographic North Pole is by following the North Star, Polaris. That would get you pretty close. If you could get to a position where you can crank your neck back and look straight up in the air, right above you, you can see Polaris, I'd say you're damn close to the North Pole.
Okay, but the reason why I asked, I mean, we were away from that the topic of discussion. Now we are. I don't know why you asked me to. If there is a way to go to North Pole, because I was asking something else.
Right. So the same for the South. How would you know when you got to the South Pole?
I don't know. You tell me.
Well, you'd look directly above your head and you'd see a center point of rotation of stars.
Okay. Yeah, so what? That's what I'm asking.
That's what we're told anyway. I haven't experienced it for myself. Maybe one day I could get to go to Antarctica and someone could guide me to that point where at night, it's nighttime in Antarctica, and I could look directly above my head. And I could watch the stars and watch the stars. No. Like right at the point where I could be right underneath the center point of celestial rotation where the stars rotate above my head.
Yeah. No, see, the point why I asked this, because in the flat Earth, how will you explain like how the 6 month thing
It's not our job to explain phenomena
I don't.
on our
like how the sun behaves. Because
Okay,
what
the sun. Okay, I'm going to do it. The sun follows a circuit.
Wait. Listen.
You wanted to
gonna
know
explain it?
how come there's 6
Oh my
months
God.
hot, 6 months cold. I'm explaining that. The sun
But wait,
follows
listen.
a circuit.
Oh my God.
Well, you
'Cause
wanted to know.
No, because T-Dub and I was discussing, so let me just give you
Okay,
one scenario.
stop for a
because
second.
I'm holding.
If you were discussing this with
Oh my
Jedi, maybe perhaps you should continue this discussion with Jedi
No,
when he
with
returns.
T-Dub. No, I was just holding the book. Now I'll just explain because I'm imagining a book as a flat surface or a
I don't know
cloud,
why.
like T-Dub said. What?
Why the necessity to imagine a book as a flat surface? We all know what a flat surface is. What are you
No,
not sure
'cause-
of?
No, I'll just imagine
What
like how
are
the
you
sun.
not sure of, please?
No, I'm saying that I'll just imagine how the sun goes above the book or the flat surface or the flat cloud. What T-Dub said.
Excellent. So, your question before was about why is it summertime for 6
Yeah, the
months?
whole
Or
question
daylight
was
for
the
6
day,
months?
night, summer, 6 months, everything. The whole question is like the behavior of the sun.
Excellent.
How does
The sun follows a circuit. In
a
this
what?
circuit, a path. The sun
Okay.
follows a path. And what happens is, every single day, that path modifies a tiny little bit. When it's at the summer solstice, it's at the end of one part of the path. At the winter solstice, it's the opposite end. So the path changes slightly throughout the year. Okay? So at the summer solstice, that's when the sun is furthest away from you in the quote unquote northern hemisphere. Also known as. Well, actually, it's the other way
Oh my
around.
God.
Summer solstice,
You're just
it's the
explaining
closest.
the global.
Winter solstice is the furthest. In the globe
Why are you
paradigm, you believe that we are a sphere spinning in front of the sun. And it is the tilt effect as per the elliptical orbit in front of the sun causing these seasons, also known as summer and winter. Now, in reality, we're not moving. The sun moves. The sun follows a circuit. When it's at its closest point to you, it's daytime. It's also summertime, depending on how far through its circuit is. So at summer solstice, it's summertime, closest to you. Winter solstice means furthest from you, winter time. Now, where I live, it is the opposite. When it's away from you, it's close to me. The same thing happens at nighttime versus daytime. When the sun's above my head, it's 12 noon. When it moves further along its path, it's 12 noon at somebody else's. Maybe in the middle of the Pacific. Maybe in the middle of the Indian. I don't know. I have not had the privilege of chasing it along. All I know is tomorrow morning
Oh my
the
God.
sun will reappear at the
Patrick,
start of
I'm
its path.
sorry to interrupt.
No, listen, Agni. It's fine. It's fine. Listen. No, listen.
No
The
problem.
short
I'll ask
answer.
it to Jedi because I did not understand because he just used. I mean, no offense. Maybe he's good at some other. Because he just I don't know what he explained because he just said
It's
it is
fine. It's
above my
fine.
head.
What you're asking
That's all
for,
right.
we can't give you. Okay, we don't have the bird's eye or God's eye perspective to be able to tell you exactly what the sun looks like it's doing over the flat Earth. All we can do, anyone can do, is describe what they see the sun doing during the daytime, right? From any given point on the ground or from above the surface at like in an airplane or something, right? But that's going to change because they're moving. I mean, but that's all we can do. We cannot give you a third person perspective, some other perspective that we can't achieve. We can't do that. We can't give that to you. We can just describe what it looks, what it seems to be doing from any given point on the surface. That's all anybody can do. So you could describe what you see it doing, and I could describe what I see it doing. We can't.
We can achieve, and it is already achieved, but you don't agree to that. That will not make any difference.
No, we can't give you what that means it would look like if we were a long way away, or if we were a god or something. We can't do that.
No, because the reason why I asked this, because it is literally confusing in flat Earth, because the movement of sun, because if you see the sunset at the same time and at a different place, maybe 2 or 3 hours. So how big is the sun? So there are so many questions around it. Like if Earth is flat,
guess
then
what?
it has to be.
Agni, guess
Join
what?
the club, man.
We have also got a lot of questions. Feel free to join the club of questions unanswered. That is why I had that long spiel earlier about me doing light measurement and readings. That's what that's about. Me, myself, trying to answer some of these questions. So you are more than welcome to join the queue. Take a number, put your feet up, grab some popcorn, and enjoy the show.
Okay, yeah, no problem, man.
I'm not saying you don't have to ask more questions. Please ask questions. But you must accept that some of the answers we cannot give you because we have not done this. You will find a lot of the flat earthers, especially some of the really, really good ones, will say, I don't know, if they don't know the answer to a question. And the reason they say that, they don't want to mislead you. They only want to give you data that can be verified. So if a flat earther says, I don't know, that means they might have a crazy theory or some random idea, but they are saying that because they don't want to mislead you with incorrect data.
And you were used to having like an explanation, right? So you were given these images, cartoons, like these diagrams and things of the Earth and its position in the solar system and how it's moving around the sun and how that explains this and that you see, right? The problem is we could do the same thing for flat Earth, but we wouldn't be able to prove it. We can prove that the Earth is flat, but we can't prove anything about the things in the sky from a perspective that we don't have, just like the globe presents those images to you, those cartoons and those models and everything, those visualizations. They can't prove any of that. They especially cannot prove that the Earth is curving. So we know that those models and those cartoons, they're incorrect. They're not an accurate representation of reality. You are not on a sphere, you are not spinning, and you are not going around the sun.
Yeah, I got you. That's okay if right now the flat earthers cannot explain. So that's why I'll stick to the globe Earth only, because whatever they have told, maybe that's a lie or whatever. But that is so true, because the how the heliocentric model, I guess, how the Earth rotates and the North Pole and how everything happens, the summer and the winter in an elliptical orbit, semi-major axis, and
it's all
minor
wrong.
axis.
It's all wrong.
No, the equinox. No, it is explained correctly. That's why.
No, it's incorrect. No, it doesn't explain it because it's wrong. It's incorrect. It doesn't explain it.
The reason it's incorrect, Agni, is because in order for all of this to be true, you have to prove you live on a ball, on a sphere. Now, the issue is there's been multiple people done measurements of the ground and there's no curvature. We live on a planar realm, a planar place, a zone. I don't know what you want to claim it as, but it is planar in nature with topography. So if it is planar, it is not curved. It is not curved, it is not a ball. So we know that all these claims of stars and seasons and daylight and daytime are caused by a ball. This is false, fallacious. It is not true because the ground is measured as flat, planar, horizontal.
And
And I got
explanations are not
you.
proof.
It is for you, like you as a, you believe or you proved whatever you did, and you think Earth is flat. That's why you're saying it is not possible. But because I believe what satellites images and what they have shown.
Well, that's your
it is like
problem.
what I believe.
Well, that's your
Yeah,
problem.
that's what I'm
That's your problem. That's your problem. You believe, right?
No, I don't
And it's
believe.
okay. Yes,
Scientists
you do.
have
Yes,
proven.
you
So,
just no, you
yeah.
no, you just said it. You believe. No, you believe scientists have proven it. You believe it. You
No,
can't
scientists
prove it
have
for
proven it.
yourself. No, you believe they have.
I don't have to prove everything on myself.
No, yes, you do. You have to. You can't rely on their perspective. All right. You don't have that perspective. That's someone else claiming to have that perspective, and you cannot verify that perspective to be true. Okay. You don't have that vantage point, and you never will. And as Matrix pointed out, they are not telling you the truth because the Earth measures to be flat. And explanations are not evidence.
No, it's not explanation. It's completely what satellites and what they have proven.
That's a belief. You said it yourself. I believe.
No, maybe the word I used. Sorry for using that word. I would
Okay, so
change
how
that
do you know? How do you know that?
How do you know?
Yeah, how do you know? How is it knowledge for you that there's satellites in space taking pictures of Earth and measuring Earth?
Okay, if how to know something is a ball if it's a big ball, if you are standing on it, of course you cannot know.
No. Remember, you're relying on satellites in space.
Yeah, I'm going to that point. Just wait. So that's what I'm saying. How could you? Yeah, let me just continue. How could you know if you're just standing that point? So for me to know if something is a big ball or sphere, whatever, I have to go far away and look at that ball and consider its motion. So that's how I will know. And if it has some spots on that ball, that spots, if they're changing position time to time,
So
that
when
means
did you do
something is
that?
rotating.
Okay, so
I
when
did
did you
not.
do that?
Yeah,
Okay,
NASA.
that's what I'm asking. So how do you
NASA,
know
ISRO.
that? How do you know that?
Yeah, because the NASA, ISRO, and Himawari satellite and
How
everything.
do you know? How do you know this? How is it knowledge for you that there's satellites in space taking pictures of Earth?
Satellites of space?
Yes. How do you know?
Yeah.
How is it not a belief? How is it not a belief?
If the satellite has taken the picture, how is it a belief? It is something done. It is something happened.
Yeah, that's the claim. Someone showed you a picture, right, and said this was taken from a satellite way out in outer space, and that's the Earth, right? How is that knowledge for you?
I can ask the same thing to you. Like, if you have not, if you have not gone to France, so how do you believe? Someone have said that France exists. So how do you believe that France exists? Have you gone?
Yeah, okay. I believe France exists. I haven't verified it for myself. Okay.
France
Are
does
you
not
conceding?
exist.
Are you conceding that it's just a belief for you then?
No, so you're saying France does not exist, right?
No, I'm not saying that. I'm saying I believe it exists. Are you saying that you believe those satellites took pictures of Earth?
No, but I'm saying that it is proof that France exists. So why you believe that?
Because I haven't been there for myself. I just trust what I'm told about it.
Okay, okay. Then if you're using that kind of word and situation, then okay, I'll say it. then I believe.
Right. Okay, it's not knowledge. Someone else claims it's knowledge for them, but it's not for you. You can't borrow their knowledge. You don't know if they're telling you the truth. You don't know it as a fact. You believe. Someone showed you a picture, a pretty picture, with a black background and a big coloured ball on it, and said, "That's Earth." From far away,
Black background,
and
no.
you choose to believe it because you cannot find that to be true.
Yeah, but I'll still stick to it, no problem.
Yeah, okay, that's a belief. You are welcome to your beliefs. You are welcome to your beliefs.
Okay. I just told you because if you're standing on a very big ball or flat plane, whatever, you cannot know the shape on the ground just by checking curvature.
Why
because
not?
It can be illusion
Why
or it.
Why
no,
not?
because everywhere because it has not proved every point
then
on the
how do you
Earth.
know that? How do you know that going far away from it isn't also going to produce an illusion?
Yes, so if you consider that, then everything is an illusion, so nothing is true. So we can
No,
come to this
you're the one. You're the one talking about things being an illusion, right? So you won't accept what it looks like from up close, but you're going to accept what it looks like from far away. Why?
Yes, if we accept both, so there has to be a third way to, because if both are contradicting, so I don't know which one to accept then. What do you say on this?
Don't you think it could be measured?
Don't you think it could be measured? But don't you think it could be seen from a satellite?
From very far away? No, I don't think I can get far enough away from Earth to see it like that.
Oh my god. But I think so, and it is done, so I won't.
Okay, Agni, how do you validate that the satellites are true and correct? How do you know that that image you've been given is true and correct?
I know you will tell the stacking, whatever, like how they project it into some coordinate system or something. Are you talking about that?
I'm talking about your claim of the satellite images of Earth. How do you know that they are true and correct? And why I ask that is because if I make a claim of a purple tree with pink polka dots in my backyard, most people would say, you are false, you are a liar. And then I would show them a photograph of a purple tree with pink polka dots. And they would say, that is CGI, that is manufactured. And then I would say, come around to my house and stand in front of it and see for yourself. Now, let's use that in space. How do we validate that the images are true and correct?
How do we? Because they are given from the satellite.
How do
like
you
how
prove? Yeah, how would you prove that they are correct? If I say to you, these images are not correct, how would you prove to me they are correct? We can't go there. If we could go there, that would be awesome. We could both go up there and look down and say, you know what, that photo is true and correct. I've been to where they're taken from. Now, we all know that you and me can't go there. So how are you going to now validate, verify, or prove that those photos are true and correct?
We can go there, by the way. We have gone to moon.
No, you can't.
Don't accept.
You can't go there. I can assure you now, you can't go there, and you never will.
Oh, are you specifically asking
So
me?
how are you going to prove to me that the photographs that are taken from space of Earth are true and correct? How are you going to do that?
No, I mean, it is already proven by many scientists.
No. It's been proven to you. It's been proven to you. You're the believer. I'm a non-believer. I want to believe. How are you going to prove to me that their photos are true and correct? They could be CGI. I want validation, verification. I want proof that those photos are, in fact, taken from that position. How are you, Agni, going to do that for me so I can become a believer too?
I'm sorry. If you suppose take the example of James Webb, I guess James Webb Satellite. No, wait.
Same thing. How are you going to prove it?
Yeah, I just watched the launching thing, and is there any track of the satellite?
Well, I don't know. That's not up to me. It's up to you to prove that these images are true and correct. That's all I want from you. Verification that we know without a doubt that is true and correct.
Because it's the job of a scientist and whatever the students who are studying from MIT and good university, so they are doing their job. And if they are telling something, you have to. You cannot do experiment on everything. You don't have the time. So that's why the positions, the designated. What do you say?
Okay, so what
jobs are-
experiment should we be doing? It sounds like you don't understand asking of you. That's what it sounds like.
No, because
if you don't understand, you can say, I don't understand. I will not be offended. I know I talk fast.
No, it's not about the understanding thing. Because
excellent. So you do understand.
Listen.
How are you going to validate the images that are taken?
We're looking for a method of validation.
No, I got your point. That's what I'm saying. Maybe I said that's not particularly on the understanding fact, because I cannot understand everything.
Hey, Agni, be honest with
you can
yourself.
ask this to a scientist.
You can't validate them. Just be honest with yourself. You be honest to me now. You can't validate them. True?
No, but if scientists are saying that it...
No.
James
So
Webb
you're
telescope
taking the word of someone else. You're not validating them. You're taking someone else's word. You're already taking someone's... with the photographs, you are already taking someone else's word. I don't want someone else's word. I want to know that it's true and correct. How do I know that the photographs are not lies? How do I know that the scientist you're talking to is not lies? How do I know this?
Yeah, because you just don't trust it, so that's why.
You have to trust. So there you go. You have to trust them, right? You have to believe.
Yeah, because that's what I explained. Because they are in the designated positions. They have passed so many physics.
Right. Yeah. So when
So I don't want to question them.
We choose knowledge. We don't want to have to believe. We want it to be knowledge, right? Oh, shit! I was leaning on it. So yeah, we're choosing knowledge over belief, right? So we're going to revert back to the knowledge that we can achieve here on Earth, right, by measuring it.
It can.
Right. We observe it. You, and I, on the surface, observe it to be flat. We measure it to be flat, and we use it as flat. That's the default position that any average person has. And then you've got these special other people, you call them scientists, right? They're not scientists, but you call them scientists. They're special people. They studied for a long time, and then they were hired by the government to build rockets. And then the government said, trust us, we're putting them up into space. Believe us, please, believe us. Trust,
First of all, do you know about
believe,
the IPHO Olympiad thing? I guess, I bet you know about the IPHO thing, right? So there are students who have scored 36 out of 36 in IPHO exam, which is the toughest exam of the earth. So, you think they are...
The problem is, Agni, the problem is You believe being intelligent is the ability to regurgitate something. Thinking for yourself is a sign of intelligence, not just copy-paste. Just because some kid can regurgitate all the stuff they learned at school doesn't prove anything. How do you know? How do you know the information tested? How do you know the information given to that kid in the first place was true and correct? You've already said that you're a believer. How about maybe the teachers are passing on information, misinformation, because they don't know. And they had the information passed on to them because they didn't know. Some people just assume that everybody's telling lies. If they don't know the truth, is it a lie? Many questions to be answered. Sure.
So Matrix, listen. So how would you explain then? Suppose let's assume that we have a NASA kind of thing of our own, and we have sent a satellite, and we are saying that satellite has gone to space. So you're still.
How would I explain? I'll tell you how I'll explain it to you. Space is a violation of natural law. And the reason we say that is because according to your scientists, space is a vacuum of 10 to the negative 17 torr. On ground level, I think we're about 760 torr, give or take. Now, in order for you to have gas pressure next to an exceptionally dangerous vacuum, you would need some kind of container. This is gas laws. You need to abide by this. This is not negotiable. Whether you believe it, whether you don't believe it, whether you like it, whether you dislike it. Fact is, you need a container if you're going to have gas pressure next to a vacuum. Now, if this is true that we have a container, I can assure you now, my friend, no little rocket ships are going out into space. So, if there's no rocket ships going out into space, there's no satellites in the field of space taking these images. Most likely, they are exceptionally high reconnaissance aircraft taking these images. And we know the military has got these things. They've had them.
No, first of all, you talked about the container thing. So it's
That's
not
right.
necessary because on Earth,
yes, it is.
The atmosphere. No, I have heard about PV equals NRT and all those stuff.
You spoke to Jedi about this?
No, I didn't. No, I did not get a chance, but I have heard from him many times.
When you get the chance to talk to Jedi about gas pressure, please do so. He's very good to listen to.
No, I thought the container thing, like if there's a volume, pressure, and PV is equal to nRT. So no, but it's a gravity which keeps the atmosphere.
Stop. Gas is not affected by your so-called gravity. Solids are, liquids are. So, solids hold their position. Liquids take the shape of their container and seek a level surface. Gases bounce around and do whatever they like. So, not gravity. As long as they fit in their container. Remove the container and they expand to fill the available space. Now, as you know, we breathe gas pressure at level. If there is a vacuum, as claimed by the so-called scientists, there would have to be a container. If there's a container, you're not putting rockets through it. Sorry, mate.
No, but
now it's 33 minutes past 7. Hold up for a second. Just so you know, Agni, it's 33 minutes past 7. in 6 minutes, I'll have been on for 12 hours straight. I just looked at it. I'm probably not going to be very much more user-friendly. So if someone else really, really nice wants to keep talking, like CB or Daz or Batman or Johnny Luna, Kembo, Kingsley, T-Dub, Quiet Noobs, you are more than welcome. AG, I know you're there. I don't know if you're up to it or not. But if someone else wants to have a chat, you're more than welcome to do so. Please, step in.
Yeah, if someone else wants to.
Got CB in the house.
Nope.
Yeah.
Nope.
Yeah. He must be busy.
Actually, my finger slipped on the last one.
You're not getting busy?
It's way too fucking. I mean, guys, it's a family show. I'm going to sleep, guys. It's way too late. I can't do it.
I'm going to sleep. I'm thinking about the same thing. I'm cooked.
You're cooked. Yeah, I can't do it, chat. I can't do it.
Oi, at 38 past the hour, please look at your clock now. At 38 past the hour, I'll have been on for 12 straight.
Golly.
Yeah, man, I've been smashing it today, bouncing in between the channels. It's been great. I'm absolutely wrecked.
It's the best, bro. Go recharge those batteries. I'm gonna do the same. You guys
Hell no!
He said,
Cook them till they burn.
He's going for the record.
No, the record would be like 18 hours or someone would have done like an all around the clock job for sure.
I think Jin just broke the record.
No, Jin actually went and slept in between.
That's cat, bro. Literally, I slept and I came back and he was still talking.
He was sleep talking.
Probably.
He just argues in his sleep about Flat Earth. So he can just be on Discord with his mic open and it'll be appropriate. Yeah, it's just like
would not be surprised. Well, before I leave, guys, I just want to quickly advertise. Be on the lookout for a very special release on Thursday. We're shooting for Thursday. You don't want to miss
What time, roughly?
this.
What time?
Say probably about 6 hours from now, 5 or 6 hours from this current time. So like whatever time that is for you where you are. But like
early in the morning. Lovely.
But how is it early in the morning for me and you?
I'll try.
6 hours from now, as in backwards or forwards?
Oh, forwards. 6 hours forwards.
So if I go 6 hours from now, that would give me, what do we got? 7:30, 8:30, 9:30, 10:30, 11:30, 30.
What time is that?
Your 6 hours on top of now puts me at 1.
It's cutting out 1:30.
1:30 a.m.
0100, yeah.
Oh,
You'll be lucky if I'm awake.
Oh, you Aussies. So like, okay. So morning time for the US, it's you guys are sleeping.
Yeah, morning time for you is about 10 o'clock in the I know what you... I mean, Mike's
Okay.
cutting out. It's getting hot again.
Yeah,
Too much talking.
Discord has been glitching.
No, I think it's my setup. It actually gets a bit toasty. And every
Anyway.
now and then I have to do a quick reset and off I go again.
Okay.
So yeah,
No, that's
so
been happening to me too. It's weird.
you your mornings are like 10 o'clock because I know you need your beauty sleep.
Yeah, man. It's so hard. It's so hard. Anyway, yeah, no, we're. I don't want to say too much, but it's gonna be special, man. It's gonna be a beautiful thing. I hope you guys were
We'll
As
join.
long as it's recorded, I'm good because I can always play it back.
Yeah, I think it's gonna be. Yeah, it's gonna be recorded.
Yeah, mad.
But it's not gonna be. I know we did like a misogyny meeting. We did the off-topic thing. Like, it's gonna be even more special. So, anyway, so I can't say too much at the moment. But I hope.
Where's
you
this
guys
at home base or at one of the other?
We're gonna do it from home base. Yeah, we're gonna do it from home base.
Oh yeah, mad.
Might be. Hey man, you guys need to go and cut your hair, shave your beard, whatever you need to do, because we're going on camera, boys.
So what?
Yeah. Put on your Sunday's best.
You've seen my head. Seriously, I don't need to be on camera.
No, you look good.
I love that when it's time to go to bed. Yep, need me beauty sleep. See you later. Oh, yes. Got a head like a drop pie.
So, but yeah, no, look out. We're shooting for Thursday probably about 8 o'clock Central, 9 o'clock Central, something around that time.
Okay, so hold on. I'll get my clock out. Where is it? Where is it? Where is it? That one. Blue. And
I'm gonna have to get some sleep because
time converter. Here we go. So what time you reckon? Central time? CDT?
probably 8, 9, 10 Central.
8 o'clock in
Around
the
that
morning.
time.
Okay, so what? That's not right. CDT, PDT. So CDT at 8 a.m. puts us at 11 p.m. our time. We might be listening.
Okay. Yeah.
Okay, so that's Thursday night. So early Thursday morning for you, Thursday night for us.
Yeah.
If you're in Iceland, it's 1300 in the afternoon. Brooklyn 9 a.m. Kansas CDT 8 a.m. LA 6 a.m. London 2 p.m. Tokyo 2200. Santiago, Chile 9 a.m. and Cape Town, South Africa 1500. So 3 o'clock in the afternoon. How's that
Nice,
for a good
actually.
spread?
I appreciate you doing that actually, because thanks for actually announcing that. Well, yeah, man, we're
So-
sure. I don't want to say too much, but it's gonna be a great thing, man. I hope you guys will join.
So yeah, so that's Central Time 0800 on Thursday.
Yes, sir. I mean, it's not like a locked-in time slot, but I would say you should be click on your Discord around that time, bro. We're gonna pop off and go get your haircut. Go get your haircut, put your trim your beard, brush your teeth,
man.
comb your hair.
Be late at night for me. I'm not going to look pretty. Oh shit, that's funny. Anyways, man, cool. There you go. I've made me 12 hours now. I'm happy.
All right, man. Let's get a W in the chat for Matrix, guys. I think he deserves that. That's a long shift right there. Oh, Helio Skeptic's in the chat. Helio, you definitely should attend as well, my friend. Even if you're just listening.
Grab your best mic, Helio.
Ooh, I mean,
Actually, he said the other week that he was digging through boxes and stuff, looking. He must have just moved, and that he was looking for his mic or something like that. So hopefully he
He's
finds
capping, bro.
his stuff.
Helio, that's cat, bro. I'm looking.
We
for
know
my mic. That's
we know
cat,
his
bro.
mic works because how many songs has he done?
I know. Oh, I'm looking for. I'm gonna say that next time. I don't want to come on the mic. Oh, I'm looking for it. I'm sorry, I can't find it. That's funny. Yeah. So, anyway, I think it's gonna be the start to something very awesome. Yeah. So, hope you all will be there.
I'll give it a crack. We'll see how we go. Hopefully they start on
man.
time.
Yeah. Yeah. So, anyway,
But we'll find out Thursday.
out of here. Yes, sir.
All right. Cool, mate. Take it easy. And we'll see you on the
Right.
next installment of 24/7.
Yes, sir. Yes, sir.
Same bat channel, same bat place.
Same bat. Yes, sir. All right, man. Well,
good
appreciate all you guys, man. This the whole community, W Vivek, W panel, W Matrix. What did that guy call you? He said like mate
Metatetrix.
No, I was gonna say that.
It took him multiple goes to get it.
Oh, really? The last guy you talked
Yeah,
to
it was-
said like Matetrix. Oh yeah, that's what he said. Matetrix. I love it.
Yeah.
Hey, listen, I'm Matetrix.
Some of these guys
It's all
have been
good.
hard to understand today. Some
Yeah,
of them are pretty
man.
easy.
The Jeet levels are on over 9,000. Shout out to everybody that comes by. Anyway, all right, guys. Well, I'm gonna roll out of here.
All
Hope
right.
you guys have a
Cool,
good rest of
cool.
your day, rest of your
Thanks
night.
for popping in, CB.
Thanks, guys. CD. Oh, thanks, guys. Peace.
Bravo just joined Deafin and then just left straight away. He's probably like, nobody's talking.
Soldier boy. It's a sister boy. Should have stuck around. Oh,
Doesn't realize he's deafened. He's going into all these channels. Why isn't anyone talking?
Yep, no speech in here. Next. No speech in here. Next. Oh, man, what's going on tonight? I can't even find anyone.
What's going on here?
Hello.
Hello, how are you?
Good. What are you up to?
Guys. What's going on here, guys? What's going on?
Well, we're just waiting for people to come in and tell us how they know that the Earth is a spinning ball in outer space. He left. He's like,
Did he just ha and leave?
Yeah. Yes.
Oh shit! My guts are hurting for that. Oh man, I'm gonna try that one day. Is there any Globers in here? Yeah. Ha ha! Doing out of here. Oh yes. I wish I could do the fat kid off The Simpsons, that Nelson kid. I wish I could do that a lot better.
Right. I wonder if I've got that on the soundboard.
Oh,
'Cause
it would have to be there somewhere. I'm sure of it.
I'm in a Simpsons server, so let's see.
Oh shit. Oh, they'd have it for sure. Don't.
Unless they've got it, or they don't. No, I'm not seeing one. Unless it's got a. No, because if you put a space in, it doesn't come up with anything, does it? Oh wait, no, that's Aha, idiot. Aha. Oh, who did that? Who's got that? I don't have it. Where'd you get that from?
That's a good question. I don't know. It doesn't say. It's what server's that in? It's in favorites. Oh, Creation Bears soundboard server R. There we go. So you got to harass him and get all of his servers, and then you'll have lots and lots of sound.
Oh, nice. Okay. I just wondered that.
I take it.
It's not.
I take it you've got Nitro,
Yeah.
right?
But
So you know how it works.
I don't know if I have the big one or the small one.
All right, I've got the bigger one. So what happens is, I'm not sure if they're both the same. I'm hoping so. Every single server you've got access to, you're allowed to use the sounds. As you probably already know. Yeah. So naturally, the more servers you're in, the more sound effects you would have. Because every server has got a minimum of 8. So to put this into perspective for you, of about roughly how many sounds I've got just myself, I name my servers starting at A, B, C, D, all the way through. I'm down to Q. Now, I've already done 1 to 10. I'm down to Q. Creation Bear has gone right through the numbers, right through the alphabet, and he's now doing special letters. And some of them he's even started naming outside of that. The majority of them we've shared with each other. So we have just under 1,000 sounds combined between us. That's without politics, 24/7, PNR, English channel, and whatever other servers I'm in. That's just us two sharing channels. So sometimes what I have found is when you have a lot of them, when you click the button to make the sound effect come out, there's about a 5-second delay sometimes.
Edonia.
What's up, friend?
Hello.
So, what brings you here today? So we just asked the last person that dropped by. We asked them how they know that the Earth is a big spinning ball in outer space, but they left. I was wondering if you have an answer to that.
No, I don't. Kan tipsa.
Well, then I guess you're just left with what you experience it as, which is flat and motionless, right?
Mm-hmm.
Well, then, welcome to Flat Earth. Yeah.
Thank you. I think there's a problem with my mic. Wait.
If there's anybody else that's just joined recently or in the last few moments. Hello. Yeah. Welcome in.
Oh, no, sorry. Yeah. Go ahead. Sorry.
No, that's fine. We're asking people how they know that they live on a big spinning ball in outer space.
Mm-hmm. Okay. I see the title of this Earth discussion. So.
Mm-hmm.
I'm sorry, your mic is a little bit crackly. I didn't quite understand.
What is it now?
No, I'm not catching that. Sorry, mate. Yeah, oh, he's gone. Yeah, never mind. Well, relatively small panel at the moment. I've got to take a short break. I may or may not be back to speak, but hopefully one of... Oh, Arthur's back. Welcome back. So we have Lats too. That's much better. That's nice, clear sound. Yep. But if one of our other flat possibly spearhead the Q&A session or whatever the conversation, please do so because I've got to take a break.
Yep, so have I. Probably I'll be back on tomorrow morning. So T-Dub, high five for the afternoon. That was a pretty
cheers, mate. You too.
Awesome run. And to the other lads that have been in here supporting and thank you much. As you can hear, I'm dropping out and stopping and starting, so that means my system's getting hotter than it needs to be. So everyone, I wish you all a good morning, good afternoon, good evening, or good night. Thank you, peace, and I shall see you all tomorrow. Catch us, guys.
Cheers, Matrix. Catch you, man. Stuff. Oh, no problem, lads. That's all right. Yeah, no worries, man. Understandable. Dang, where is everyone? Where's Alpha and Jedi and Indio and Wolfgang? It's the whole gang. Where are they?
Earth is round.
Yeah, can you prove that? I guess not. Yeah, Circuit Breaker. Yeah, we see lights in the sky that we've named planets. They have retrograde motion, so their cycle is works a little bit differently. To other stars. The original definition of a planet was a wandering star, for that very reason. Modern definition gives them solidity or physicality, and gives them the attribute of having an orbit around the sun. But none of that is observed nor verified or verifiable. You just see lights in the sky. No one's claiming that, Circuit Breaker, but mind you, you might scoff at that, but you're the heliocentric side, so the side that believes that the Earth is a globe and part of a solar system, and the solar system is part of a galaxy, and the galaxies in the universe, etc. They have a similar belief that if you could bend and warp space-time enough, that you could skip between one point and another, covering vast amounts of distance in mere seconds, like trillions of light years across the universe. Did you laugh at that when you heard that idea? Einstein and Rosenbridge's idea. I mean Rosen's idea, but Einstein and Rosenbridge's. Haven't you seen them on the documentaries when they fold the piece of paper? They put two holes in the piece of paper and then join the holes together by bending the paper around? That doesn't seem crazy to you? Yeah, you believe that Earth is a planet, right? But there's no evidence of that. Earth is not a planet. It's not in the sky. You have terrestrial and you have celestial. And celestial does not mean outer space, as you've been taught. Oh, I know we can't currently travel like that, but I bet you didn't think that was a silly idea when you saw it on TV or on some documentary or on some YouTube short. I bet you went, "Whoa, man! Wow, those scientists really are smart." But the idea that could, potentially happen on a flat Earth, that's silly. What a silly idea that is, right? Kind of seems like double standards you have there. What do you mean, what about satellites? What is a satellite, do you think? Yes, and Earth isn't one. Because Earth isn't one. I just said that. Earth isn't a planet. Earth isn't a planet. Planets are not what you've been taught. And the universe, as you've been taught in textbooks and on TV, doesn't exist. Okay? You're not on a big spinning ball that's going around the sun. And you're not in a big galaxy, and an ever-expanding universe. Right? You're on a flat and motionless plane. The luminaries or the lights above us that move across the sky daily and nightly, okay, they are unidentifiable. We don't know what they are. We don't know how they move. We don't know how big they are. We don't know how far away they are. And we don't know what medium they exist within. All right? Nobody can know those things. You're told stories about those things that you've chosen to believe. Okay? You can't verify any of it. But if they were what we're told, right, and the Earth is like a planet, so if a planet is an object in outer space and its surface has curvature, and Earth is like those things, then Earth's surface would have curvature. But it doesn't. We don't observe it to have curvature, we don't measure it to have curvature, and we don't use it as if it has curvature. No, you don't, Circuit Breaker. Jump on your mic. Jump on your mic and have a talk. Yeah, how do we know? How do we know? Not somebody else. How do we know? How can we how can we tell how far away they are? Measure with laser? Really? You think you can shoot a laser to Mars? Or a star? Hey, Flat Earthers, if there's anybody out there that's available to speak, can you please join in? Cover things here. Be prepared for conversations, people joining, or responding to text. I'm going to call out. If not, I'm just going to go on mute, and looks like the chat's dying off anyway, so it's probably just going to die off more if nobody's in here being active, which will be unfortunate. Alright. Muting up for a bit. No, good, Kembo. No problem, man. I understand. You can't. That's the way it is. Just surprised that there's not more people in.
wood, like obviously it burns, right? But you want to find out what causes the reaction for combustion to happen of why dry wood would burn. So you're going to look for things without like trying to quantify. You're just looking for what things make dry wood burn. Right, so
But
you
just
throw
because
some.
you come to a conclusion doesn't mean you are correct nor valid.
Well, but here's the thing, though. You're gonna throw some sand on it. You might throw some water on it. That doesn't cause a reaction. You're gonna try to do whatever it takes, right? Then all of a sudden you get to the place where maybe you light a match or something, and you see fire happening. You put it to the dry wood, and the dry wood starts to burn. So what happens is like you see it happening right there and then. You see the reaction between dry wood and fire.
To create a model.
Yeah,
that's
but
not
what I'm
science
saying
because.
Hold on a minute, dude. Like what I'm saying is, you see something happen in nature, right? There's a natural phenomena of dry wood burning. You see something, a tree being burned up. You see a tree being, you see a tree. Hold on, dude. You see a tree being burned up in the woods because it got struck by lightning or whatever. So you saw something happen, and you're like, I wonder what caused that. I know I saw lightning, but I want to know why that wood is burning. So you want to know. So you're gonna start doing things to cause the same reaction. And so you're going to use methods, right? Different things. And you can say, I tried all these other things. This one thing is what works. And so you're not like measuring like, okay, I'm only going to put, 5/8 of this thing in here, or you know what I mean? Like 3/4 in there. Like you're just going to.
That's not science at the end of the day.
Wait a minute, dude. You're just trying to cause a reaction. That's all you're doing. You're using an independent variable to cause a reaction in the dependent variable. So you're not.
An experiment. Yeah.
Yeah, I know, but you said it's not, and I'm telling you it is.
No, it's an experiment. It's not science.
Well,
it doesn't follow
what
the
do you
scientific
mean?
method.
What do you mean it's not?
It follows experimental methods, but the scientific method includes you must do background research, and you must publish the results for other people to look at so they can repeat that.
Yeah, it could be testable or repeatable, but what I'm saying is when
it has to be tested and repeated.
When the researcher's actually doing the inquiry as to like what's happening, you have to formulate a hypothesis to test it, right? I wonder how we're going to do a test. So in a controlled environment, you're going to figure out how you're going to manipulate this independent variable to cause a reaction to make the dependent variable change. In order for you to do that,
experimental method, yeah, but that's not the scientific
but it's following the scientific method because you want to see a naturally occurring phenomena. When you see something happen in nature, you want to know why that's happening. So you want to cause a reaction in the dependent variable. In order to do that, you're going to have to change the independent variable. You're going to have to manipulate that. So what I'm telling you is that you don't have to like measure things. You can just try different things. So there's no measuring there that happens. You just.
So, if I may speak uninterrupted for a second, because I fully understand what you're saying. I'm saying, in order for it to be science, it must have background research and be repeatable and be presented.
That's incorrect. I told you about my vacuum chamber before, and you went, blah, 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 well, and I didn't need to get Flat Earth Ranger over my house to do it with him.
That's correct.
When you have this system that must have all these different parts, I'm saying some parts are not found when you're just doing that experiment. And the scientific field has to include all these different research. So the reason that measurement, I feel, is a requirement in true science is because you must be able to repeat it and others must confirm through repeating the same thing.
Yeah, I know, but you're calling it true science doesn't change the fact that it's still science. Like it's not.
It does change. It does, but it's an experiment.
It doesn't need to be quantified. It doesn't need to be quantified. Okay.
Okay. The independent variable
quantification
be quantified.
You can just X causes Y. That's it.
Okay. What's the independent variable though? In
germs cause disease, right? We can figure that out without counting
disease.
Yeah. We can figure that out without
germs?
Yeah, germ theory, right? Germ theory don't have any quantifications.
Germ theory has quantifications. Yes, they do.
But it's not required.
It is so that they know what they're talking about. They have qualitative descriptions of different types of germs, and then they have
qualitative, right?
And then they have quantitative categorical distinctions.
What I'm saying is quantification isn't necessary. It's not necessary. Faraday didn't quantify the law of induction.
I mean, he did.
No, he didn't. None of his original experiments have any quantifications in it.
Yeah, but when he published it, it had quantifications because it had.
No, someone else did that.
Oh, well, then they're the ones who
That's
applied
ex
science
post
to it.
facto.
And more science.
So the point here is that you can follow the scientific method without quantifying things. You can figure out the cause and effect relationship without quantifying it.
You
Now,
understand where I'm coming
in
from,
modern
like, I
practice,
think you need
hold on.
it to
In modern
communicate it
practice,
with.
you would quantify. You would do a bunch of trials, right? And then you would give it a p-value to figure out whether that that effect, that cause and effect relation of that experiment is greater than chance. That's just modern practice. Yeah, but that's just modern practice. That has nothing to do with whether it's a valid experiment or not. Still following the scientific method, whether you quantify it or not. Now, you could say this isn't rigorous enough for me to believe in, but that's just, that's a personal thing. It has nothing to do with whether the experiments follow the scientific method. Now, what we're talking about is when you say Earth is flat, Earth's a globe, Earth's concave, Earth's a freaking pineapple, right? Now, think about your house, right? There's lots of shapes in your house of different things. You could take a tape measure, run out through your house, measure everything, and you wouldn't call yourself a scientist because you know the freaking height and depth of your cabinets, would you? If you knew that you know your table's a circle or a square, you wouldn't say, hey, I just did some science.
Yeah, no, I would not. I would say.
Yeah. So when we measure the Earth and say, hey, the Earth is this or Earth is that, we're not doing any science. We're just measuring its form.
Well, science has a lot to do with measuring.
You have to Kleenex. You have to concede, bro. This is a valid point.
This is a very valid point, but I don't think he's taking into account certain fields of science that absolutely have to do with measurement.
Yeah, but the form of the Earth being what it is not a method of scientific inquiry. It's just measuring it. You're trying to figure out what it is. So what is question? A how wide question would be what science would be dealing with.
But science deals with when we ask, how can we measure that?
Yes.
Yeah. So it is.
But we're not how can we measure it? Now what we're dealing with is what is the Earth, and so if it's something that you can put in a category of like, well, if it's an oblate spheroid, or if it's a cube, or if it's a pyramid, or some other kind of 3D shape that you're trying to put it in, then that's just you're using a method to figure out how to measure. You're just trying to measure the thing.
I mean, you're not wrong, and I don't think science will tell us what the Earth is. But when we ask, how do we measure this, we use scientific methods and tools to help us measure things.
My God, it's just going to keep doubling down.
Let's say we want to find the coastline surface area of a country, and this is practical because it's a way that they
So, what are you trying to find the cause of? You're trying to find the cause of coastlines. Or coastline length?
I'm trying to find. I'm curious. So this would be me asking a question. How can I get a standardized measurement for the coastline? So now I do background research. I understand the complications of doing finding the length of a coastline.
Apply scientific method to it, dude.
Area? Do we go off of tide? Do we go off of?
Yeah, just apply scientific method to
hypothesis.
it.
Yeah.
What are you going to do with the scientific method here?
Yeah, what's the cause and effect of coastlines measurement?
Why is this a question?
Yeah,
because
it's not.
Argue. Science is measuring.
It's not a scientific endeavor, just like was said. Like measuring coastline, it has nothing to do with science.
Yeah, everybody's been telling you this.
A scientific method, it must include the cosine thing.
Oh my God!
Yeah, you don't have a cause and effect relationship with.
He planted his flag on this hill. I think this is the hill he wants to die on. I guess.
The thing is, this is what's blowing my mind is that he was repudiating this hill like 5 minutes ago. That's why I brought it up, because I knew when it came down to Brett, when he brought up science in the globe, people would try to defend it, even though he was. Don't take this personally. You were saying people use science all wrong in lots of situations, and they believe science is, all these things that it's not. But now when I mention science in the globe, that mind virus, you planted your flag on the hill, dude, and you're going to die on it, even though it seems like a pedantic argument, but it's really not.
Yeah, you went cattywampus, dude, when he told you that. So now we're trying to figure out why. I know why. You even said why. You're identifying with the Earth being a globe. So you have some sort of psychological tie into this thing, So you're kind of invested, man, whether you think about it or not. You try to sound a bit unbiased, like you don't care either way, but it sounds like what we're hearing is different. Like you really are, like,
well, the thing
you're
that
trying to find your way around this, man. There's really no way.
I'm hearing
Okay,
you. The
well,
reason
I
why
mean-
I started going that way was actually my connection with the scientific method. I think it's being misapplied if you think that's all the scientific method is. That's all. I don't care if
You
it's
have a
a
mis-
globe or
you
flat
have a
Earth.
you have a fundamental misunderstanding of the scientific method.
Okay, explain to me why you can get rid of a certain step in the
Okay, so I'm going to present you an example. In front of me on the table, I have a cube, a sphere or a ball, and a triangle. What is the cause of those shapes?
Depends on the material.
So you think there's a cause of those shapes? What caused those shapes? So you think that's a scientific endeavor?
And you think that those shapes are a natural phenomenon?
Just because there's cause, it makes it a scientific endeavor.
Yeah, it has to have a cause and effect. So you're looking at a naturally occurring phenomenon in nature. You don't find those shapes in nature, for one. When we're talking about Earth, it's a geometric question, period. It's not a scientific endeavor because there's not a cause and effect with a geometric shape. If we're just measuring the surface of Earth, that's a geometric endeavor. A measurement is all that's required. You don't need cause and effect. You don't need an experiment to measure something. You just measure it.
But I think we all understand that in the globe theory, we don't have the full measurement. Like there's trees. We don't include all the trees.
Oh my God. Okay, we're not talking about trees, bro. We're talking about the measurement of the surface, like legitimately over water. Like drop over distance over water is mostly what we talk about.
Right. But that's fine if you apply science to it. That's great. Just applying.
How do you apply science to it? You don't do that.
Okay, let's walk through the scientific method. What would we want to know what the Earth is, what its form is? What's our independent and dependent variables?
So we would have to translate stuff into them, but
what does that mean? Like we want to know what's the independent variable and what's the dependent variable. What's the control variable? What's the null hypothesis? Like, what are all these things? These are all. These are all. Hold on. These are all components of the scientific method. All of them.
They don't have to be. They're not always part of it.
They have to be.
I mean, in what situation would they not be part of it?
In situations where you're not comparing results. But you can do it with comparing results and finding the curvature of the Earth.
Comparing results is after the fact. Do you get that?
Yes, that's results of the entire thing. I'm talking about results of a specific.
So we're not talking about after the fact.
It's part of a research paper.
India is asking you.
If you have two different groups, they'll have two different results. Those are the results I'm talking about comparing. If you have to
compare after the experiment is done. Yeah, that's besides the point. We can talk about comparing results afterwards.
Part of the what? No. Like if you're doing an experiment, the only time you need to have the dependent and independent factors are when you're comparing two different groups, so you can see the difference.
True.
You're trying to figure out the relationship between the variables.
Independent means it doesn't change based off of the environment that you put it in.
No.
And the only way to have an independent variable is for two different groups to share that independent variable.
No, that's wrong.
That's what I was taught.
X causes Y. The independent variable is X, the dependent variable is Y. So, for example, we observe a natural phenomenon. That would be the effect, the observation of something happening. That would be our dependent variable. What causes that is the independent variable, right?
But the independent variable that causes the dependent variable can also be dependent.
Oh my God!
It could be. Okay, it could be, but that's why you're supposed to identify confounding variables and control them. Right. Those would be control variables.
To have multiple groups so that you can compare them to understand that they don't change.
You can control them experimentally by just holding them so they don't change, right? So if they don't change and you manipulate the independent variable and the effect changes, you know the cause of the effect, as long as you've identified all confounding variables.
Yeah, which you never can. But if you have enough of them, yeah.
Well, I mean, obviously not. That would take fucking OmniBrain,
Yeah,
right?
even in NASA labs, they can't. Yeah, they've admitted it themselves.
So we got away from the point there. So Indio asked you a pretty poignant question. So in the question of what Earth is, let's start from the beginning. What is your phenomenon that you're observing?
Well, I mean, we can just go to. He already admitted that measuring items in your house and their shapes and sizes wasn't science. How, when we use the exact identical methodology, tape measures, like rulers, shit like that, that somehow it's different because it's the Earth?
Well, because when you're doing it in your house, you aren't using the tools and methods that required science to create.
What?
What the hell does that mean?
It means that you did not need a standardized anything to build upon the idea that you...
Rulers are standardized.
Yeah, meters are standardized, miles standardized.
That's not created by science, though. They're not standardized by science.
So what? What does that even mean, created by science? Is there like some magic science genie creating things?
Yeah, so tell us the standard. Tell us the standard of measure that science created. Go ahead.
What? No, I said it doesn't.
Yeah, that's what you said.
It created Newtons.
You said a measuring. You said a measuring.
That's just a unit.
A measuring standard that was created by science. So we want the measuring standard or method that was created by science.
Spectroscopy.
Is that a standard? Is that a standard of measurement?
Jesus Christ, man! Did you really just say that?
Thing that has standardized units like frequency and all this.
Is that how you measure things with microscopy?
He's throwing shit at the wall. He has no clue what scientific method is. He's trying really hard to fit his geometric claim of globe into the scientific category. He doesn't have any clue about any of this stuff. It's totally obvious.
Doesn't. So
You've been telling him over and over, you're going to test the cause of a natural phenomenon. That's what the scientific method is for. Then he starts saying, oh, that's the experimental method. It's the same fucking thing. Experiment is the test of science. That is the scientific method.
I think the scientific method must include...
Yeah, now we're going to get what he thinks.
Background.
He's just going to ignore what it actually is and tell you
Can you do science without experiment?
No.
Okay, then we just gave you the experiment, which you can't take out of the scientific method. We just gave you the scientific methodology for doing an experiment.
Right?
Yeah. So it applies not just to the experiment, it applies to the scientific method as a whole. Nowhere in there can measurement of the Earth fit.
No, the measurement of the Earth and what it is and what it actually looks like is not science's job. No, I've already conceded that.
Oh,
when it comes to finding out those measurements, you do use science.
In what way?
Well, I mean, the laser, it was invented by, understanding and building on blocks through...
You haven't told us. You haven't told us what method that is.
A laser
scientific method.
The problem is he has to call this science. That's where he's coming from.
No, it's what I was taught. The scientific method is applying all of these steps in scrutinous order.
Scrutinous order. Jesus Christ.
Okay, could we do the same experiment without a laser and just use a mirror? Are you going to claim mirrors are invented by scientists?
I would say that you can't create... I mean, no. Some of the mirrors...
These experiments have been done with a mirror.
Mirrors have existed for a long time. They don't take much science.
Yeah, and these tests, these long distance tests, have been done with mirrors.
Okay, yeah, then that would...
No lasers. So the device is what makes it science or not? The device, the measurement device itself?
Yeah,
like that seems...
That is
really?
one of the factors, yes, yeah. But in this case, if you...
The measurement device.
I mean, that's what I said, isn't it? Like, that's what
would one measurement device versus another, how does that change it into science? What qualities of the device?
The science is a manufacturer.
To understand and build on.
That doesn't make any sense. We want to know about the device itself. Okay,
Yeah, but
I have a mirror. I have a laser. Why is the laser science and the mirror's not? Or vice versa?
Because the understanding of it comes from the momentum of the collective consciousness using the method.
Okay, I'm not touching that, dude.
Word salad.
That's not word salad. It's word salad to not use the scientific.
Yeah, you don't know what it is. Still, even when told what it is with an open book test, you failed. You don't know what science or the scientific method is. You think it's something other than what it actually is.
What is it actually?
It's actually a method.
Right.
Testing the cause of a natural phenomenon.
Yeah. Naturally occurring phenomenon.
The cause, dude.
The natural phenomenon?
Yeah, that's what it's for.
Not man-made phenomenon, not mechanical phenomenon, naturally occurring phenomenon.
I thought it was to find the mechanism so that you could get better predictability.
Mechanism. So what are you studying? You're studying the mechanism, or you're studying a cause and effect?
Mechanisms of stuff, mostly.
A man-made mechanical device.
No, mechanism is the concrete, step-by-step cause and effect relationship that creates the outcome.
Oh my God! It's never going to get to any specifics. So, what in particular was the scientific method used for in any of what you're talking about?
Yes, please. Somebody stop the painful.
Was used to describe how chemical reactions occur.
Okay, well, we're talking specifically on the topic, though.
Yeah, science isn't about descriptions either.
The coast stability, like we used mathematics to help with the coastline.
Okay, that's mathematics. That's a coastline. We're talking about whether the Earth is a globe or not. Where science used in any claim that you have. Okay, there we go.
Better.
How?
Because we applied understandings that helped us get more accurate results.
Okay, you're just talking like vague. Yeah, so.
It doesn't mean it's correct to apply the understandings or that the understandings of science is correct. My point is there are cases that people use science to help with measurement. That's really the claim.
Where? Which one?
When, where, and how? What method?
I mean, lasers.
Yeah, be specific.
Is one. Anything
lasers. Okay, how was the scientific method used for lasers? Yeah, okay, don't gish gallop, dude. Lasers.
He's barely listening.
Scientific method was used how for lasers? What was the natural observed phenomenon when the scientific method was applied to lasers for measuring shit?
They would do an experiment with lasers.
No, that experiment will come after the natural observed phenomenon,
and
dude.
then people would be able to
Start with step one, natural observed phenomenon.
Yeah, for the creation of lasers.
They naturally observed that light existed. In some sense, it was different than things.
Okay, naturally occurring phenomenon. Light existed. It's different than some things. Okay, suppose cause for light exists.
Now we go, okay,
that
light is reflecting off of that surface. Why? Why do I see the sun when I'm looking away from the sun? Right?
Science doesn't answer why questions.
So a mirror then? That's going to be your independent variable? A mirror reflecting sunlight?
That will be part of the experiment that starts the building blocks. I then understand that it's some type of reflective surface. I then come up with equations to help me predict where it has to be in order for me to see the sun and at what angle. And then I produce those results. And then other people go, well, those are inaccurate results. I'm going to build upon them and make your math more clean. I'm going to...
Mr. Magoo's sophistry hour. It's just painful.
Yeah, how did they come upon a laser through their scientific experiment?
Well,
what was the experiment?
They understood through background research, anyone who has a question of like...
What was the experiment? What was
background research?
We need the experiment.
Your hypothesis or your question can just be, what would happen if I launched a bunch of like flashlights together? What would happen?
What the fuck?
What was the cause and effect of? What was the cause and effect of flashlights all put together?
The cause was the resonance within the flashlight's light as well as the light itself, and the effect was increased frequency of the rays coming from the flashlights.
What the fuck? Well, let me ask you a question. Do all questions that can be asked, can it be figured out scientifically?
No, you can never figure anything out.
Okay, so what you're saying can't be figured out with science.
Correct. It can't be figured out with measurement, and it can't be figured out with experiment.
Because you're talking about things that are man-made. We know how they work because man made them.
We didn't know how they interacted with each other when you put them together.
That's not science.
Yeah, that's called engineering.
It is a science.
We did trial and error, right?
That doesn't mean you figure it out. But
no, it's test and observation.
Trial and error. trial and error. You guys don't want to acknowledge that almost everything.
Method. Trial and error.
No, it isn't.
Yes, it is.
Trial and error has nothing to do with the scientific method.
Of the scientific method, it has arrows that make loops, because if it does not align with your results, you try again, construct a new hypothesis, test it with a new experiment.
Yeah, there's a different trial and error.
You go back to test with an experiment.
Okay,
these are trial and errors.
This isn't the trial and error I'm talking about. The trial and error I'm talking about is engineering, right? So you have a bunch of equations, and you say, "Hey, we're going to manufacture this part and see it because we want to do this." Then you manufacture a part, and then you test it, and then in the test, it doesn't work exactly as you say. So you change how you manufacture the part. That's trial and error.
Yeah, and that's part of the scientific method. Yeah.
None of that. That's engineering. None of that is a scientific method.
Actually, engineering uses a scientific method like that all the time.
No, it doesn't, because scientific method only deals with natural phenomena.
Yeah, you know, the phenomenon of different materials' physical properties and how it affects with, electricity.
Be specific about the phenomenon observed in nature that the experiment was based on, and who actually did it. Give us something real world that someone actually did. Don't just blather something.
I can't hear you because he's talking through you.
And don't just make something up on the fly. Give us a specific real world example. Something somebody actually did.
What I just thought of is human-based. So
you're going to just go again with stuff that you're making up here on the fly.
No, I'm not. I'm thinking of stuff that is actually known.
You're talking like in vague generalities, right? There's no cowbell here.
Flashlights are the cowbell.
Yeah, you got nothing. You're making stuff up, dude.
You guys made up someone seeing a tree get hit by lightning.
Right? Oh no, you guys.
Someone. I'm trying, bro. I'm gonna look for. There's different examples that definitely
getting hit by lightning now proves that you live on a ball. That's awesome.
Said that. That's crazy.
Wait, so what shape do we live on?
We can't get to that because he's desperate to call it science.
No. I'm just curious on y'all's opinions. I don't give a fuck about his opinions on shit.
We don't live on a shape.
What do we live on?
Earth.
Yeah, but what is it?
Space is fake, so it's not a shape.
It's a what?
Not a shape. Space is fake. You don't fly around in space.
No, yeah, but what's the shape?
No, yeah. There's no shape.
What's the shape of the universe?
Expanding in all directions.
Relative
if you had a balloon that's expanding, it's still a balloon shape. So what's the shape of the universe?
I don't think he asked me what it was doing. I think he asked what the shape of the universe is.
Relative to concave and convex, the universe's shape is flat. It's one of the reasons we see a really big and fast expansion at the Big Bang.
Where's the edge of the flat universe?
Huh?
First of all,
I don't know if we know much about the edge.
All right,
we can only
facts.
see as far as our different electromagnetic, things let us.
But you put your positive, there is an edge, right?
Follow-up question. Are we prompts?
Huh?
What does he want to be?
Follow-up question. Are we prompts?
I don't think so. We can be, if you try hard enough.
I've met some prompts.
Right. CB,
one more question.
About you, I'm like, man, if you were here, you'd be cooking this dude with a soundboard.
Facts. Wait, one more question for the Flat Universe guy. Can you draw the shape flat and then post it in the chat?
Oh yeah, I want to see that too.
The shape of the universe?
Well, you said the shape is flat, so can you draw the shape flat for us and then post it in the chat?
I won't draw it myself, but I can give you our best rendition of a 2-dimensional 3D flat plane.
No. It's just keep it real simple. Open up your Notes app or MS Paint or something, and just take your pen and draw the shape flat, and then we'll take a look.
I think we both know what that would look like. It'd be a line.
Nope.
That would be called a line.
Yeah, it would be a line.
Do we need to go back to what shapes are?
He asked you to draw a flat.
So sometimes in class they're talking about a line, and they say flat.
Okay, yeah, sure, yeah, yeah.
Really? Yeah, that you've heard that happen before.
No, that just works with what I meant by flat. It means like I
So
think.
if I draw a curved line, I can call it a curved flat.
I don't know. I just learned.
The teacher says draw a curved flat. You've had that happen before.
Oh, you guys are making that up.
Do we have to teach you what shapes are? Radwin, get your triangles out.
If I draw something flat, it'll just be a line.
That's called a line. That's not a shape.
Do you know
I
what
wasn't asked to draw a shape. You want me to draw the
triangle
universe?
No. You did. You said, "What's the shape?" And we said, "Well, what's the shape of the universe?" And you said, "Flat."
I didn't just answer flat. I said,
should we just rip the Band-Aid off?
Convex or
Let's just rip
concave,
the
it's
Band-Aid
flat.
off. Flat's not a shape.
Space can
Dude.
either be concave or it can be convex, and in the universe's case, it's flat.
That's not a shape, brother.
That's fine. Okay, I guess I misanswered the question.
We can reveal to you how it's not a shape if you were just to take your
I
pen
was
and
just
draw
talking
it.
about, it's geometric shapes, like not
Yes.
exactly a shape or
Flat is not a
standardized
geometric
shape.
shape, dude. This is crazy, bro. What's happening, Heretic? What's happening to the Globetards, dude? They're getting more and more retarded over the time.
What's happening
bro.
is you don't understand. I'm not getting retarded.
I don't understand. You don't know what shapes are.
Yeah,
we heard you.
You're here telling us that a line
You
is
think
called
I
a
don't
flat.
know what shapes are?
So the
You
teacher
think I'm
says
going
draw.
to a flat?
Take it.
What are
MS
these?
Paint.
What are these assumptions about me? They're crazy.
MS Paint. Go to your notes app and draw the shape called flat.
I would just draw a line.
That's not. That's not a geometric shape, dude.
Yeah, flat isn't a shape, right? Why would I draw a shape if you're asking me to draw something that's not a shape?
Well, when we asked you what's the shape of the universe, you said it was flat.
Yeah, I said in relative to convex or concave, it would be flat. And obviously, I conceded that I misanswered the question then because you were looking for an actual shape.
No, you.
The shape of.
You were looking for the shape because you asked what's the shape of the Earth.
No, you were asking for the shape because you asked what's the shape of the universe.
Bro.
You did ask what the shape of the universe
I'm helping you reveal how retarded your question is, basically.
What was my question?
What is the shape of the Earth?
That was my question. When?
This is live recorded, dude. Should we play it back for you?
Then. Please.
Yeah. All right, we're going to play it back and we're just going to pop you on mute. After that. Yeah, all right, cool. How do you forget what you just said? How am I remembering your own words for you?
I don't know why you're putting words in my mouth. That is weird.
Oh, it's live recorded, but all right. Give me 1 second.
Hey guys, it's Matt.
What's up, Max? What's up, like, dude? Are you trying to gaslight us or something? You asked what the shape of the Earth is.
Did I?
I'm pretty sure you did.
Yeah.
I saw somebody else talking.
I thought it was someone else.
He absolutely did. I just want to see if something's going to happen once he hears this
It
recording.
actually wasn't him, it was me. And I asked that question and I got a complete non-answer. And that's okay.
I said he wants you to draw a flat. Remember that he wants you to draw the shape flat so that we can describe it to you.
That's what he said.
After I was asked what the shape of the universe was.
Draw that for us. You said it's flat. Draw it the shape of flat.
I told you exactly
I think the universe is a sphere too. Like, if the start of the universe was a big ass explosion, explosions don't travel on a fucking 2D plane.
Well,
they expand in all directions.
No, you got bendy space time flattening everything out.
I ain't never seen no bendy space time in my life.
I said it's flat.
Yeah, me either.
Relative to convex or concave. This is probably out of like the scope of what we're talking about.
Relativeness to flat, not you don't base flat off that. Flat is flat. You start with
we're looking
flat,
at the universe for non-Euclidean geometry, and that would be convex or concave geometry. They were looking for it throughout the space, and they only found Euclidean geometry.
Stop reading chatbot.
It's not a chatbot. I just remember the word.
Maybe he is a chatbot. Maybe that's the problem.
I was chatbots before chatbots, and I think they usurped me, bro. I hate it. They usurped me from my stance.
What?
He's feeding our audio right into Chat GPT.
No, I'm. Can I do that?
We've had people do that.
That's awesome.
We had a guy that was turning everybody's speech into text in real time.
That's so cool.
He accidentally shared his screen and showed it.
What chat would you use that in? If you went into one of the chats on the server, which one would you want to use that in the most?
Oh, none.
We're not going to tell you how to do the cool shit.
Tactics.
Dude, I don't want no permanent
any dickhead tactics. You don't need to do that.
I don't do the dickhead.
We're not going to tell you how to do dumb shit. Do you understand that? We're not going to tell you how to do it.
I understand that you don't trust me, yes, and that's fair not to trust me.
Oh, look, this is a crazy anti-flat earther, globe apologist that was trying to refute flat Earth. He was in here for months, and kept failing. I actually think he teaches at a university, but what he was doing, he was taking people talking, and he was turning that into text so that he could go over the text and look for holes in our argument so he could come back with a better one.
That's so sad, bro.
And the only reason it was discovered is because he shared his screen, and then when I clicked on it, I saw my name pop up when I was talking, and the words I was saying was text that was appearing on his screen in real time.
That's insane, bro. That's a great catch, bro. Imagine you didn't catch him doing that. You just didn't know why he was being weird for so long.
Yeah, I mean...
That's so crazy.
Yeah,
that's such a cool story.
Wait, did Krennic say that flat was a shape, or was that someone else?
I didn't say flat was a shape.
Well, I don't know why you responded when the other guy chimed in. Did he leave? The other guy left anyway.
Well, he's saying flat isn't a shape. Just let him do his,
Yeah, it's fine.
Let's say he
spoke up and responded to him. He then Koreanix responded for some weird reason. But all right.
I thought it was me he was talking about because we did go over the draw flat. I said it would be a line and stuff like that. I was just saying if you're telling me to tell you the shape of the universe, I misunderstood that as describing the shape rather than giving the shape.
Well, the question was for the other guy who spoke up and said, "What shape do we live on?" So I was asking him, but then you responded. So.
Oh, I didn't know that. It doesn't clock to me, but if you say so.
I mean, it's weird. We haven't talked about flat Earth in a long time now. I mean, honestly, we haven't.
That's true.
So how could you definitively prove the Earth is a globe or not, or flat or not?
Well, to definitively prove either of those, you would have to go away from the Earth and see it in a different.
See it, really? I don't know why you guys say that. I really don't. I don't know why you people think I'll just look at it. Do you think if you were you're gonna do a peer-reviewed paper and they're like, well, how did you figure out what that was? I just looked at it. Do you think that would fly?
I thought it was implied that we use our eyes in a certain way.
Yeah, we do, but be able to tell. If you build, but if you build something, you can't figure out the shape of the pieces of the house by just eyeballing the pieces.
But I can see that the house is house-shaped by seeing it from an outside.
Oh my god.
Well, that depends on the angle you look at it, right? So if you're directly above the house, it'll look like a square, right?
Yeah, what if it's a crooked house? What if it looks like a Doctor Who house where it's all crooked? That's still house shape.
If I go up straight from the center, then it would have the same view if it was a sphere or flat. Or a disc.
You're stuck. You're stuck.
Well, dude, what I'm saying is that you couldn't tell just by simply looking at it. That would be very subjective.
Well, it depends on the shape. If it can be different things, if there's different possibilities.
Well, what if you saw a big circle, right? And what if the Earth is a
that's
circle?
what I just. Yeah. What if I saw a disc? What if I saw that there was a flat on top, and I saw that there was a thing coming? I don't know if it just extends off into infinity behind it. I can't tell, but I guess see it from a different angle, right? If I just add another angle, it'd be good.
So what if you're the radius away? Whatever circle you're looking at, what if you're the radius of that circle away? And you look at it from different angles. Guess what? It'll still look like a circle.
when I said that I was going to go away from the Earth, I meant far enough so that all of the Earth is within my field of view.
Yes. And if you're the radius value away of a circle, right, the distance, no matter where you are, the angle subtended by that circle, it's always the same. And it will always look like a circle from every angle.
I mean, yeah, I agree.
Okay. So it would be a disc, but you, because you're looking at a bunch of different angles, would reach the conclusion it's a globe.
Well, if it's a disc at a certain angle, it'll look like a line.
Yeah, I said radius distance away. Yeah, if you're looking at it edge on, like, is that what you're planning on doing? Looking at it edge on?
Well, if it's, I gotta get different angles. I would hope that I can get at least 3 to see, dimensionally. And
So you think it's possible to see an Earth disk?
if the Earth's a disc, then yes.
So we think Earth is a disk then? Is that right?
Not at all. I only brought up disc because I thought of the different, it can be a disc or a sphere if you go up from the center. And then he said a radius away, and I think that's supposed to be.
There's only one angle, but you'd have to look at it edge on to see it. Was it every other angle other than the freaking basically zero angle? It would look like a sphere as long as you're the radius distance.
It would look like an oval sometimes.
As long as you're the radius distance away from the center. This is you could prove this.
If I'm a radius distance away.
Hold on, dude. You could prove this, dude. There's a mathematical proof for this. You could prove that this is the case.
I believe you, but I'm not going a radius distance away. I'm trying to get further.
Okay. How do you know? How do you know you're further?
Because of the relative size in my vision.
Dude, that doesn't really help you.
I can experiment with both multiple different 3D printed shapes of possibilities of the Earth, and I can experiment.
Where did a 3D printer come into this? Like, what the fuck?
Just a way to get shapes. You want me to find natural rocks that are a donut?
But what's the one you experience in reality? What's the only one you measure and experience in reality, though?
What do you mean between
the
globe?
The whole point of this is that it's subjective. Everything you're saying is, I'll just look at it. It's subjective.
It would be from my perspective, yeah. But
subjective
to a scientific field for other people to check. But it's just for me to know, right? It's not to prove it to anyone but myself.
Okay, well, you're just going to pile up subjective experiences that is going. But you can prove it to yourself. That's why I asked you. Like, it was kind of loaded, but that's why I said, how could you prove it definitively? Going up high and looking at it does not prove it definitively.
Right. Oh, okay. I misunderstood.
It would prove it to you.
Yeah, you can never prove it definitively.
Well, you can. Well, you can because we have a true dichotomy, right? Either the surface of the Earth is curving, in which case it can't be a ball. You can eliminate ball by just measuring that one property. Its existence. It either exists or don't.
Wait, I don't think that's how true dichotomy works here.
Well, can you have a sphere that's flat?
You can have sphere that is flat at certain points.
No, you can't, dude.
What the fuck? How many flats make a sphere?
Zero. And at what point? Yeah, he said it. He said zero. At what point do we identify this?
Yeah, zero.
Mental gymnastics. What the fuck?
Yeah, but in a flat plane, there's also zero flats.
Okay, so the property of a sphere is that it's equidistant from the center, right? So no line can be equidistant from a single point.
No lines. I mean, maybe some.
A line. If you drew a line and a point, every point on that line can't be equidistant from that freaking point, right? That is a property of a circle or a sphere in 3 dimensions, right? So this property is a dichotomy.
No, because it's not about if it's a sphere or not. It's about if there's curvature due to the fact it's something like a sphere.
Circular reasoning, then.
Sure.
Yeah, so you use 6 words to say the same thing Indio just said.
Yeah, we can figure out sphere or flat just by measuring the surface. We only need to know the surface properties. That's the point I'm making. We don't need to do anything
But
convoluted.
we need to know every single surface's properties.
We need to measure, say if we measure the water and the water's all connected and water shares the same property and we measure it flat and most of the surface of the Earth is water, then the Earth can't be a sphere because you can't have a 51% flat sphere, dude.
Yeah, but that's good deduction, but the things you assume to be true aren't true.
What am I assuming to be true?
That the water has the same properties.
That water has the same connected bodies of water. You think they have different properties? That they curve someplace, they're flat in another place?
Yes.
Absolutely. Right back to square zero, it seems, from like 2 hours ago. He hasn't given up.
Yeah, what part of your experience tells you that water doesn't have the same
part of anything tells you that, dude.
Tectonic plates can tell you that.
Well,
tectonic plates have to do with water?
Wow.
No, they create ripples throughout the water that give it a curvature.
Hold on, let's just end this shit because now you're going to Bevite retardation. Does flat exist?
Mm-hmm.
Is anything flat?
No.
Anything? Nothing. Okay, then we just end this. Why are you even here if you don't think anything's flat whatsoever?
Exactly.
Because I thought we were talking about like a generalized shape.
Can't admit to anything.
Yeah, you're the one making the pedantic argument like there's waves, so it can't be flat, dude.
He said tectonic plates have ripples on top of the water. I think he's trying to say.
Earlier, Old Hall said something about the fish jumping out. Shut up! Earlier, Old Hall said something about the fish jumping out of the water, and he said that was curvature also. So he's clearly a dumbass.
No. The problem is he said that it's either curved or flat, and I was like, well, no, right? Like,
that's a true dichotomy. That's a true dichotomy.
Dichotomy, exactly. It's not, is what I'm saying. And
what's the third option? What's the third option?
It's homogeneously different based on your location.
What?
The hell does that even mean?
It means that in some places it's flat, in some places it's convex, in some places it's concave, which is
so if I measure someplace flat, when I move, it's not flat anymore?
Well, if you're on the top of one mountain and you see a mountain away from you,
he's talking about topography, this dumbass. Oh my god.
Yeah, topography.
Yeah,
exactly.
Listen, dumbass. What if I'm at sea level?
If you're at sea level, even what's around you can change the shape. We're talking about the shape of the Earth. Are we also going to?
Yeah, I measure the water over water and measure.
And we're talking about the macroscopic shape. At the macroscopic level, flat or curved, dude.
Yeah, dude, I already explained this to you earlier, remember? I remember we had this exact discussion, and I said, what we're talking about is Earth curvature, not the curve of a wave or some shit. You already agreed.
You absolutely did, Cyclone. Yes.
So we don't need to retread this fired attempt at a rebuttal to there being...
We actually never got a concession from him. That's why I'm retreading this, dude, because he's in like skipping rope, double dutching, doing mental gymnastics to avoid this. And that's why I went back to it. And it's just really, it's, very ironic that Cyclone, you come back right into the place you left at. And we're still...
No, I'm feeling like it's deja vu. I'm like, what the fuck is going on?
No, I'm feeling the same thing. I was trying to explain the reason I brought it up.
Because it definitively answers the question. That's why we're on it.
Yeah, but there isn't a way to definitively define the question for more reasons than the thing that I just said about it being
okay, so if the surface of the entire Earth is flat, it can still be a sphere.
Well, depending on your scale and what you've defined flat as in an experiment, yeah.
He brings experiment into it again.
Depends what you mean. What the meaning of is, dude. Like Bill Clinton, it would be jealous.
Just saying words.
This isn't just saying words.
It's something weird.
When you're doing an experiment,
not
you can
uneducated.
make the model work no matter what, as long as you use the right conclusion
Dude, listen to what he just said. If the entire surface of the Earth is flat, can it be a ball? He said yes. Dude, you're not uneducated.
Well, I'm going from the perspective of a human being, man. Like, if I'm a human being, I have decided that the entire Earth is flat wherever I measure.
No. He's saying if the surface of the Earth is flat, can it be a ball? He didn't say from your perspective if you see it as flat. He said if the surface of the Earth is flat.
If every surface of the Earth is flat, then it would not be a ball. That'd be right. Then.
Correct.
Every surface.
And even if you measure
flat Earth,
that doesn't mean
you're even trying to qualify that, but I get it. It's your called this.
Every surface? What if like 51% of the surfaces are flat? Is it still a ball?
Well, I'm trying to imagine what that looks like.
Yeah, you would have to imagine. Yeah, you would have to imagine.
Well,
yeah, we know you want to imagine. That's what you've been doing. That's what you've been doing the whole time you've been here, Krenix, is imagine. So what if 71% of the Earth is flat? Can it still be a ball?
Well, no, it wouldn't. There wouldn't be enough material that's bending.
Okay, welcome to flat Earth.
That doesn't mean I'm flat Earth. It just means that if everything's flat, it would
71% is water. So yeah, it's flat. We measure it that way. We practically use it that way. Everyone does.
Just because you measure a surface as flat, it depends on how you define flat. That's why I said what I said. It does not depend on how you define your
You have to redefine words because he's backed into a corner. And
you have to define words because they don't mean anything with that definition.
Chill. I was just about to give you a compliment. Okay, so far you've been pretty chill. You've been respectful and polite, so we appreciate that. So let's give him some grace, guys. I mean, I've not heard the whole conversation, but let's give him some space. Obviously, there's some cocktails there that he's trying to work himself around. But yeah, I mean, still continue the conversation, but just keep in mind he's not being belligerent, so he could be chill.
His struggle is inside him. His struggle is inside himself, dude. Certainly.
Yeah. Krenix, what was your rebuttal to that? Just because you measured what I couldn't hear.
So it was what I had said before, which is that it depends on how you define flat, and how you measure it. Because if I have a sphere and something is microscopic on it, and you define flat as this level thing in front of you, you created a thing that's like 5 meters long, it seeks level, right? You place it down and it is perfect, both corners touch the surface. You just have to get small enough for that to be true on a sphere. So if the globe was a sphere, even if you measure flat in different areas, it's not going to reflect the actual shape unless you get long enough. And
so you can't use your logic like he tried to do for you and realize that 71% of the world is water that measures flat and equate that to no flat surfaces on the globe. So the Earth must be flat. You can't do that. You can't use that simple logic.
Hold on. What we need to address here is the definition of flat, because that seems to be where he's getting confused potentially. Do you think flat can mean curved?
Yes, he said it. He said it.
At a certain perspective, they are not distinguishable.
Right. So see, this is the problem. We're just gonna. He's gonna completely not understand anything if he thinks flat can be curved.
Yeah, like I said, we have to redefine words.
Yeah, well, this is a problem. You keep saying from a certain perspective. We're not talking about looking at it. We're talking about measuring it. That's
well,
objective.
if you measure it, you get the curve.
Also, when you're imagining.
Okay, why do you say that?
Because of how nautical science works.
Because nautical science.
What science is that?
New branch.
Science that led to inventions like the sextant.
Like when you grab onto a turtle.
Just falling out
like
your
when you
mouth.
grab onto a turtle and you let the turtle swim and you just glide along behind it. I think that's what he's talking about.
That nautical science.
Okay. So what does the sextant measure about the Earth?
Is it not? It does not. I don't know. But I thought.
And why are you bringing it up?
You hold it up. Because it's a science that has to do with.
Doesn't know what flat is.
It's kind of a faith. It's a faith reasoning. It's that ships
it's just such a good answer to hear, bro.
The Earth
nice to hear.
In
you don't know, just say, I don't know.
And the units, right? I don't.
Yeah, you're digging yourself a hole.
You can't say I don't know.
It's fine, guys. It's fine to let him say I don't know. That's a good response. If you don't know, you should say I don't know. But then don't be like, but I do think, and then go on to argue again. Be like,
for 3 hours he hasn't said I don't know one time.
That's definitely not true. That is definitely a lie. Or not a lie, but misremembering. I have said I don't know multiple times.
I don't know why you think the measures curvature. That's really what that's boggling my mind. Why do you think a sextant's measuring curvature of the Earth's surface?
I never claimed that.
Okay. You said it's curved over long distances. I said, how do you know that? I talked about objective measurements, right? We can measure the Earth, and it measures flat. And you're like, no, it measures curve. And I said, how do they do that? And you said with a sextant. That implies.
I did not say with a sextant. You said, how do I know that? And I said, because of nautical sciences. And someone said, what is the nautical sciences? And I said, it's the stuff that led to inventions like the sextant and then we kept talking.
Who has measured Earth curve? Good. When, where, with what instrument?
Names.
Yeah, with what instrument?
LiDAR's one.
They measured Earth curve with LiDAR.
Now, are you sure about that?
Are you really saying that?
Words are just slipping
We're
out,
talking
apparently.
about measuring, not definitively making it, right? They used LiDAR and that measured it.
Okay, how does LiDAR work?
I really want you to
LiDAR works a lot like you just bounce light, but it's more than that. It's a certain type
Well,
of...
remember, I asked you for this measurement. I asked you for this earlier, and you didn't send anything. So, have you found something now, and it's LiDAR? Is that what you're saying? Or are you just kind of
something that
saying
does what? That measures the surface of the Earth?
Actually measures curvature.
Yeah, I sent that in.
LiDAR does not measure curvature, dude, at all.
It can, but it's not going to definitively tell you curvature.
No,
it can.
They don't even model it to measure curvature at all.
When you get the entire mapping of the surface under the water, you're able to...
Yeah, what does that got to do with LiDAR? LiDAR don't work underwater.
LiDAR does work underwater.
LiDAR's infrared. Does not work underwater.
So he just doesn't know what he's talking about then?
LiDAR goes through heat. What are you talking about?
Yeah, it doesn't work underwater.
Water. It doesn't go through water. Water absorbs that wavelength.
Does it?
Yeah, it does.
So did we just establish that he doesn't know what he's talking about?
Now, you could say radar, but then you have another problem, or sonar, and you have another problem because they have these things under the ocean called abyssal plains. Abyssal plain. Most of the ocean underneath the water is a giant plain.
Yeah, flat.
I mean, I'm seeing them using LiDAR to get coastal maps, to get, like, continental shelf readings of the entire surface under.
Yeah, I think you're mistaking LiDAR for another technology.
No, it's LiDAR. It's just
okay, post it.
Are they measuring the ocean surface, or are they measuring underwater?
The surface under it.
Post it.
Yeah, I need to see that. Dude.
Hey, what's up, guys? Is the Earth still a pancake? Question of the day.
Never was, never will be.
Oh, so it's not flat. Good. Thank you.
Well, no, that's a false.
Yeah, he had to just say that, a drive-by.
Cope of the day.
Copium.
That was a quick cope. Actually, they measure it flatter than that.
Yep. NOAA says that the abyssal plains are they're the flattest parts of Earth.
Trace found it. They use water penetrating green light to measure seafloor and river.
Yeah, you just copied that out from Drace.
No, this is what I was thinking of. I was really imagining.
Yeah, but LiDAR is not green light, brother.
Diagram.
LiDAR is infrared.
No, it's not in this case. It's not always infrared.
LiDAR is always infrared. That's what LiDAR stands for. It's an acronym.
I don't know what you're talking about.
LiDAR is an acronym.
We know.
Yeah, I know it's an acronym, but it doesn't use infrared in the case of barometric LiDAR.
Yes, it does. You literally read it in my source. It uses a near-infrared laser to map the land. However, they have a specific type that used to try to map the sea floor. However, that doesn't show any curvature.
It does show the landscape of the sea floor. And if you can...
Yeah, which is a plateau, dumbass, or flat.
The continental shelves, yes, but not the seafloor.
The seafloor are mostly abyssal plains. What are you not getting about this?
Yeah, there's no curvature at the bottom there.
If it's a plane, if it's a long plane, then there would be. Unless it's just so non-homogeneous.
Yeah, it's flat.
Yeah, if it's flat, then you would see the curvature using LiDAR.
Yeah, you don't see any curvature.
If it were flat, you would see the curvature? What, sir?
Well, like we've already established, it can seem flat and be curved at the same time.
Oh my God! Here's this flat can be curved at the same time again.
Now it's not measured curved; it's just seen curved.
If you can, I feel like it's a lack of understanding of what I mean.
No, I'm going to get a clip of it. We understand perfectly. You think flat can be curved. You just said
exactly. Yes.
Yeah, I'm going to get a clip of it. We're going to share that through all of the... I'm going to clip it myself.
Can you explain in layman's terms how flat can be curved?
I have tried multiple times and I will again. It is perspective.
So it's not measurable, it's not real, it's just apparent?
No, it is measurable, but it depends on how far your data reaches.
So then can you show us the data that's actually measured it? That's what this whole conversation has been about.
Yeah, I've sent an article earlier.
Yeah, we're not talking about looking now. See, you're confusing projected perspective geometry with orthographic, absolute values, right? So, like, when we look at things, we only see things in relative angles. We can't tell distance or size, right, from just looking at things.
Angles, and you've created a context.
Well, you need a priori knowledge of size or distance. You need prior knowledge.
If you can compare it to your own body size, touch it, and then go away from it, does it count?
Well, yeah, because then you know a size, right? You know your own body size. We're not talking about looking at things, dude. We're not talking about looking at it and saying, does it look flat? Does it look curved? We're not talking about that.
Yeah, but it's
if I have a line of sight, right?
Curved.
No, it's not negligible.
Curved.
It's not negligible. It's 8 inches from our. It's not. It's not what the goal predicts. That's not what the goal predicts.
That in certain scales it is negligible, and in higher scales it is more significant.
That's not what the goal predicts, bro. You can keep saying it, but the goal predicts 8 inches per mile squared.
It's not. Go ahead and explain.
8 inches per mile squared.
8 inches per mile squared.
That's right. So in 10 miles, the drop is 66 feet.
10 miles?
Because to say, yes, there's curvature, then you have to measure it. And you can't measure it because it can't be horizontal. You see? Can you see that, ladies and gentlemen? Once again, he's gone silent. And when he comes back to talk, he'll be talking the other way again because he's embarrassed. This is an embarrassing situation for him. And remember, he said that the oblate is it's not oval, because he couldn't give us an image of that, because that would be a substantial amount of oblateness there, okay? And substantially less than a spherical ball. But he said, no, it's not oval. I misspoke. I made a mistake. It's only slightly oblate. That means it's almost a spherical ball circle. That's what that means, you see. And then when we ask him, is there or is it a block? We get silence, ladies and gentlemen. So as you can see, I'm not wrong. The only reason why, as I've been accused of being aggressive, I'm not being aggressive. I'm being astute and we're being forceful here. We have to press the truth home. When you have somebody evading and slippering around and not refusing to answer questions properly, pushing out misinformation, then you have to be a little bit, mind you. It's necessary in order to get the conversation moving and get the man to adhere to integrity, because he was moving well away from it. He's saying the plane doesn't have to follow the curvature of the earth. Well, that's ridiculous. Okay? When you're living in your neighborhood and you want to get somewhere, you have to make lefts and right turns. You have to. Otherwise, you're not going to get to your destination. Whether you're walking, cycling, or riding a motorbike, or driving a car or a truck. You can't just go anywhere you like and drive through people's houses, through mountains. You have to follow the routes. So if you're an oblate spheroid, you have to follow the curvature. Okay? You must follow that. And finding that curvature. Yeah. We're not able to measure it. Yes, please go ahead. You're welcome, of course.
Yeah, I just want to say that it is possible to prove the curvature of the Earth by calculating the altitude of the sun. So there is a website called SunCalc that is used to calculate the altitude in different places.
Yeah, he's right. Now, ladies,
and it uses.
Yeah, go ahead. Yeah, go ahead, please.
Yeah, so it's this website assumes that the Earth is a sphere. So it makes this assumption, and it enables you to calculate the altitude in different places of the Earth. So you can actually go outside and test it yourself. You can use a stick and calculate the altitude by. There's a simple formula that you can use to calculate, and you will see that the calculations in SunCalc, the calculations in SunCalc actually are the same as the ones you do yourself outside of your house.
Okay, thank you very much. Now, ladies and gentlemen, the problem we have here is that we have the maps in place. He's introduced us to a new one, and we thank him for that because that's an extra tool we can use to curvature. Now we take the instruments and the mathematics to nature, and we're finding horizontality. That's what we're telling you. We're taking maps and we're actually going out into nature, and we're not finding that curvature. We're finding extended horizontality. We're not finding curvature. Extension of horizontality wherever we look with the maps. So if we used his app and his calculations and then transfer that onto the surface of the Earth, we're going to find extended horizontality. Because we're doing that already. That's what we're finding. And we're using better technology these days, like the in-flight telemetry data from the inside of an aeroplane that records the motion and everything else about that aircraft. And it's not flying in a curved trajectory, which it would need to do if you're living on the globe. Remember, you can't ignore that. If it's curving, you must follow the curve. That's not my law. That's God's law and the law of a spherical ball, the laws of nature. So it's not the Gene CBR1's law. That's the law of life. Okay, the law of the life we're living.
Yeah,
if you're on a ball, if you're on a slight oblate spheroid, only slight, that means it's almost circular. That means it has curvature. It means you must experience it through the flight. When you take a car and you turn left, everybody moves to the right. So you're feeling that turn as the car is turning. When the car is turning to the right now, everybody's moving to the left because you're feeling that turn as you turn. You see, that's nature at work there. Okay? So flying through a ball Earth for 9.5 hours over 90 degrees, 740.47 miles of curvature over a distance of 6,000 miles, you must feel that curvature of 90 degrees.
Yeah.
Okay.
I don't understand.
So, ladies and gentlemen, we can have as many apps as we like and as many mathematical formulas as we like, but then we have to take those numbers and put it into the physical world so we can actually feel it. We must feel the curvature. It's physical. Physics. Physical.
Yeah, but what does that mean? What does feeling the curvature mean? I mean,
okay, I'll give you what it means, ladies and gentlemen.
Big enough sphere, it will.
Yeah, yes, I can explain that one for you quite well. Ladies and gentlemen, I'm going to do the biggest roller coaster ride in Japan, okay? Takes a little while to go up. So now you're going up, ladies. To a severe angle now. So already I'm noticing something already. My body is telling me I'm not horizontal. Click, 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 click. I'm very nervous now. Okay, because I haven't got to the top yet. Click, 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 click. I'm seeing the top of skyscraper buildings. I'm now seeing the top of buildings here, the high-rise buildings. Click, 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 click. I'm still going up. People are looking very small. Click, 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 click. I look down. It's a long way to where the people are queuing up. Click, 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 click. I'm still going up. Click, 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 click. Okay, so I've noticed it. Now we get to the top. The clicks have gone. It's gone quiet now, and now I'm rolling over the top, and now I'm dropping down like a stone. Can you see? I'm feeling that. I am feeling it. So I felt the click going up. I felt it rolling over the crown of the crest of that hump. I'm feeling myself go down. Now we're going to do loop to loop, ladies and gentlemen. So we're rushing through. We're doing left, right, barrel roll, and now we're into a loop to loop. I feel all that, ladies and gentlemen. So feeling is very important. That's your senses. Without it, if you didn't have any senses, you would have many accidents. You don't know where you are. You'd be lost. So you must feel the curvature of the earth through flight over 9.5 hours, 6,000 mile distance, 3,740.47 miles of curvature over a 90 degree on that globe ball. Okay? You must feel it. It's impossible not to feel it. If my spirit level app is registering it, it must register on my body as well. We came first. We made the bubble app. We made the spirit level through our senses so we can make sure things are built correctly and horizontal. We must feel it, ladies and gentlemen. That is my case for the globe. And the young man here who's saying you can't feel it because it's ever so slight. Well, I'll leave that for you. I don't accept that. Any questions? Please ask.
Yes, I just want to understand. So you're saying that in the flight, when you're flying, it must be that you feel the curvature of the earth. You can't just see it flat.
You can't, because you're on a ball that is curving at an exponential rate. Okay? It's impossible not to encounter the curvature. Impossible.
But why do you say that? Do you have proof of this? Because
it's clearly obvious.
Take a big enough earth.
Of course, you see, you didn't listen to any of the. You didn't listen to the roller coaster ride. You didn't listen to the car driving.
I listened to it, but you cannot.
Well, then, hold on.
You cannot compare.
Stop there, please. If you listened to it, do you understand it? Do you understand?
I actually do not understand how does a roller coaster ride relate with the curvature of the earth.
So you don't understand it.
How these things.
Okay, let's start again. You are driving the car with your family in the car, okay? You're driving at 60 miles an hour. You now want to turn through the 60 miles an hour. You're going to turn left, okay? You're going to turn left. What happens to the people in the car? Do they move to the right? Do a body weight shifts to the right, doesn't it? Your body weight. Doesn't it?
Yes, it does.
Right. So you're feeling that turn. You're feeling that turn. You see that? You're feeling it because your body weight's shifting now. You're feeling it. Okay? And if you turned right, what happens to the people in the car? They move to the left, don't they?
Yeah, I understand what you're saying.
Okay, so you understand.
I can say that.
Hang on a second.
Yes, I understand now.
Hang on a second, please. So you understand through a curved trajectory when you're turning around corners, you feel it and you know it. Yes?
Yes.
Okay. Then you have the aeroplane traveling 6,000 miles. That's almost 90 degrees of the globe ball that you think you live on. Okay? That means you must follow the curvature. The aeroplane doesn't follow the curvature at all. It flies horizontal all the way, level. It doesn't follow the curvature because it's not there. Okay? That's the laws of nature. It's not my law. So it's impossible that you're on a ball and you don't know it. It's totally impossible. It's such a distinctive shape. We use this spherical ball in ball bearings in engineering. Okay? If there's anything wrong, like any flat spot on a spherical ball, we take that and put it in the bucket. It's not good. It's rejected. It's not perfect. We melt it again and make another one. And then we use the perfect one. Okay? So if you have a ball, you must follow the curvature. Impossible not to be able to do that.
I understand what you're saying now.
Thank you.
But the curvature of the earth is ever so slight that you cannot feel it. You cannot compare the curvature.
I'm going to ask you one question. I'm going to ask you one question. Is 90 degrees curvature slight? 90 degrees.
What do you mean 90 degrees?
Then I'm going to ask you, is 180 degrees curvature slight? 180 degrees. Is that a slight curvature? And then I'm going to ask you finally, is 300 degrees, hang on, is 360 degrees curvature, is that slight? You see?
You don't understand how.
Excuse me, when you say slight, hang on a second, when you say, listen, when you say slight, it's incorrect, okay? 90 degrees is not slight, 180 degrees is not slight, and 360 degrees is not slight, it's a complete circle. So slight is not working here. Okay. Horizontal is not circular because there's no curvature there. Curvature is there on your ball. It's meant to be. Okay, because it's a ball shape, almost. Remember, the other guy said the O plate is only just slight, so it's almost perfect circle, almost, because he said it's only slight. It's not oval shape, because he hasn't got any images of that. So it's only slight, so that means it's circle almost. Okay, that means you must have a curvature. Okay, and you've never seen the curvature yourself. You've never measured the curvature yourself. You don't have a photograph yourself. There you are. You don't have it.
I just gave you a way to measure it.
No. You see, you don't give it to me. What you should have done is gone out and do it, photograph, do it, and bring it here.
Yes, I did it.
Well, show us, please.
I actually.
Can we see it, please? Can you show us, please? Show me, please.
Yes,
show us.
Yes, I can send you. I don't have it on me right now, but I swear to God,
okay. Well, then please bring it, ladies and gentlemen. He doesn't have it on him. That's fine. Okay, I can accept that. That's perfectly okay.
Yes,
can you please? But the thing is, hang on 1 second, please. 1 second. You knew you were coming here. You see, he knows he's coming. So the next time you come to this server, make sure you have the information that you said you've got. Now, other servers.
Yes, I have the information.
Yeah, you said that's what I'm asking you for. I'm asking you for your experiment, your observations. You said you did it, okay, and you've got the photographs. Have you got them?
No, but you can actually go outside.
No. Then you must go and do that. Excuse me. No, you must go and do that. We've already done that. That's why we're flat earthers. So you must go and do that and bring us the results of what you have done. Okay? That's what you must do. You must do that.
No, I'm just presenting the facts.
No, you're not presenting any facts. You're not presenting any facts because you haven't done anything.
It's actually a fact.
You're not presenting any fact. The word fact cannot mention here.
No. You can try.
No, you're not presenting fact. Excuse me. Excuse me. The fact would be that you've gone out with your methodology. You've measured, you've photographed, and you've seen it, and then you bring it here. That would be a fact when we see it. So there's no fact at the moment. So don't use the word fact. The fact is you need to go out there. You must go and do this.
Yes.
I say again, you must go and do this. Please. You must do this. Okay? That's how you've got to do it.
Yes, I'm saying.
Yeah.
Yeah, I understand. But you have to understand one thing. The fact that you can actually measure the altitude of the sun from anywhere on the earth and it will match this website. It's called SunCalc.
Unfortunately,
universally known.
Yeah,
if you find, yes. Let me just finish this.
Yeah,
if you find a way, if you find a calculation that is inaccurate or in any way you consider a mistake, you can go to the website and report it. You can actually post it on the internet and expose that the Earth is flat, and you can expose that SunCalc, the website that uses it assumes that the Earth is round, and it does the calculation.
Dude, it's not calculating the altitude of the sun. The altitude, it's calculating the angle of the sun depending on which area of the Earth you're standing in, right? Like the angle in the sky in degrees. So if the sun's at 30 degrees or something like that, or if it's at 14 degrees, like that's all it's calculating, right? Because the sun has for all of time just moves in specific paths. It's not predicting anything, right? It's just happened before. It's just the data, and that data has been translated into a global model, right? Into a global coordinate system. That's all. It's not predicting anything. It's a post-diction, not a prediction.
Thank you very much. Hang on a second, ladies and gentlemen. It is vital that you understand what was just told you there. that methodology is flawed because you don't look to the sun to know what's going down on the ground. The golden standard is to measure it. So in my methodology is we use the aeroplane to measure the curvature on the ground by saying to you that if the Earth is an oblate spheroid, within a given distance, there must be X amount of curvature. That means the plane will follow that curvature, and it doesn't. And then the information that's been recorded by the in-flight telemetry data supports that fact, that the plane flew horizontal, your senses register it, and if you're smart like me, you would have downloaded a Spirit Level app onto your phone because you can use them, and that also backs up what you experience. No curvature. The app that's been told to you is only post-dicting, as was just said, and it's an absolutely incorrect and substantially flawed methodology. It's totally inaccurate. The sun doesn't help us here. It's the ground. Okay, ladies and gentlemen, and you know that makes sense, doesn't it? You know that makes sense. You measure the surface because that's where you live. That's where you are. That's where you want to experience. Okay? Thank you.
Yeah,
we're doing a good job.
To say that.
Yeah, go ahead, please.
Yeah.
Go ahead.
I just want to say that the altitude is actually the angle between the sun and the horizon. So it's something really physical, and it's really can measure it. You can measure it right now. You can use just a stick and basic trigonometry, and you'll be able to measure it. It's not something
again, but you're not feeling it. Hang on a second. You're measuring angles, but you're not experiencing it. Ladies and gentlemen, measuring is one thing, but you must experience it in the physicality world. That's where we live. We don't live on straight lines, looking up. So that's what we're talking about. The physicality of it now. Yes, we've got the numbers in place. We've got the trigonometry. We've got the slide rule out, ladies and gentlemen. That's all there in black and white. Can we now extrapolate that into reality? Can we bring that into real life now? Let's go and feel the curvature of the Earth. See it physically, see it and measure it. Let's go. On the surface.
Yeah. So I want
dude, it's measuring
one thing.
Hold on a second, dude. It's giving you angles to the sun, right? That's all it's doing. That's not altitude. Like if I said what altitude does a commercial plane fly at, right? You're going to say 30,000, 40,000 feet altitude, right? That means the height that the plane is actually above the surface of the Earth, right? That's completely different than an elevation angle to the sun. The sun's not at that altitude. It's completely different meaning. It's just what happens every single day, but it's been plotted out into a spherical model. It's not proof of anything, right? If you look at how if you actually take those elevation angles, right, you'll need
horizontal
to use horizontals. Yep, exactly.
Yeah, you need a horizontal. You see, you need. Hang on a second, sir. 1 minute. I'll only be 5 seconds. Again, what my esteemed colleague has just informed you is that, ladies and gentlemen, in order to make those angles, you can't assume that the Earth is a ball because that's flawed already. You need, without a doubt, like you need air to breathe, a horizontal baseline. That's flat Earth. Without it, you can't get your angles. Okay, you must have a horizontal baseline. That would be the Earth, sea level, sea level, horizontal. Okay, young man, go ahead.
But I don't think you actually need a flat Earth because the horizon actually represents the normal of the sphere. So I also want to say one thing about the proof. It's not.
That's an assumption you said, yes,
idea.
You assumed.
No,
you assumed, sir.
No, it's not.
You made a baseless claim. You made an emotionally baseless claim, and it's an assumption at the same time.
No, that's not an assumption. That's just a mathematical thing.
Yeah, mathematics doesn't always prove reality. That's why we said, I agree. I give you your maths. You've got it on the paper. Can we now together take that mathematical formula and everything on the paper together, go and measure the curvature and photograph it and experience it? Can we go and do that now, please? Can we? Can we?
Yes, but the thing is that mathematics is a model of describing reality. So we use it to describe reality. It's not always
doing that. I'm sorry, sir. It's not always doing that. According to Nikola Tesla, this is Nikola. Hang on a minute. Do you know Nikola Tesla? This is what he said. he said that the mathematicians and the scientists are moving from one mathematical formula to the next, to the point where these formulas are no longer matching reality. So you can be very good at maths and good at making formulas, but these formulas may not match reality. That's why I said to the young man, can we take your mathematical formulas and let's walk together and measure and photograph? So I want you to do that. I want you to take your mathematical formulas and photograph the curvature of the Earth that you measured. Okay? That's what you do. That's physics. That's proving that your maths is correct. Go and do that. We've done that. That's why we're flat Earth.
Jin, this seems like a good moment to actually take it back to the radius value and validating that radius value, which is the core variable that must be there for this model that he's talking about to exist. So do you have any evidence of the 3959 mile radius that is the backbone of your entire globe model that you're talking about, right? Essentially proof of Earth curvature, right? Validation of the radius value. So let's maybe try to tell us what evidence do you have throughout all of history of validation of this radius value?
Yeah, and by the way, are you talking about physical? Because they'll have numbers, they can give us, they'll throw numbers at us all the time. Are you asking for the physical aspect? Are you?
This is exactly what I'm asking for, right? So they claim, the mathematics claims that it matches reality. Now we need to see that the actual claim matches up with reality. So we need to see something empirical, something practical demonstrated in reality. And you can pick anyone throughout all of history as your evidence.
Yeah, there we are. Okay?
Yes. Okay, yeah, I just want, I'm going to try to do this, so please just don't interrupt me. I'll just finish it in a second. So the first thing you have to do to prove the curvature of the Earth is that the first thing is calculate the altitude of the sun, which is the angle between the horizon line and the sun. So you calculate it at different places, you know? And the fact that the altitude is different in different places. For flat earthers, there's two possibilities. There's only one possibility. It is just that the sun is close. So you can use the altitude to calculate the height of the sun.
Incorrect.
You know? Because if the sun was...
No, that's incorrect. Because the sun, right, you're assuming that the sun that we're seeing in the sky is in a physical location. But that's not the case. We're seeing an apparent sun, right? So we can't use that that's why you can't use that to calculate the distance to the sun, right? If you're not assuming, you don't want to make assumptions. Now, what you're talking about is using angles, which are straight lines, right? You're talking about using 90-degree angles to measure the elevation angle to the sun. That requires a flat Earth to do that. Okay, you need to be able to actually validate the curvature, right? Correct. So you would have to use a tangent. Okay, so you would have to make assumptions that there is actually a curvature, right? A curved surface that tangent line is interacting with, right? To have that tangent to get that angle. So what you need to do is actually validate that there is curvature in the first place. Because what you're kind of talking about is the Eratosthenes method, in a way, right? You're having to assume, make a bunch of assumptions before you, and then you're doing your calculations based off those assumptions.
Yeah.
Right, that's
and
all.
One more, sorry to cut you off there. I thought you had finished. My bad. Please finish off. Sorry.
No, I have finished. I do have to mute up because I'm doing something.
Well, yeah, it's a very great interjection there. And that tangent line, by the way, ladies and gentlemen, that tangent line, you will notice, is a straight line. So you still need a straight line to get your tangent. You see, it's a failure all the way. So the man is assuming here again. That's why we've said to him that he needs to bring physical evidence now. Okay, we've given you that you've done the maths. Okay, you're taking your angles, even though you're assuming everything. Let's see if you can assume this curvature then. Bring the curvature to life with your assumptions, please. That's what you've got to do now. That's what you've got to do, because that's the only way you're going to debunk flat Earth. You've got to go out, measure, photograph, experience it, bring it to us, and then we can copy that and replicate. Go ahead.
He just did measure the flat Earth when he took an elevation angle to the sun.
Yeah, good joke. Thanks, mate. That's a good joke. Because he did. Are you having a good weekend? Good Sunday?
Yeah, it's not bad, thanks, mate.
Okay, well done. Yeah.
Is it Sunday for you too?
Oh yeah, of course it is. Yeah, it's what are we here? We are up to 9 o'clock in the evening here.
9 in the
Japan. Japan.
Wait.
Remember, I'm near you.
Oh
Time zone
yeah,
wise.
you're not far away. Yeah.
No, time
I'm only
zone
49.
wise.
Well, 50 minutes ahead.
That's right. Yeah. That's why I was asking if you're having a great Sunday. You see, because I knew where you were. You see. Yeah, so it's nice. I'm glad they come in, and I'm glad they are passionately trying to defend themselves, because with the passion, we're all emotionally attached to the things we have in our lives, okay? So the emotions are going to flow, and the listeners are going to be getting emotionally involved as well when they're listening, so they can see the to and fro. So it's good that we can actually clarify what they're doing wrong. That's very important, and they will resonate because they're doing the same thing themselves as well. Those who haven't measured, they're believing. You see, and believing is I did that for 48 years. Why? Because I trusted them. You see, and now I've learned that I should not have trusted them for 48 years. So that means a lesson that you can learn. Don't trust the scientists. Check that they're doing the right thing. Then you can trust them on that particular topic matter or situation. That's what I've learned. Don't trust the scientists, because I trusted them for 48 years and they've turned out to be incorrect regarding the shape of the earth and space travel, for example. So yeah, we're still here on the panel here, waiting for anyone to come up and speak their truth about the globe and try to prove it, or enjoy an exercise in English language. Have a look at a picture and talk about what the picture contains, and that's another way of learning about a language, especially English, through photographs, trying to describe what you see, etc., etc. And please don't be put off when we get a little stern. Sometimes we have to get a little stern when individuals are not following the integrity route. Just be honest. That's all. You know, a circle is a circle. Circumference means circle. So that means you have to go in a circular route, yeah? Horizontal is level. That means that's straight. If we're not going to be able to agree on that simple, clear, basic truth, we've got problems. You see? Right. Can't be having difficulties at the beginning. And we were told that it was an oval shape. Now that's a distinct shape that's substantially different from a spherical ball. But then he said, no, I haven't got any pictures on it. No, you know, he couldn't find a picture. Okay, you're hot micing now. Hot micing. So yeah, he couldn't produce that picture of the oval one. So then he went back to it's only a slight oblateness. So that's almost circular then. Right. And if that's almost circular, then there must be almost a circular motion, not a horizontal one. And that's where we are at the moment, ladies and gentlemen. We're waiting for any more questions from the individuals who are in the server here today. Hopefully they're enjoying themselves and learning at the same time. Yep. So we wait patiently here. Anyone? So it's currently 8 o'clock in the United States. Welcome. Welcome. Hi there. Please come in and good morning, good afternoon, good evening. Please don't hesitate to ask. We're here to address any questions you may have, any queries. If you want to practice a bit of English, we can do that as well. Put up an idea, maybe we can look at an image and then describe it, kind of thing. That's a good way of learning vocabulary in English language. But I was just going to say it's 1 o'clock in the UK now. It's 9 o'clock here in Japan, coming up for 9 p.m. and it's coming up for 1 p.m. in the afternoon in the UK. So that would make that in the East Coast, New York. Then West Coast would be what? 5 o'clock in the morning. So they're asleep in California and maybe just getting up. Maybe not getting up just yet. East Coast, sorry. New York and places like that. New York, Georgia, Florida. They're probably still asleep or maybe just getting up. California, they're still asleep. It's 5. So that's why it's a bit quiet here.
So just quickly, the last guy was claiming that SunCalc proves the globe, right? But
yeah,
if you actually look into it, right? Like, so SunCalc is just a tool that shows the sun's position, right? Any time of the day for any location on the Earth. So it shows it in like a graphic. So it doesn't actually use a globe model at all. It's just visualized in that way on the website. What it actually uses is the equation of time.
Yeah.
So it just basically takes like the speed and movement, right, that's already happened. So if you look up the equation of time, right, it says the equation of time corrects for the apparent difference between solar noon and clock noon throughout the year. It accounts for the analemma pattern the sun takes in the sky, the figure 8 pattern caused by 2 effects, the elliptical path of the sun as observed and the varying speeds of the sun across the sky, right? This correction is cyclical and predictable, meaning it can be plotted mathematically without needing a globe.
Yeah. I'm not satisfied with one quote that you said there, and that was varying speeds of the sun. Sun's only got one speed, hasn't it? Oh, no. It does appear to speed up when it's at the Tropical Cancer. Is that right? Capricorn, sorry.
Yeah, I think wouldn't it? Well, it's a different, depending on like what angle it's at in the sky. I think it's different locations in the Earth. Like, you know, Amish, right? He was saying that where he lives, when the sun's, you know, down lower on the horizon, it moves at like 6.5 degrees per hour. But when it's up high in the sky, it moves at 15. So yeah, it depends, you know.
Yeah.
It's apparent as well. It's not that it's moving at a different speed. It just appears to be, I think, something like that.
Yeah.
You know, just based on the angle, and then you got the, you know, the atmospheric conditions and all that sort of thing to take into account.
Oh, absolutely. Yeah. When you're looking up, because you're looking through that. So yeah. No, absolutely correct. Yeah. But yeah, you know, they're relying on these apps so much. Okay, even if the app is telling you that, but why don't you actually make sure that the app is correct? Go and check it. Otherwise, we're falling into the same situation as we fell in at school. They told us, and that's it. You know what I mean? No proof. No proof of the pudding. They keep telling us about the pudding, right, showing us the pudding bowl and the spoon and the pudding, but you don't get to eat the pudding, ladies and gentlemen. Wouldn't you like to eat the pudding as well, so you know it's a pudding? Exactly. Let's go and get the pudding now then.
Yeah, India is very good at debunking the SunCalc argument.
Oh, yeah. Well, yeah, India, yeah. He's very good at doing all of it.
Yeah, he is. Yeah, beast.
Yeah, exactly. Yeah, I thought he honoured me when he gave me the links to the Ulnus and the Apollo detectives. A lot of stuff coming out of there, and I think he's put that upon me to research and bring findings. So I thanked him for it every time, because it's forever giving. That's how I've learned about the vacuums. Of course, I haven't been there, but I've learned what should be happening and what does happen if you were to subject. Okay, and that's through this site, man. It's brilliant. So what I did, I might do a presentation and and dump some of that material here so you can all have a look and feed off of it, and because it is really interesting stuff. But the annoying thing is, though, they still go on like the Earth is a globe. You know what I mean? That's the annoying thing. They refer to Earth as a planet still moving through the universe. Scott Henderson knows a lot about vacuums and how the space travel can't happen, but he says from the best spacecraft ever as we're hurtling the universe. Very smooth, he says. You know what I mean? An American, Scott Henderson. Hello, welcome. Good morning, good afternoon, and good evening, wherever you are on the flat Earth. Jin CBR1 in, holding the fort at the moment. If anyone's got any questions, please feel free to ask.
In 10 miles, the drop of the Earth from your line of sight should be down 66
I found
feet.
it. I found the place where the crazy people go.
Yeah, you're trying to throw your body into gear.
I finally found it. This is where they go.
You want to get muted, Nephilim free, or you want to act cordial? Oh, too late.
So you just don't it doesn't seem like you understand what the globe geometry actually predicts. The curve of the Earth should be easily measurable. Easily.
I think that it is easily measurable.
Okay, so who measured it?
Multiple people all around. I sent an article.
You guys always say the same shit. There's lots of people. Like who? Oh, let me Google it. Oh, there's some sticks and shadows. It's not measuring the curve of the Earth, dude.
How is it not? Like, there's so many examples of people measuring the curvature of the Earth.
Okay, then give me one.
As long as you keep saying it and not presenting anything, then I guess.
Who measured drop over distance?
I feel like you guys know more about it than I do, though. So I feel like
we do.
You guys should tell me like the main examples and why they're wrong. Because I just
you could at the very least say you don't know. Can you enlighten us? Enlighten
why they're wrong.
At the very least.
Like,
I mean, yeah, that's what I'm saying.
Right?
I don't know off the top of my head like the main examples of people measuring the Earth. Could you enlighten me on them?
That's because nobody's ever done it. No one's ever measured drop over distance. That's what we're trying to tell you.
I know that, but you must have heard people who claim to that are very well known.
No, they don't.
How?
Because it's not a thing. You can't. If you have drop, then you don't have horizontal. Horizontal does not deviate from 0 degrees. It's that simple.
Yeah.
Okay. Welcome to Flat Earth. Yeah.
Your girlfriend. You can let it go, bro. It's okay.
Yeah, we did cover this. So they measure that there's no drop, and they say there's no drop, and you already talked about it because refraction picks it up to make it look flat. You understand? That's why I said it was ad hoc. Hey, I go to measure drop over distance. Oh shit, I didn't measure any drop over distance. There must be refraction making it perfectly look flat.
I think
every day of the week, no matter what body of water I go to, no matter who does the experiment, it's always the same. It just appears flat. Like the world is just a giant fucking optical illusion. It's really a globe, but it just appears flat because I live in a fucking giant lens, making everything just look flat.
That's not true. If I have more evidences of flatter surfaces than curvature, then I would believe more flatter surfaces. But I don't have that yet.
Evidence of curvature.
I have gotten a lot of stuff here to think about. I'm going to think about drop over distance. I still want the articles of the explanation.
It's still going to be hard, Krenix, when you don't understand that flat is straight and level. When you're saying flat can be curved, you still have some things to figure out.
Well, if something from 5 feet away stays 0 degrees, but from 7 feet away it starts to become 0.1 or something,
then it never was 0 degrees.
Right. But it's
okay, there it is.
Flat. Yeah.
You see how simple that is?
Yeah.
So if it's flat in one area, then it's going to be consistently flat.
Well, no.
It seems like he's subconsciously bringing up topography again.
If it's flat in one area, that means you measured it to tell, right? So if you measured it and it came out flat, that doesn't mean that everything will stay flat no matter what, because from 5 feet it was flat, and then from 7 feet it was 0.1 degrees.
What?
You know what refutes you? 0 degrees for everyone, everywhere at the ocean, at the water, at the surface. 0 degrees. Everyone has 0 degrees. It's our reference for the horizon. As long as you talk through everyone that starts talking, you will never hear them speaking.
I actually can listen while I talk, but go on.
Look, we have plenty of measurements of no drop over distance, and there are no globe measurements of drop over distance. That's what we're trying to tell you. The definitive
I feel like
evidence.
I've gotten all I need that I will use to process it all. Let me
give you an example of my favorite one, right? So the dude goes to a frozen lake. So the lake is completely frozen in the middle of the winter. He takes these road cones. All these road cones are the same size. He digs down through the snow, puts a road cone on the ice, drives a mile in his truck, puts another road cone down, drives another mile in his truck, puts another road cone down, drives another mile in his truck, puts a road cone down. He has a light, different color light on top of each of these road cones. He drives to 5 miles away from the first road cone. So now he has a road cone 5 miles, 6 miles, 7 miles, 8 miles away. He films these road cones from 6 inches off the ice. Now, each road cone, because they're farther away, should be dropped lower, right? Because of the curve of the Earth. The further it is away, the more down it should be, because the Earth's curving down from his perspective.
I mean, not always more down. They're on the top of the cone, right? The light?
Yeah.
It will
all the
go
lights
down
are the same
very
height.
near the end, but it'll be higher most of the time.
Okay, so the first road cone is supposed to be down 9 feet, and the last road cone is supposed to be down 27 feet. It's an exponential curve, dude.
I mean, I'd have to do math, actually. I'd have to do the actual math.
But I'll just give you the ending, because he films these, right? And they're all in a straight line on the horizon. A perfectly straight line. When each road cone, not only should he not see any of the road cone lights at all, he shouldn't see them at all. But they should each one should appear lower than the other.
Yeah, I'll hear you. I'll remember that. I need time to process this stuff. So I'm a head out of here. I already have the refraction index of CO2, but I want the article about that we talked about. The terrestrial, I guess, opacity or turbidity of the air.
I posted a while ago. I posted Southern Ocean Sailing Guide link and the screenshot of it, and I posted the cosmologist guy.
Okay. Let me find those.
It's probably way up, because it was like an hour and a half ago or something.
Yeah, I'm already up because I was looking for my article. I just search this chat. Can I do that? I don't think I can.
Yeah, I don't know if they let you search the guest voice chats.
Yeah.
We shouldn't even be a guest voice chat anymore, dude. We should have permanent status here.
Yeah, can somebody figure if that can happen, Indio?
All right, I got the guide.
I don't know, maybe Heretic can give a good word. Who knows? Just to kind of let somebody know, just, hey, man, we should be,
They probably got a vote on it, and some triggered mod will veto it.
Oh, cosmologist debate. Okay. Got them both. Okay. Thank you guys for talking with me. It was a really good time.
All right, man.
Bye con Dios.
All right, see it.
Dude, he was reminding me of Percent. He was so opportune.
Get your reps in today, Indio. You got like 2 pounds of flesh.
Dude, but like I took the same pound from the same place, man. Like I had to loop back around again.
You had to place it. You had the same pound of flesh you extracted. You put it back in and took it back out again.
Yeah, man.
At least he was quiet. He was quiet. He wasn't all like, he didn't get all angry or anything. But boy, he was. Wow, she just like making up some shit on top of shit on top of shit.
Yeah, it's like Chef Indio over here, man. We were at a barbecue, man. He's just like handing out like leg quarters and fucking steaks.
Yeah, man. I've been very busy lately, so I haven't really been on that much. I gotta like be very efficient when I come in here. Cook them fast, right? Just burn it on both sides, raw in the middle.
It sucks too, because you're probably listening in the back chat. Like, I can just imagine like rolling your eyes, like fucking hell, bro. Like,
Yeah, I listen on YouTube a lot, so it's hard sometimes. I have to shut it off sometimes. Like, oh my god, I gotta shut this up. I won't get nothing done. I'll be in there all day.
Oh, frick.
you got sulfur in here. Oh, you just left. A lot of drive-by globies too. CB here? What's up, CB? Just looking through the panel, man, everybody got their reps in today. I heard Drace, I heard Elbow, Flat Lloyd this morning. Flat Earth Ranger came through. Radwin, Sonny. I didn't hear much of Rayleigh, so.
Dude, I thought Stevie was going to hear that guy and frickin' smoke him, dude. Because he was saying, like, some ridiculous nonsense. I'm like, Stevie's going to get triggered and jump all over him. He kind of did.
Yeah, I think he mentioned, like, we're amoebas on a giant something or other. Did he say something? But that's what triggers Stevie. When they start talking about ants on the beach ball, he fucking hates that dude.
Yeah, it's freaking so dumb, man.
We're just too small. You can't detect if the Earth's curvature is there because we're just like amoebas.
Yeah. So what's funny about that is it like this is one of the things that, like, you have to understand who you're talking to. Something like that, when they say something like that, that gives you a window into their mind. Someone said that to them and they found that convincing. Someone said to them, it's like, we're ants on the beach ball, and they're like, that makes sense. Earth is a ball.
Oh, here he is.
Oh, hell no.
Yeah, he was saying that shit earlier, dude. You're probably busy doing something, but yeah, he said that we're like amoebas on a giant fucking. I don't know what he said, but yeah, it was.
Bruh. Incredible.
Yeah, flat means curved, by the way. I think Sonny's got a clip of that in the text.
Yeah, Sonny, you got that clip?
We're like gonorrhea on a testicle.
Bro!
Somebody needs to play that fucking shit right now.
Huh?
Yeah, flat does mean curved. Like, what the fuck? How long was he on? He must have been like, what, 2 hours? I know he was here for a while.
It's about 2 hours, yeah.
Good lord.
2 hours later.
Oh, that had to be Drace.
That was Drace, dude.
Oh, that guy that did a drive-by and said, "Was it still flat as a pancake?" Like, Kansas is.
And the guy was actually pretty good up until the point where Indio pointed out that is the shape of the Earth a scientific question, and that's where it just fucking went south, bro.
Dude, I knew he was capping, bro. I knew he was cap. I knew as soon as I said, "Is the shape of the Earth a scientific question?" That whole shtick that he was given, he didn't really believe that, and it just all fell apart. He was the same thing that all the people he was complaining about.
Yeah, you hold out hope, right? You hope that they don't think like that, and hopefully when that question comes around, I was like, man, this should make him or break him. If he sees through the question and says, yeah, that's not a scientific question, then there would have been some hope, but he fucking went right. He dove headfirst into the waterless, swimming pool.
He even held his nose on the way down.
I was like, cannonball, like, fucking hell, bro.
He fucking pancaked like Wile E. Coyote.
And then everything just came undone from that point. Like, flat beans curve, like fucking everything you could think of was where amoeba's on a fucking giant ball, or I don't know what the fuck. Like, his hair was on fire, bro. Like, that's what it was. Fucking hell.
Must defend the science. Defend the globe, defend the science. Globe and science, they go together hand in hand.
Oh my god.
And only moments before, dude, he was like, yeah, I hate those guys. Like, those guys, they don't know what they're talking about. And he just became one of those guys in real time. What the fuck?
Yes. Right as he was talking about it and laying it out and agreeing with, I think it was Indio he was talking to, he became that.
So, I don't see any hops in here. That guy last night, though, that was melting down, holy. That was something to listen to. The guy was having like a full-on, like, it wasn't terrible, but he was like literally spiraling. He's like, my brain is overheating. I don't know if I can do it. That was pretty funny to listen to. Was anyone else here for that, or Radwin was here? Literally got cooked. He was posting gifs in the chat of his brain steaming.
Yeah, I was there. I heard that he was like this.
Help! Help! Help me! Help! Yeah. It was like fairly.
That's pretty funny.
It wasn't like, fuck you guys, this is bullshit, blah, 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 blah. He was like, damn, you guys are actually cooking me. Like, am I a flat earther? Like, he was contemplating life.
That's what Krenix was doing a little bit.
Oh, we're dialed in right now.
Yeah, surgical even.
Mm-hmm.
You cut right through the bullshit, right?
Yep. I have an idea for an episode for tomorrow. I need to get with AI. Maybe do like how to like a master class on jumping on the VC, like from our side. I feel bad. Sort of, because last night Sasha was like, you guys were in the middle of cooking this guy, and Sasha was like, "So what is level?" And so I was like, "Put him on you."
Shut up, bitch!
It's so hard.
That was a unified shut up, bitch.
I felt kind of bad, but like I understood, but like, damn, that was funny as fuck though. I'm not gonna lie. But I think like just a master class, maybe AI could help run it. Not sitting here saying I'm the master at this or anything, but I think it would be cool to do a class on like how we do things in the VC, and maybe like if you want to jump on the mic, this is how some tips, some pro tips, advice, stuff like that. I think that could be fun. Like a lot of us are here anyway, and that type of show wouldn't require a globe earther to be in the room. And of course, if they do pop in, we can put all of our work to the test. But yeah, maybe like we could do a show tomorrow in 24/7. DC Masterclass run by AI or something like that if he's around. There's a lot of guys in here that could help give advice. There's a lot of people that are neither new, they don't speak a lot, or people who do speak a lot and could be, like curated.
I think language barrier is usually the biggest problem, I think.
Yeah, I know. Necros gets a lot of flack. Sasha gets cooked sometimes, but yeah, it could be helpful for some people. Dude, that was so funny last night, though. I'm not gonna lie. Like, we were in the middle of like a cooking session, and Sasha was like, "What is level?" And someone just said, "Put him on mute." And I looked down, he's server muted. Oh, I feel so bad, Sasha. Sorry, bro, if you're listening right now. Oh, I was dying laughing though. That was really fun. But I have advice. I have some good advice for stuff like that, and it could be helpful. Especially AI. He's usually pretty locked in. Bro doesn't mess around. So yeah, just keep your eyes out. Depending on if I'm busy with 304 tomorrow or not, TBD. And then
being sauced don't help the language barrier either. We have a couple of that, like they're a little inebriated. And the more inebriated they get, the more they revert to their native language. And like, dude, I ain't German. What are you talking about?
Oh. Yeah, don't let me cook a German in here. I'll be like, bro, where's your wiener schnitzel at?
Some of these guys, they come in a little on the weekend and they've been drinking a little much, and then the more they drink, the worse their English gets.
Yeah. Who are you thinking of, though? You feeling toxic?
Dude, I'm not.
Name names, bro. Be toxic.
Stick around, you'll find out. So what do you want to do tomorrow night?
I'm thinking we do a show in 24/7. We start an event like VC Masterclass or some type of, just like educational class where we get together and talk about tips on speaking on the mic or something like that. I don't know. You know, it can be helpful for people who don't talk at all and like what they would need to do if they want to like chime in, or for folks like Sasha or just anybody really. There's some people that really know what they're doing on the mic. I think like AI is really good at this, and he could parse out some good advice for people who want to talk. So I don't know, just like some event we could go over 24/7. Doesn't require gold card.
Yeah, dude. Key thing, I think, dude, I don't know if I always say it, but I say it enough. Like, key is listening, dude. Listening to what they say. They tell you a lot about themselves just by like I just brought up the example. If they make the ants in the beach ball argument, that means someone said that to them and it was convincing. That tells you that person doesn't have two brain cells that rub together.
Facts. Yeah, that's facts, bro.
What they tell you is the arguments that convince them that they found convincing. So when they're giving you their quote unquote cold proofs, they're really telling on themselves. You know how that goes, CB.
Yeah. Yeah, this is the kind of advice I'm talking about. This is exact right here. Because a lot of guys have been in here. It's like going to learn from a chess player. Like, okay, look, if they make this move, you make this move. And that kind of stuff could be really helpful. I'm thinking of like Flat Earth Ranger, for example. Like, bro, like I have a lot of what's the word? I love when people speak on the mic. I give props to people who want to chime in and stuff like that. So like, rewarding those types of behaviors and stuff like that. We also have Martin K that just joined.
Yeah, that's mostly for entertainment. I'm different. I've been a flat earther longer than most people, so I just like to listen to people, and sometimes I chime in. I've cooked before. I usually don't like to, but yeah.
I cooked before. Yeah. Well, like you and I have a similar. I feel like you and I do like a similar thing in here. And I enjoy it. I like it. So maybe teaching people what we do and how we operate, and then like AI is gonna have some stuff, and Sunny and everyone's got some advice to share for sure. So I think that would be cool to do a little masterclass on how we run the VC, or what's some tips on navigating in the VC, something like that. So just keep your eyes out. We might go back to 24/7 tomorrow and do a sesh. The last session we had over there was a lot of fun. Sorry if you guys missed it. That was a blast. It was good to be back in 24/7. Felt good.
I know we got to make that a habit, dude.
Yeah, I'm trying to get like 1 or 2 days over there a week. I think that would be good. Remind people that the place is still alive. Everyone gets their brooms out. We go dust the place off. That type of shit. The last show was fun. It was huge. There was a lot of people over there. I don't remember how big the panel got. It was definitely like 40 or something like that. A lot of people. Tons.
Thinking about starting the show there, like doing it out of the server.
We should definitely do it out of our server.
I don't know.
Yeah, we should definitely do it out of our server because we have full control over that. We can name the events. We can ping people. We can, it's our server. We do what we want.
I want to have it as a stage event. Like have the stage, you can do with the Discord, make it like a stage.
Yeah, the stages. Yeah, definitely. I love the stages idea. We need to turn that on.
Well, I think the initial problem with the stages was you have to agree to some fucked up terms of service.
Oh, really?
I think so. They might have changed it, but I thought that was the reason I didn't do it. That's also the reason. So, like, you have the regular terms of service, but when you be like a community server, and I think it also applies to the stages, that you have to agree to this other terms of service, like in addition to the regular one. That's how they get you, man. That's how they always get you. You agree into some other extra shit.
I didn't know that.
Well, I have actually experience with it in real life. So, in the computer industry, they try to do that crap. They'll give you the terms of service for something, and then they're like, well, hey, you're going to be our special we'll give you a sticker and a t-shirt, and you'll get some special perks and privileges if you agree to this little extra contract. And then if you break it, you didn't read the fine print, and now they're fining you and all sorts of other shit.
I see. Well, maybe we could take a second look at that, because I think the stage
I'll actually say what it was. Well, there was a computer company they were buying computers from big corporations when they were upgrading their computer systems, and they would resell them.